instantiation. Really complicated sounding words, but you need to understand what they mean so that you can talk to other programmers. You also need to learn about a language's data type. That is, what sort of data can a program hold? You can think of it as values. Just like in real life, we have different ways to represent values, like numbers, letters, and symbols. In programming, we have these data types to store information. And each programming language has different sort of data types. Next, we need to learn about actions. At the end of the day, all programming is a way for us to tell our machines, hey, store this data and then retrieve this data and perform some action on it. That's all it is, just using memory and performing some actions. So we're going to learn how to perform those actions. And then finally, we have to learn the best practices of each language. There's good ways of writing Python code, and then there's bad ways. So that when we build our applications, our programs, well, we don't have a leaning tower like this, but we have a solid structure and a solid program. So throughout the course, we're going to learn about these things. But keep this in mind. These 4 things are what you need to become a good programmer. And I want to start the basic Python section with the data types. So let's get started. Let's learn about the Python data types, all the options we have in Python. Now we're back to our REPL.it, so we can write some Python code. We see over here that we're using Python version 3.6. That's great. Let's minimize this and start writing our first Python code. Now we're going to talk about data types. And Python has several available to us. Now I'm going to list them out for you, and then we're going to talk about each one individually. First, we have something called int. And you see right away when I type, I have the REPL already give me hint, and it's highlighting it. If I hover over it, it shows me that int stands for integer. We also have something called float. We have bool, which stands for boolean. We have str, which stands for string. List, tuple, set, and dict. Now, what are these? These are data types, right? A data type is a value in Python. So you can think of it as exactly that, values. So int would represent all numbers, for example. String will represent all letters, for example. And a program is simply instructions that tell a computer what to do. And what does that mean? It's all about storing information, or a data type, and modifying that information. We're taking actions on these data types. So the 2 crucial steps when learning a programming language is that, well, we have these data types that we need to understand that exist in a language, and then we need to learn how we can manipulate the data, create, store, read, change, remove this data from the machine. Now, these data types are called the fundamental data types in Python. They are the core to the language. Now, after the fundamental data types, we also have something called classes. So beyond these data types, we can actually create our own using something called classes. So these will be custom types. Again, something that we'll learn about. So I can create a class that I can name whatever I want. For example, supercar. Now that doesn't exist, but I can create it. And we'll explore how to do that in the course. Now, besides the fundamental data types, the classes, which will be our own custom types, we also have something called specialized data types. And these specialized data types, they're not built into Python, but they're special packages and modules that we can use from libraries. Now, again, this is a topic that we'll cover later, But these are, you can think of it as extra boosts. Whenever we don't have a data type that we want in the standard Python package, and maybe we don't want to create our own custom types, there are specialized data types that we can use from what we call modules. So you can think of it as extensions that we can add to the language. Again, something that we'll talk about later on in the course. And then finally, there's another type that is a little special called none. And none, as you can see, it's being highlighted, which means it means something in the language. None, as the name suggests, means nothing. It's kind of like the idea of zero in math. It's the absence of value. It's simply nothing. And you'll see why this is important in programming later on. So these are our data types that we're going to talk and we're going to use in our language. Now we're going to start with the fundamental data types, which are nice and simple for us to get through. So let's start one by one. And you know what? Let's start with these two for now. I'll see you in the next one. Bye-bye. Welcome back. Let's talk about our first data type. And you know what? Let's do two at the same time. We have int and floats. Int stands for integer, as you can see here. And float stands for a floating point number. Let's explore that. First, let's start off with integer. An integer is, well, a number. 3 or 4 or 5, these are all integers. In a programming language, you can use integers to do mathematical operations. For example, 2 plus 4. If I run this, well, nothing gets printed because, again, we have to perform some action on these data types. And one action that we've learned so far is this idea of printing. And we print something by calling the print keyword with the brackets. So the brackets is almost like saying, hey, perform this action on these data types. And if we run this, we get 6 right here. Awesome. So not only are we using print, but we're also using the plus sign to perform an action to add the two data types together. And as you can imagine, we can do most mathematical operations, the basic ones. We can do negative. We can do, let's say, 2 times 4. And then we can also do 2 divided by 4. And if I click run here, all right, it looks like everything is working. We've added, we've subtracted, we've multiplied, and then we've also divided. Now here's the interesting part. Up until now, we've used what we call integers. That is, these are whole numbers. There's no decimal places, they're just, well, integers. And a neat trick that I can do here is I can actually say, hey, what's the type of 2 plus 4? If I click run here, all right, let's decipher what just happened. I've taught you another action that we can perform, which is something called type, which tells us, hey, what data type is this? And just like in math, we go bracket by bracket. So the first part, Python says, hey, what's 2 plus 4? Well, that's going to be 6. And it's going to say, hey, what's the type of 6? Well, the type of 6, that's an integer. So it's going to say class int. We don't have to worry about the class keyword for now. That's something that we'll talk about later. But we see here that we're using int for integer. And then finally, after this gets evaluated by Python, we print out whatever this does, which is class int. Now, check this out. Let's do the same for all these ones as well. So we're going to say type here, and then type here. And if this syntax is intimidating, don't worry. This is something that you get used to. If this is your first programming language, it is not going to be easy because, well, if it was easy, then everybody would be doing it. So hang in there. Trust me, as you practice more, this is going to start making more and more sense. Now, before I click run, what do you think the output of each one of these lines are? Ready? Give it a guess and let's click run. All right, we got int for 6. We have -2 here, which is also an integer. We have 8 here, which again is also an integer. But then we have float, because 2 divided by 4 is 0.5. What is that? Well, remember, we are talking about two data types here. We're talking about int and float. And float is what we call a floating point number. A floating point number is simply a number with a decimal point. In our case, this is 0.5. So it's a floating point number. So if we write a number, let's say we'll do print type, and then I'll say 0.00001. What do you think we'll get? Well, we would get a float. If I do 5.0001, again, we'll get a float. What about the number 0? If I click run, I get an int because, well, there's no decimal points. Why do we need to make this distinction in programming, and specifically in Python? Well, it's because a float takes up actually a lot more space in memory than an integer, right? Because remember, this number, the number 6, this needs to get stored in memory on our machine. And remember that machines don't really understand this. They understand zeros and 1. And they store this number in something called a binary, or binary numbers, which is zeros and 1s. Now, the problem is when you have decimal places like 0. Or let's do 10.56, it's hard to represent that in a binary number, zeros and 1s, because of this point. So a floating point number essentially stores these numbers in two different locations, one for the 10 and one for 56. Now, we don't need to get technical here, but that's the idea. The idea is that we need more memory to store a number like this than a number like this. Now, the topic of floating point numbers is really, really interesting, and I'll link to a resource. But the best way to learn more about floating points, again, it's not super important that you know the technical details. But if you go to floating point number Python, again, you want to make sure that you go to the documentation for version 3. And you can actually learn about floating point arithmetic. And these official documentation by Python are always a good tool for you to use whenever you get confused about something or you want to get a little bit more extra detail. But let's get back to the topic at hand. Both int and float are used for, well, numbers, right? And Python is going to automatically format the type to whatever, well, makes sense. For example, if in here I do 20 plus 1.1, one is a integer, the other one is a floating point number. But when I click run here, automatically Python is going to convert it to float. Let's remove these here so that we don't get confused by them. So if I run this, we see that this whole expression is converted into, well, a float. Now, if I do, let's say, 9.9 here, which will equal to 11, and I click run, these two floats add up 2 while still a floating point number. Because if I remove the type from here and I click run, it gives me the result 11.0. It keeps the floating point numbers. All right, but at the end of the day, what we care about is that Python works the way we expect it to. That is, we can do mathematical operations. As a matter of fact, we can do a few other things as well. There's also this idea of the double multiply. So this means to the power of. So 2 to the power of 2, well, that's going to equal 4. 2 to the power of 3 is going to equal 8. We also have the double divide. That is, we can do 2 divided by 4. But then we use 2 slashes here. If I click run here, I get 0. This actually returns an integer, rounded down. If I do 3 divided by 4, I get 0. But if I do 5 divided by 4, I get 1. This gets rounded down to an integer. Finally, the last operator that we're going to learn about is called modulo. And it looks something like this. If I do 5 modulo, which is the percent sign, divided by 4, or modulo 4, if I run this, I get 1. Modulo is used to represent what's the remainder of this division. So if I divide 5 by 4, the remainder of this division will be 1. If I do 6 divided by 4 with modulo, and I run, I get 2. 2 is the remainder of 4. All right, let's take a break and learn a little bit more about these numbers in the next video. Bye-bye. Welcome back. Let's continue our understanding of int and float. We talked about the idea of these two data types and how we can use operations on them that we're familiar with from math class, plus a few ones that maybe we haven't seen before, such as modulo or the double slash, or the double multiply for the power of. Now, this is really cool because we can get our computers to do, well, math for us, like a calculator, right? But a programming language also provides for us different actions that we can perform. Now, besides these ones, we also learned that there's a type action that we can take, there's a print action that we can take, but there's also specific math type functions that int and float are able to use that are built into Python. Now, these are called, well, math functions. And functions, something we'll talk about later on, are these actions that we've been talking about. Remember our diagram here? We're starting to learn about the data types and the actions that we can perform on them. Now, in most programming languages, these actions are called functions. And we have a whole section on them. But for now, there's some functions that we can use. So this is a print function, this is a type function. But there's specific math functions, such as round. And you see right away, when I type, REPL is a tool like an IDE that hints and tells us what we can add. So it says round and give me a number and maybe an digit. But let's just worry about the first one for now. So round, if I do 3.1 and I round here, I get 2. Well, that's not right? That's actually the result from up here because we need to also tell it to perform with a function of print. Hey, print to the screen whatever the result of this is. And just to make things easier to see, I'm going to comment this out. So I'm just selecting everything and then pressing Command/, or if you're on Windows, Control/. If I click Run, I get 3 because I'm rounding down the number. So let's say if it was 3.9, I click and I get 4. Again, I'm rounding the number. Another math function that's built into Python is something called ABS. And you see right away that I get ABS here. And ABS returns the absolute value of the argument. And again, for those that aren't too familiar with math, an absolute value simply means, well, no negative numbers. So an absolute value of negative 20 is 20. And now, because we know about math functions, I can start Googling, right? I can say, hey, I'm a Python programmer and I want to learn about math functions. Well, I can go Python 3 math functions. And look at that. Right away, Google tells me that there's a ton that we can use. You don't have to memorize all of these. As a matter of fact, some of these I've never ever used in my programming career. But it's good to know that they have these tools available to you. And as a programmer, this is something that you'll have to get used to. The idea that you won't actually memorize every single action that we can take for each data type. Because some of these are very rarely used. Some of them you'll never use in your career. The key is to understand how to Google them and how to find them. And throughout this course, I will show you the important ones that you're going to see over and over and over. But as a way for you to develop as a programmer, at least you know that this is how you look for answers and find out that, hey, there's different math functions that we can use with numbers. All right, let's take a break and continue in the next video. Bye-bye. All right, this is a big video. Now, these videos are going to be sprinkled throughout the course. They're developer fundamentals video. These are the topics that are going to be super short, but important because as a beginner, it's hard to learn these things because you don't know what you don't know. So what I'm going to try and do in these developer fundamentals is tell you, well, how to avoid the mistakes that I made when I got started and what a lot of people do when they get started. That is, they don't have a clear path and don't understand what the most efficient way to do things is. So with developer fundamentals, we're going to talk about key things to make you, first of all, efficient in learning Python, but also make you a programmer that is really good and that companies want. So what is this first developer fundamental? It's don't read the dictionary. What does that mean? Well, when you're learning a language, such as Python, you're going to have a tendency, especially when you're starting out, to try and learn every single thing, every single function, every single syntax, every single trick. It's almost like you're trying to learn a language by reading a dictionary from page 1 all the way to page, 1,200. But that's not how things work. As a matter of fact, when I work with different programming languages, I don't know all the syntaxes. I don't know all the methods and functions. And what a lot of developers do is not necessarily memorize everything, just like you would every single word in a dictionary. Instead, you understand what exists and what you can use, but you can always Google things. And most of the time, developers are Googling things, no matter how experienced they are. For example, if we go to the Python documentation here, we can go through everything, right? I can go through the language reference and read through everything. And this is really useful information. But you're not going to memorize every single thing about the language because there's a lot. This is the Python language, and then there's also the libraries, the standard libraries that we can use. And if you sit through here and just read everything in here, well, you're not going to memorize anything. In order for you to actually learn Python, you have to use the language. And you'll notice that some things are used a lot more than others. Just like in human languages, like when you learn English, there's really difficult words that don't get used that often. And there's words like and, the, or apple that get used very often. So we're going to learn the language in a way that makes sense, in a way that's efficient, where we focus on the 20% that gets used 80% of the time. And all these smaller, more complicated things we're going to cover, but we're not going to cover one by one from start to finish. We're going to jump around. The idea being that when you learn a programming language, you're just using these concepts and slowly you're learning what's out there so that when you have a problem, you can identify it and remember, oh, I think Python has a pathlib library that I can use. Or perhaps remember that, oh, I can use tuples in Python. So your first developer fundamental is this. Don't learn a language as if you're trying to get 100% on a test. We're going to learn a language by actually using it, focusing on the things that actually matter. All right, that's enough talking for me. I'll see you in the next video. Bye-bye. Welcome back. Let's talk about an important term when it comes to programming, and that is operator precedence. Now, what does that mean? Again, we're using our knowledge from math class. It's the idea that if I do 20 plus 3 times 4, it means that different operators have precedence over different ones. That is, we multiply this first, equals to 12, and then 20 gets added to 12. Because the Python interpreter is going to follow a basic set of rules. For example, if I do 20 minus 3 here, and let's print this out, click run, I get 8. Because 3 times 4 gets evaluated first, which equals to 12, and then subtracted from 20. It's not that this goes first and then we multiply 17 by 4. And this operator precedence shouldn't be new, right? If you've taken any sort of math class, you understand that this is how, well, math works. And this works the same in all programming languages. So the order is this. First, we follow the brackets. So whatever is wrapped in a bracket, we do first. The second is we do the power of. So whatever is done in the power of will be after parentheses. For example, if I do parentheses here, and then to the power of, let's say, 2, or let's do plus 2 to the power of 2, well, the first operation that will happen is 20 minus 3, because that's the first precedence. And then we do 2 to the power of 2 because that's the next precedence. And then only after we do that, we add these two together. If I click run, I get 21, which again makes sense. 17 plus 4. After the power of, we have the multiplication and division. And then finally, the last precedence is addition and subtraction. Now, this isn't going to be a math class. Some people really love math. Some people really don't. But I want to just give you this basic understanding of operator precedence when you see it. We'll do some exercises here to get accustomed to it, but trust me, this is as mathy as we're going to get in this course. The math part of the course is, well, just here. It's going to get a lot more interesting as we learn about different data types. I'll see you in the next one. Bye-bye. Welcome back. This is a quick optional video that, well, with something that you probably won't use, but I want you to just know that it's out there. And that is, there's actually an extra data type that I didn't talk about, and it's called complex. And as the name suggests, it's pretty complex. However, a complex number, again, is a number that is a third type. Instead of int and float, we also have this type for numbers. Now, the reason I'm not really teaching complex is that you only use this if you're doing something really, really complex math, Most of the time, you'll never use it. I personally have never used it, but it is good to know that it exists. It's the equivalent to a real number, and you can read about complex numbers if you want. But again, that's something that you don't need to worry 99.9% of the time. Another thing I want to talk to you about is this idea that these integers and floats get stored, such as 5, in memory as binary. That is, as binary numbers, ones and zeros. And there's actually an action or function that we can use in Python called bin for binary. And you can see that a bin returns the binary representation of an integer. So it's going to return whatever the binary version of 5 is. If I click run here, well, I have to print, remember. So let's print and click run. And I get the binary representation. Now, instead of all zeros and ones, there's also this idea of B. And that is what Python uses underneath the hood to say, hey, when I see this number with 0B, that's a binary number. But if I Google binary number 5, I see that the binary number for 5 is 101, which, again, that's what we see here. So that's really cool, really interesting just to know that it exists. By the way, just for fun, let's say that we want to return this into a decimal. Let's say we're the computer and we just retrieve this binary number. I can do int and then wrap this like this in single or double quotes. And then with the int, I can also say, hey, I want this return to a number that is base 10, which is what us humans use. So if I actually do print here and click run, well, actually we have to do base 2 here, right? Because what we're saying is, hey, this number is base 2 and convert it to integer. And base 2 number is, well, zeros and 1. It's a binary number. So if I click run here, look at that. I get 5. So in your head, you can think of it this way. When we store a number like 5, an integer like 5, when a computer retrieves that number, let's say we're doing some addition, well, it's going to grab this from memory. It's going to say, well, this is a binary number, and I'm going to convert it into integer. Very, very cool. Now, the reason I taught this here, you won't see this a lot in beginner courses, and especially so early in the course, but I think it's an important principle. Although you might not get tested on this ever, for you to just understand how things are working underneath the hood, I believe is an important thing for you to do in order to become a great developer. So hopefully this doesn't confuse you too much. I'll see you in the next video. Bye-bye. Welcome back. So we've just learned about the first two, well, kind of three, because we also mentioned that there is such a thing as a complex number in Python. But we talked about the main ones, the int and float, and there are still a few data types remaining. But before we get to these, we are missing an important concept. And this is going to be our first important term in Python, and as a matter of fact, in all programming languages. It's called variables. Yep, that's a term. Now, if this is your first time learning a programming language, you might not know what this means. If this isn't your first time, well, this is very simple because all languages have variables. But what are they exactly? Well, variables store information that can be used in our programs. So we can hold perhaps user inputs like values. Maybe when you log into Facebook, you need to hold some information such as your profile picture, or maybe your date of birth in a variable. Variables are ways for us to store information on our computer. So let's have a look at this. If we remove this, and let's say I'm creating a quiz program. And this quiz program maybe measures your IQ. And let's say you just took the quiz and you found out that your IQ is 190. Quite high, good job. But we need to store that information somewhere. Well, we can do that with variables. So that in Python, all we need to do is name it whatever we want. In our case, it'll be IQ. And we're going to say IQ equals 190. And this IQ here is a variable. It is something that I just completely made up. I could name it whatever I want. That's a variable too. The idea is that once we assign to a variable, that is, we're saying 190 is going to be assigned to IQ, I can now use it in my program whenever I want. For example, I can later on print, or make sure it's not cap, let's do print IQ. And if I do that and click run, you see that I can use IQ. So we can pretend here that a user takes a quiz, finds out their IQ is 190. We can store that information in this variable, and later on, when they come perhaps online or try to use the program again, they don't have to take the quiz all over because, well, we've stored that information in IQ. And remember what I said at the beginning. Programs are simply data that's being stored, that's being changed, that's being removed, and that's all programs are. And variables are important concepts in Python and all languages. Now, variables can also sometimes be called names. So this could be a name, for example. And assigning a value is also known as binding. That is, we're binding the value 190 to this variable so that when we request this variable later on in our program, our computer knows how to look for this information. It's going to say, hey, I know what IQ is. I stored it somewhere in memory. And it's going to go look for that. And because it's being bound to a value, it points to this value 190. And remember, this number in memory gets stored as a binary representation in zeros and ones, right? But it doesn't matter to us because however our machine stores it, we don't care. We just want to be able to retrieve it. And then when we print it to do, well, get 190. Now, we're going to be using variables all over the course. But on top of just naming variables however we want, there's some best practices around variables of how you should write good variables. And as a matter of fact, these are specific rules that the Python community as a whole has that you'll just have to remember. So let's have a look at this. Variables, and remember, this is the symbol for best practices, are what we call snake case. Snake case means it's all lowercase and then spaces, well, they don't exist. We use underscores. Variables must start with a lowercase or an underscore. Variables can be anything with letters, numbers, and underscores. But remember, they have to start with lowercase and underscore. That means we can't start a variable with a number. They're also case sensitive. That means if I create a variable, but let's say this snake case, this variable has a capital E instead of a lowercase e, that'll be a different variable. And then finally, you can't overwrite keywords. Let's go through these with some examples. First, a variable has to be in the form of a snake case. That is, if I want to call this user IQ, I should technically have an underscore here instead of a space, just to make sure that a programmer, maybe I'm working on a team, can read this variable. So that's snake case. You also have to start your variables with either a letter or an underscore. So I can technically do this. And I click run. Well, that's going to give me an error because I've changed the variable. So now in order to access that variable, you have to go like this. Now, underscore in Python signifies a private variable, something that we'll go over later on in the course. But usually you're starting your variables with a letter. And afterwards, yeah, you can add numbers if you want in here. That's no problem. This is still going to work. This is a valid variable. Finally, a variable is case sensitive. So if I do user IQ here, and I do capital letters, I can't access this like this because, well, it doesn't exist. Again, it's case sensitive. We have to make sure that we match. And finally, we don't want to overwrite keywords. What does that mean? Keywords in Python, well, they already mean something in Python. For example, this print is a keyword. You can see it highlighted in blue. So that if I create a variable saying print equals 190, and then I do print, let's see what happens. We get an error because I can't really assign to this variable because print already means something. Now I know what you're wondering. What are these keywords in Python? That's a simple Google search away, and we'll learn these throughout our course. If we go to Python Keywords by EE3 Schools, you'll see that we have these keywords that each mean something in Python. Again, we'll go through these and we'll learn them throughout our course. And if you look, it's not that intimidating. There's not that many. So as we practice, you'll start to get familiar with them. But the easiest way to tell whether it's keyword or an important word in Python, well, you see that it's highlighted in blue. As soon as you create a variable that is unique, it's highlighted in white. And this will be the case with whatever environment that you're typing code into, as long as it's set up for Python. Now, beyond the Python keywords, there are different things like, for example, the int for integer that we've learned. So these we're going to get familiar with. So a good rule of thumb for variables is to make them really descriptive. Really say what your intention is. And a good programmer is somebody that's able to name things really well with their variables. So if a new developer comes and looks at your code, it's easily understood. Finally, variables can also be reassigned. For example, let's say we have IQ here of 190, and then I decide to perhaps have another variable, call it user age. And for some reason, I want to assign user age to perhaps have IQ divided by 4. Is that going to work? It should, right? I'm saying user age is going to equal 47.5. I'm using IQ, which is 190, dividing it by 4, and then assigning it to user age. I can maybe assign this to another variable called user age or called A. And once again, I run this and it's printing the same thing. So you can use variables to store that information and use it whenever you want. You can use it in operations, you can use it to reassign it, whatever your program needs. Now, later on in the course, we're going to learn about classes, and classes actually have a different convention than this, but we'll get to that later on. For now though, I want to mention two small gotchas with variables that you should be careful with. For example, there's an idea of constants, and constants are those things that never change in a program. For example, if we wanted to create a constant, such as the value of pi, let's say for now it's 3.14, we can have it all in capitals. And that's going to tell other programmers that, hey, this is a constant. This number is not meant to change. I mean, we could change it if we want. There you go. I just made pi equal to 0. So it was stored as 3.14 in memory, but then we overrode it and reassigned it the value of 0. You can still do that, but a good convention is that if you see this, that means this number or this value should never be changed. Another type of variable that you're going to see, and this is something we'll see later on in the course, are it doesn't look like I just did double underscores here, but it's 2 underscores, and we call these dunder. And as you can see here, we have some dunder variables that Python has. Now, we'll learn more about these later on, but the idea here is that these are meant to be left alone. You should not touch them. You shouldn't create a variable with 2 underscores like this and call it hi and assign it a value. I mean, you still can. However, this is generally not good practice. So you want to be careful with that. But the one thing that I really want you to take away from this is that variables are really important concepts in programming. Naming variables is one of the most important skills you have as a programmer. I know it sounds silly, but there's so many times that I read code that is so hard to understand simply because a programmer is not descriptive enough. So throughout the course, we're going to learn how to name things well so that our code reads like English. And that's the whole point of writing good code. The point of writing good code is that it's readable and understandable by other programmers. By the way, to finish off, I just want to show you one quick trick. There's also a way that you might see in some code bases that uses something like this. Equals 1, 2, 3. And this simply is a way for us to rapidly assign values to variables multiple times. So for example, if I do print A, then print B, then print C, and I run this, you see that I get 1, 2, 3. We assign value of 1 to A, value of 2 to B, and value of 3 to C. Just a quick shorthand way that you might encounter. All right, let's take a break, and I'll see you in the next one. Let's learn another important key term. Well, two for that matter. One is expressions, and the other one is statements. You're going to hear this a lot when talking to programmers. So what do they mean? Let's have a look. If we create a piece of code here, let's just say IQ is 100. IQ has lowered. And then let's say user age is going to equal IQ divided by 5. An expression is this part of the code. It's a piece of code that produces a value. In our case, this produces a value, right? Because 100 divided by 5 is going to equal 20. So this is an expression. A statement, on the other hand, is an entire line of code. Not this entire thing, but an entire line of code that performs some sort of action. In this case, what action are we performing? Well, the action is that we're calculating 100 divided by 5 and then assigning that value to the variable user age. So this is an expression. This is a statement. And also this is another statement. So if you hear me mentioning these terms throughout the course, hopefully now you know what they mean. I'll see you in the next one. Bye-bye. Welcome back. I want to quickly talk about something called augmented assignment operator. So we've learned that we can create variables like some value, and we can assign it a data type. In our case, let's just assign it 5. There's something called augmented assignment operator that allows us to do something quite neat. Let's have a look. So if this value, I want to increase it, let's say 5 plus 2, so add 2 to it, I could do that. Or I could even use some value which is already 5 by the time it gets to line 3 and do something like this. If I print some value and I click run, I'll get 7 because 5 plus 2 equals to 7. So in memory, some value points to 7. But there's a neater way of doing this called augmented assignment operator. Instead of doing something like this, I could just simply add a plus to the equals. So we're going to say some value plus equals 2 is still going to equal 7. So it's the same thing as before. And this is called augmented assignment operator. It's a shorthand of us doing something like this. We can also change this to something like minus, which once again is like subtracting 2 from whatever the previous value of some value was. Now, if I was to do this at the beginning here, so let's just do here and then comment this out. And if I click run, I'll get an error because some value is not defined. We haven't really created anything. So in order for this to work, we need to make sure that this variable has some previous value. So we've learned about the plus, the minus, and then finally we have the multiply. Once again, if I run this, we get 10. Remember, this is just the same as us saying some value times 2. It's just a shorthand form. All right, this was a quick video in case you see something like this in the wild. Now, you shouldn't be afraid. Remember that the operator comes to the left of the equal sign. I'll see you in the next one. Bye-bye. All right, we're almost kind of flying through this. I know we're going slow here, but trust me, once you get these data types, things become a lot easier. So we're just climbing that mountain so that we can start looking at a higher level at the language of Python. To keep going, let's talk about this data type, str, which stands for strings. Let's see what they are. A string is simply, well, a piece of text. For example, a string can be written with quotation marks. And I can say, hi, hello there. And that is a string. You see that the color changed here in my editor. I can also make strings with double quotes. So once again, this is also a valid string. And I can put anything I want in here. I can do numbers if I wanted to, exclamation marks. It's just a piece of text. You can think of it as a sentence for now. And if I do the type function here, remember, these brackets denote that we want to perform some sort of action, which is we're using the type action that Python gives us. And if I click run, you see that, and remember, we have to print it out as well. So let's do print so that we can see the display. And I click run, you see that it's str. It's a type of string. Now we can use this in important ways. For example, imagine you're creating a login form and we want to collect somebody's username and password. Well, we can have username variable that we assign, let's say, some sort of username. Let's call it super coder. And then password can be super secret. And now we have these variables, usernames and passwords that we can use throughout our program, such as to check if a password exists. And remember, I can use single quotes or double quotes. But there's a third way that we can write strings in Python. And this, well, is used for long strings. So let's just create a variable long string. And what we can do here is 3 single quotes in a row, like this. And then here, I can just say, wow, maybe a pair of eyes of somebody that's really impressed, and let's go with a mouth. That actually kind of looks like hair. All right, and then I finish it off with 3 single quotes again. So now if I print the long string and I click run, look at that. My little weird emoji face is printed. So the 3 single quotes is for long strings that I can keep going on multiple lines. For example, I can't do this with the single quote. You see that the orange color is now gone because Python is going to say this is a new line and this is another line. And it's going to give me an error because, well, a cret with a quote doesn't mean anything. But if we use 3 single quotes, you can see that we can do multi-line strings. And this is really useful if you want to have maybe long sentences and paragraphs. Now, with a string, we can do some cool things that we saw in the numbers videos. What if I had something like this? Let's say I wanted to grab the first name of a user. I'll just give my own name here, and then last name. and again, my super hard to pronounce last name. Could we do something like this, where we have full name equals to first name plus last name? And then if we print here the full name like this, should this work? Well, let's have a look. Let me remove this part over here just so we have nice and clean looking code. And if I click run, there you go. My name is printed, but you see that there's no spaces here because we're going to use the addition sign to attach Andre to Nagoye, but you can see that there's no spaces here. So I can add a space if I wanted to, or I can just simply create another string inside of here, just like this, and then add a space in between. So we're just using the plus sign, which we've seen in the numbers videos, but instead to add strings together. And now if I click run, you see that I got the space because I'm adding a space in here, in between the names. Very, very cool. But there's a few more neat things that we can do with strings. So let's take a break, and I'll see you in the next video. Welcome back. I want to quickly touch on the subject of what we call string concatenation. Yes, programmers love creating really complex names when concepts may not be as complex. So what does string concatenation mean? Well, it simply means adding strings together. So I can do hello plus Andre, and I've concatenated the string. I've added two strings together. So if I print this, I get hello Andre. So if you ever hear people talk about string concatenation, that's what they mean. We're concatenating strings. By the way, what do you think will happen if I do hello plus 5? If I click run, that's not good, is it? I get type error. Must be string, not int. So it looks like string concatenation only works with strings. We'll explore that a little bit more in the next video. Welcome back. Remember in Python that string is written as str, and this is a special word. Actually, it's a built-in, what we call function, or built-in action that we can take. Now, let me ask you this. What happens if I do string 100? 100 is clearly a number, an integer. But what if we run the string function on this? Let's find out. Let's do print here, and then run this. If I click run, I get 100. All right, but is this an int or a string? To find that out, once again, let's wrap this, so the answer of whatever this value is, into type, like so. I know this is a lot of brackets, but remember, we're evaluating this piece of code, so we're turning 100 into a string, or running the string action, and then we're going to check the type of this entire thing, and then we're going to print it out. If I click run, I see that it's a string type. So we've converted 100 into string using this. Now, just to confuse you a little bit more, what if we do something like int? Like this. All right, even more brackets. What happens now? Can you guess? Well, we convert 100 into a string, then convert it back into an integer, and then we check the type of it, which is a class int, and then we print that. So remember, this was the same as me saying a equals str 100, and then b is going to equal int of a, because we're evaluating this part, and then I'm saying C is going to equal the type of whatever B is. And then finally, we're printing C. So that piece of code was the same as doing this. Very, very cool. Now, this is the idea of type conversion. Again, if I were to write that down, it's called type conversion. We're converting the type of our data types. And you can do that throughout programming. And we'll talk a lot about this throughout the course. But it's the main reason we have things like str, int, we have things like float, and many other data types that we're going to talk about. I'll see you in the next video. Bye-bye. Welcome back. Let's talk about something called escape sequence in Python. Let's comment this out. And let me ask you a question. What if we wanted to have a string that tells me, let's say, the weather? And here we want to write, it's sunny. You see how the highlighting changed here? Because I want to say it's with an apostrophe S. But Python is reading this and saying, okay, this is the start of the string and this is the end of the string. And then I have no idea what this is, and then we're starting a string again. How can we fix this? Well, we can add a double quote string instead, and this now works. But what if, for some reason, we also wanted to add it's kind of sunny in quotation marks? Well, now we have another issue. So how can we solve this? Because in human language, we have double quotes and apostrophes. Well, we can use escape sequences here. And this is a little hard to understand at first, but it's simply adding a slash like this. So the one right above your enter on the keyboard. So this slash, when Python goes through it, is going to say, all right, whatever comes after this, I recognize this symbol. Whatever comes after this, I'm going to assume it's a string. So now if I do backslash here, and then backslash here, it's going to say, hey, Python, I'm letting you know whatever comes after this is a string. I'm letting you know whatever comes after this is a string. And then I'm letting you know what comes after this is a string. So that when we print the weather, everything is printed nicely. Awesome. Now, this escape sequence can be used in multiple ways. For example, if I want to have an actual backslash, well, I can go like this. And because it's saying whatever comes after this is a string, it's going to assume that this is a string now. So if I run this, you see that we get this backslash. And there's a few other neat tricks that you can do with it. For example, one of it is the backslash T. What does that mean? Well, let's remove this for now. There you go. The backslash T, remember, well, let's add a space in here so we can distinguish it, is going to say, hey, whatever comes after this, I want you to add a tab. This is a special meaning here. So if I click on run, you see that it's added a tab spacing to my string. Another one is using n, or a new line. So let's leave T here and then add a backslash n and then say, hope you have a good day. What do you think will happen here? If I click run, I have a tab from the backslash T, and then I have a new line after kind of sunny because I do the backslash n, which denotes a new line, so that this shows up on a new line. Now, these escape sequences are hard to see at first, but they're pretty much available in all programming languages that use strings. So if you come from another language, this shouldn't be that strange to you. If it's your first time seeing this, you just need to get used to this syntax and every once in a while go to the Python documentation and just type in escape sequences, and you'll see all the ones that we have. These are the main ones that you need to know. All right, more to learn in the next video. Welcome back. Let's talk about the topic of formatted strings. Up until now, we've just written simple strings. But we want a program that's dynamic, that's static. Let's say we have a Amazon page, and we're working at Amazon actually. And when a user logs into their profile, well, we want to display their name or what they have in the cart. In that case, we don't want to just hard code and write every single user's name, like Andre, or another user, Joe, and write every single name in the world. No, ideally, what we can do is have something dynamic, where let's say it's a profile page and we simply use the name variable and we display that on the page. Now, this name variable should equal whatever the user's name is. And this is something that we can grab from the database, again, something that we'll talk later on in the course. But let's assume that in here, when we do equals, we're going to grab some user information, which will be the name. And this name, for now, will be John. Or let's go Johnny. And this Johnny, we want to display on the profile page. And we can do that with formatted strings. We can simply do something like print and then say name. But we also want to greet that person, right? So let's do hi and then plus name. And remember to add a space. If I click run, I get hi Johnny. But as we get more and more information, let's say we have age and Johnny is 55. If I wanted to extend the sentence and I want to say you are, and then add another plus, make sure we add a space in here, and then add year old. Run here. All right, we get a type error. Must be string, not int. Oh boy. All right, so we have to convert this into a string. So remember, we can do that like this. And then if I click run, hi, Johnny, you are 55-year-old or years old. All right, that was a little cumbersome, but we're making our Amazon page dynamic. We can grab different information from the database and we'll have in a string something according to the user. But there's a better way of doing this. And with formatted strings, all we need to do is add an F at the beginning. And this F at the beginning is going to tell Python, hey, this is going to be a formatted string. And instead of doing all this plus and name and all this stuff, and doing the str to convert the type, we can simply do something like this. Let's remove this and simply do brackets and say name. And then again, remove all of this and say age. So I'm going to say hi, name, you are age, years old. And if I click run here, you see that it still works. This is a new feature of Python 3. By adding F to the beginning, it's saying, hey, this is going to be a formatted string. And I want you to just make these variables available as strings inside of, well, this string. How much cleaner is that? Now, although this is nice and clean, and this is my preferred way of writing strings, before Python 3, you didn't really have this. So in Python 2, and mind you, this works in Python 3 as well, as you can see, we had something different to accomplish this. What we had was this idea of a dot format. And dot format, so let's remove the F here, is going to do the same thing for us. We do a bracket here, and then we say, hey, we want Johnny and age of 55. And we can just remove these variable names. If I click run here, I get an error. And you have to be careful here. Dot format works on strings, but you can see over here that we did it outside of the brackets. And what it's doing is saying, hey, run the format action on this print. But print is not really a string, right? So you have to make sure that we move the brackets to the outside so that we evaluate this piece of code first. So the string is going to get formatted, and then we're going to print. If I run this, hi Johnny, you are 55 years old. So that works the same way. But what if we wanted to use variables? Because right now we're just doing this by order. So whatever comes first gets filled in first in the brackets. Well, we can do something like name and age. Let's see, can we do that? Let's run. There you go. That works the same way. What if we had a specific order? Maybe we want this to be age and here to be name. Well, we can mix those around. We can say 1 here and 0 here. Because in computer science, we always start counting from 0. So this is 0 and this is 1. If we had something else in here, let's say a third variable, then this will be 2. So if I click run here, all right, everything is upside down. Finally, I can just create my own variables if I wanted to. So let's say hi, let's say new name equals Sally. And then age of Sally is going to equal, let's say 100. Sally is very old. Now, if I do 0, let's say I'm 1 here, I click run. So now we'll actually get an error. Tuple index out of range. Now we haven't really learned about tuples and ranges, and this is a little confusing, but a bit of a trick here. We want to make sure that we add now, because we've given the actual variable a value, we need to actually say new name here. And here will be age. So that if I click run, there you go. Hi, Sally. You are 100 years old. As you can see, with dot format, things are a little bit more complicated. You'll still see this, and all Python 2 code still uses the dot format. And you'll see a lot of Python 3 code bases that still use dot format because some people prefer it. But I would argue that the F at the beginning of a formatted string is the way to go because, well, it just makes things so much easier, right? Nice and clean, nice and easy. So I do recommend that you use the formatted string with the F in front. And for short, we usually call this an F string. All right, I'll see you in the next one. Bye-bye. Now, up to this point, we've learned that str is an ordered sequence of characters, right? It's essentially a piece of text where we can write our names, passwords, paragraphs, and sentences. And strings underneath the hood are stored in memory, as I said, as an ordered sequence of characters. So for example, if I had the string me, then this will be stored in our computer's memory in an order. So M will be stored in a place in memory, and after that place in memory, E will be stored, then the space will be stored, and then M, then E, then space, then M, then E. So if you think of a bookshelf, each one of these is ordered in a different part of the bookshelf, but one after another. And the way we can think about this is like this. The M is stored in location 0, and then E is stored in location 1, and then space is stored in location 2, and so on and so forth. And each shelf now corresponds to a value. so that when we ask the computer, hey, I want you to grab this string, we know that, hey, we're going to look in the shelf 0 to 7. Now, why is this important? Because one of the most useful things you can do with strings is to access different part of a string using its what we call an index. So for example, when you have a string, and let's call this variable or this piece of string selfish. And selfish has me. And I'm going to comment this out just like this. Make sure it's aligned, okay? And what I'm going to do here is I'm going to say selfish and then square brackets right here and then type in 0. Now, if I print this and I click run, check that out. I get the letter M. Why is that? Well, using the square brackets, I'm telling the computer, hey, grab the variable selfish, and then from that variable selfish, grab whatever is an index of 0. And what's on that bookshelf of index of 0? Well, the letter M. What if I do 7? What do you think will happen? If I click run, I get E, because on the bookshelf of number 7, that's E. And when I'm getting just selfish, I get the entire string. It's going to say, all right, I'm going to grab from the bookshelf index of 0 all the way to 7. Very, very cool. And this concept we're going to explore throughout the course, and you're going to see why it's important very soon. But using this knowledge, we can do a lot of string manipulation. And Python has this unique feature that we're going to talk about right now that allows us to grab different pieces of text. So let's have a look here. The rule here is when we use square brackets in Python, the first item that we put between the square brackets is what we call the start. The start is, hey, where do you want me to look? In our case, we said we want to look at 0, so we got M. We wanted to look at 7, we got E. But then there's an extra thing that we can do. If we do a colon here, we also have the option to say, hey, where to stop. What does that mean? Well, if I do something, and you know what, let's change this to 0, 1, 2, 3, 4, 5, 6, 7, just so it's easier to understand. If I do, let's say, 0, colon, 2, and I click run, I get start at 0, end at 2. So I get to grab 0 to 1. Because remember, I'm saying start here, but then stop as soon as you get to bookshelf 2. We don't want that. So if I do 0 to 7, what do you think will happen? Well, I click run, and I get all the way to 6. So in order for us to grab the full string, we have to do 0 to 8. Because there's actually 8 characters here, right? Because we start from 0. If I click run, there you go. Now there's a third thing that we can add here. And this is called the step over. And the step over says, hey, start here, end here, and then step over a few things. So the default is 1 because we're going 1 by 1 through our bookshelf. You see that we get the entire string. But if I add 2 here, it steps over by 2. So I grab 0, then I step over 1, 2, grab 2, then step over 1, 2, grab 4, step over, and so on and so forth. So let me ask you a couple of tricky questions here. What happens if I do this? Is this valid? If I click run, what will happen? Ready to guess? I get 1, 2, 3, 4, 5, 6, 7. This says, hey, start at 1, so that is right here. But then afterwards, stop, well, there's nothing there. So the default is going to say go all the way to the end. I know this is confusing, but hang in there. Practice this often enough, and this will become second nature. Okay, what if I do something like this, where I don't fill the start and do 5 here? What happens now? Ready? I get 0, 1, 2, 3, 4, all the way until 5. So it starts as default 0 and goes to 5. Okay, what if I do something like this? 2 semicolons and then 1. If I click run, all right, I get the default behavior. Because it's starting at 0 when there's nothing. It ends at whenever the string ends, when there's nothing, and then we're stepping over through it once. All right, but what if we do something like this? What if I do -1 here? This is a tricky one. What will happen? Let's find out. I get 7. In Python, the negative index means, hey, start at the end of the string. So that if I do -2, I get 6. If I do -3, I get 5 because I'm going backwards. And a neat trick that you can do here is if we do semicolon, semicolon, -1, and this is actually quite a common operation, so you just have to memorize this even though it looks weird. It means start, stop, there's no limit here, but I want to step over from the back. So what do you think will happen here? If I click run, do you see that? We get the reverse of the string. So this is a very useful notation if you want to, let's say, reverse an order. And if we want to, let's say, skip by 2, I click run, and you see that we're skipping by 2 now. Now, hopefully your head doesn't hurt with all this notation. You just have to get used to it. It's something quite unique to Python, but it's very, very useful. So up until now, we learned that strings can be accessed quite easily. And using the square brackets, we can access different parts of the string. And this idea of a start, a stop, and a step over is what we call slicing or string slicing, because we can slice the string however we like. But we also need to learn another important term that's going to come up again and again throughout this course. And as a matter of fact, it's an important concept that as you get more advanced into programming, you really need to understand. What is this concept? Well, it's this idea of immutability. It's an important term in programming. What does immutability mean? Well, strings in Python are immutable. That means they cannot be changed. What do I mean by that? Now that we've assigned selfish this value, this string, well, I can reassign it, right? I can say selfish is 100 now. And if I print selfish and I click run, that works. But if I instead do something like the first index of selfish is going to equal 8, and I click run, I get an error. I get a type error saying string object does not support item assignment. Why is that? Because strings are immutable. That is, I cannot change the value of this once it's created. I can't just immediately change it to 8, 1, 2, 3, 4, 5, 6, 7. No, it has to stay the same. The only way that I can remove this or change this is to completely reassign the value. So that in memory, Python removes all of this from our bookshelf of memory and instead just assigns 8 into the 0 bookshelf and removes everything else because we don't use it anymore. Now, this idea of immutability is something we'll explore more and more. especially when we start talking about lists. But for now, just remember that you can't reassign part of a string. Once created, it exists like that in that form. The only way we can change it is to create something new. We can do selfish plus 8, and we can create it that way. But now this selfish is a whole new string. This no longer exists, and a whole new shelf space was created for us to use this whole new string. Again, if this doesn't make sense to you or why it's important just yet, don't worry, we'll get there. For now though, I'll see you in the next video. Bye-bye. Welcome back. So far we've learned a few built-in functions that Python has. Few built-in actions, right? Actions that we can take on data. And we learned about str, we learned about int, we learned about float, and the type conversion that we can do. We also learned about type, we also learned about print. And these built-in functions in Python, well, there's a few of them, and I'll link to this resource, but there's not too many. As a matter of fact, we've also seen ones like ABS or round in our numbers video. So numbers had some functions that we can use, some built-in functions. Well, strings also has a very useful one called len, which stands for length. So as you guessed it, if I type in something like this and I print this out and I click run, I get 9 because it's calculating the length of the string. In our case, 1, 2, 3, 4, 5, 6, 7, 8, 9. The length of the string is 9. Now you have to be careful here because the length itself doesn't start at 0 as we've seen with indexes. Instead, it counts like humans do from 1. So a neat thing to do here is I can do something like this. Let's say that we have a variable greet that equals hello. Well, I can grab the greet variable, which is a string, and use string slicing to grab, well, the first and then go all the way until the end. Now the default already does this. If I leave it like this, it's going to grab hello. Oh, and make sure I add a bracket here. Let's click run. I get hello. Now, if I do 0 to length of greet, what does that mean? Well, if I click run, I still get hello because the length of greet is 9. Like so. Now, this length function is quite useful and we're going to use it a lot in this course. But I want to introduce to you the concept of built-in functions, as well as what we call built-in methods. What does that mean? A built-in function had this syntax of the word that was highlighted in blue, and then we used curly brackets to perform some action on a data type. However, Python also has this idea of methods. And methods are similar to functions, but they are owned by something. So for example, in Python, we have string methods. So these are methods or actions that only strings can perform. And don't worry, this is something that we'll talk more about when we talk about classes and functions. But for now, Python, for example, has string methods. So these are methods that we can use specifically for strings. And methods have a special syntax, where instead of just the word with the curly brackets, it usually has a dot in front of it. So dot, and then some sort of word, and we've actually seen one, format, right? Dot format curly brackets or brackets is a method. And if I go to Python string methods and I scroll down or scroll up, we see that format specific values in a string, is a method. Now, why do we care? Well, with this, Python gives us automatic tools that we can use on strings. So let's explore some of these string methods. Let's create a quote here. And the quote is going to be or not to be. Now, in here, with this quote, we can use some methods on this string. Now, I'm not going to go through everything because, well, 60% of these you're most likely never going to use in your career. I'm going to go over the important ones that you'll see over and over again, but I'll also link to this so that you can see this for yourself as a reference. Remember, as a programmer, your job is not to memorize this and read a language like you read a dictionary. Instead, is to know that this resource exists and it's for you to explore and learn as a specific problem occurs. But let's get back to the task at hand. One thing that we can do is to use the upper method. We use a dot and then type in upper and then the curly brackets. And luckily for us, our editor shows us that this actually exists because of the drop-down menu. So what happens now? If I print this and I click run, look at that. Everything gets capitalized. To be or not to be. There is also another one we can use called capitalize. What's the difference between the two? Well, if I run, you see that it capitalizes the beginning of the sentence. And by the way, your editor, or in our case, our REPL, if you hover over this, it'll actually tell you what it does. It returns a capitalized version of S. So whatever is to the left of the dot. And a good editor will actually show you all the things available to you. So as soon as you press a dot, look at that. I see all these purple boxes, which are methods that are available to me for a string. And you see there's a lot of them. Now, don't worry about these double underscores, these dunder methods, because this is something that we'll talk about when we talk about classes. But you can see that you have different things that you can use. For example, you have lower. Instead of upper, it lowercases everything. What if I want to use find, for example? And find simply says, hey, does B exist in the code to be or not to be? And if I click run, well, it tells me that yes, quote.find has B and it starts at index of 3. So if I go to 0, 1, 2, and then look at that, 3. So we have find, which finds us the first occurrence of a piece of text. You also have things like replace, where I can replace whatever I give it as the first thing and then separate it to the second thing. So you can see over here, it tells me old and then comma, new. And I can replace this with me. If I click run, I get to me or not to me. So this replaces all the occurrences of B. Now, the final thing I want to point out to you is that if I print here, quote, what do you think is going to happen? I've printed here and I replaced to me, to be or not to be with to me or not to me. Quite a selfish quote. But if I print this again on the 5th line, what do you think will happen? Let's find out. Whoa. Is this what you expected? Think about why this might happen based on what we've learned. Here's the thing. Remember, strings are immutable. That is, they cannot be changed. We can overwrite them if we want, but we don't change them. We either create them or destroy them. In our case, when we do quote.replace to me or not to me, it's creating a new string. Now, we're not assigning this string to anything. So eventually, after we print it, we remove it from memory. But if I do something like this, where I have quote 2 equals quote replace, and I print quote 2, well, in our case, we're creating a whole new string. We're creating a string, but we never modify the original string because it's immutable. So that quote always stays the way it is. Until we destroy it, until we remove it, our program ends, this is going to exist. All right. Hope you're having fun. Hang in there. More to learn in the next video. All right. So up until now, we've spent forever talking about numbers and strings, and you're thinking, oh God, we have so many more to go through and my head hurts already. Well, you know what? I think you're gonna really like this one because this one's really short. And they're called booleans. And booleans in Python is bool. And bool, well, there's only two options. A bool can either be true or false. That's it. How awesome is that? You just learned booleans. So a boolean I can assign to, let's say, my Facebook profile. I can say Andre, or I can say name equals Andre. And make sure that we form this into a string. And then I can say, well, let's say we're creating an even better social network than Facebook. We're creating our own. And this social network also has the is cool option on your user profile. And let's say for now it's false. You see over here that's being highlighted. Now is cool is set to false. But all of a sudden I'm thinking, my profile doesn't look good if is cool is set to false. So I'm going to change that. I'm going to say is cool is now equal to true. Now my profile has been changed to is cool is true. Hooray. And that's it. Booleans represent this idea of true and false, which in programming is kind of like saying 0 and 1. They're logical values, right? There's some logic that we can use, and we'll see when we talk about conditionals in upcoming videos, where booleans become really useful, because we can use booleans to control the flow of our program, to do something if something is true, to do another thing if something is false. It's a cornerstone of computer science. And by the way, a topic we're going to explore more and more is this idea of using booleans to denote logic. So for example, what do you think a bool of 1, converting 1 to boolean, would do? If I print this and I click run, I get true. In boolean, 1 means true. A 0, well, that equals false. And remember, we're just simply converting this integer into a boolean value. And a boolean, well, is just either false or true. Nothing else. That's it. And I can also convert a string that says true into a boolean true. Again, this is something we're going to explore a little bit more when we talk about conditional logic. But I wanted to make this video nice and short to let you know that, hey, not all these data types are as complex as, well, numbers and strings. All right, nice and short. I'll see you in the next one. Bye-bye. Welcome back. So up until now, we've learned about integers, floats, strings, and boolean values. So let's try and tie some of those things together. Let's imagine you were Facebook. How do you think Facebook works underneath the hood when it comes to your profile? Well, they would have, let's say, a variable called name, and this will have your name. And then they'll probably have a variable with your age, let's say 50. I'm not actually 50, but I'm pretending to be for this case, just so I sound wiser. And then let's say relationship, status. So again, we also have relationship status on Facebook. And for now, let's say single. So that's my Facebook profile right there. Now, if we wanted to perhaps change that, let's say my relationship status all of a sudden goes from single to it's complicated. Well, that's an easy fix. We would just do relationship status equals to it's complicated. And remember, because of the single quote, we'll have to do backslash it's complicated. And now if I print my relationship status, you'll see that it's been updated to it's complicated. I am no longer single. Hooray! But this is pretty simple. Let's do something more complicated. And this is going to be a fun exercise. Let's create a program that guesses your age. Let's use the input method that we've seen before. Remember, the input method allows us to type something in here and receive it as input. So we can assign that to a variable. So let's say this variable is going to be birth year, and that's going to equal the input that's going to ask when or what year were you born. Now, from here, I want you to pause the video and try to solve this yourself. How can you make it so that at the end of this program, you're going to get asked, what year were you born? You're going to type in your year, and then it's going to print out your age is whatever the age is. So pause the video, try and solve this on your own. Mind you, there is a bit of a trick in here. So if you get stuck, try to Google around and figure out what the issue may be. Again, part of being a programmer is trying to solve these problems that you don't know the answers to. All right, let me show you my solution. We have our birth year here that we're going to store in a variable. And now we're going to calculate the age. I'm going to say age equals, well, it's going to equal the current year, let's say 2019. And then 2019 here is going to get subtracted from whatever the birth year that you entered. So let's enter that. And then we're simply going to say print your age is, and we want to use an F string here. So I'm going to add an F here. And then simply say age. If I run this, I get what year were you born? I was born in 1986. We get an error. And if you try this yourself, you may have encountered this error. We get something called a type error. And there's lots of errors that you can get in Python. Again, we have a section on errors, so don't stress too much about it. But if you read here, it says unsupported operand type S for minus int and string. Let's try and debug this. It looks like we're using minus on an integer and a string. So let me print out here the type of birth year. If I run this and let's enter 1986, I get class string. And this is a little gotcha because what input does is it asks you for an input. But that input that I wrote, 1986, well, that actually gets converted to a string and assigned to birth year. So what that means is that we're trying to subtract a number or a string from a number. So how do we solve this issue? Well, you'd have to turn this into an integer. And this is something that we saw previously. what we need to do is to convert this into an integer with using the int function. So let's try that. If I remove this and click run, I'll say 1986. And look at that. Your age is 33. We've created a program that is able to tell your age based on the year that you were born. Now, this may have been tricky to you, but it teaches an important concept in programming. That is, sometimes you're storing data into different data types. And sometimes you need those different data types to interact together. So you'll see a lot of problems where you have to convert a data type. And this is a very common one where you take an input that's a string and then you convert it to something like an integer. So you can perform a mathematical operation. And that's why, if you remember, we gave you a list of all our data types in Python, the fundamental data types, and all of them were blue because, well, each one of these are actions, are functions that we can use. For example, I converted the birth year into integer, but I could have also converted this to a float, for example. And if I run this, it would still work because Python knows that, well, we can use integers and floats in mathematical operation, but you can see here that it's converted into a float now. If we convert this into a Boolean and I click run, your age is 2018. That's really confusing, right? Well, that's because this gets turned into true, and underneath the hood, Python does something weird, where a true value is converted to 1. Because Boolean, remember, it's 1 or 0, true or false. All right, hopefully this didn't confuse you too much. It's something that we'll encounter throughout the course, so don't worry, we'll get more and more practice. However, I hope you get to practice this a little bit to really understand what's going on, because although this is a couple of lines of code, the principles that we use here, we're going to use throughout bigger and bigger code bases. So I guess I'll see you in the next one. Bye-bye. Let's talk about another developer fundamental. And this one is commenting your code. Up until now, you may have seen me add comments to our scripts. For example, right here, I added a comment of Booleans. And this tells the Python interpreter, hey, this is a comment, don't run this, it's just for me, you can just ignore it and skip over to line 2. And you saw that I simply did that in Python with the pound sign. As soon as Python sees a pound sign, it adds a comment. And you can do that after a line as well. I can say, this assigns to a variable. And although this may look like 2 lines, it's actually just the word wrapping that's happening. And you can see that the interpreter just completely ignores these comments. Now, commenting sounds very, very simple, but it's an important concept. And if you want to be a good programmer, in all languages, we have commenting. But there's good ways and bad ways of commenting. And this is something that comes with practice. But here are some key guidelines. When you're commenting your code, the idea is that you're adding valuable comments. That is, if I add a comment here that says, hey, this is assign name variable a value of Andre string. A comment like this is not really good. Why is that? Well, because your code should be self-explanatory, right? The idea is for us to write code that is easy to read, easy to understand. It's not trying to be clever. Instead, it should read like English. And any Python programmer would know that here we're just simply adding Andre as a value of name. We're assigning a variable. And adding a comment like this that's self-explanatory just adds clutter to your code. So there's a trade-off here. it's good to comment your code. For, let's say, if you're working on teams and other developers come and they want to understand your code. But you have to remember this principle of code being easy to read. The only time you want to add comments to your code is, well, when something really, really important is happening, where it might be a little complex. You first decide, hey, is this code written in a way that makes sense? For example, if this was variable A and this was variable B, well, this might be really hard for somebody to understand. So you might say that this is cool flag. But before you add that comment, you want to say to yourself, maybe my code is hard to read. Maybe I should just change the variable to is cool to make it more understandable. Now, this is something that you improve upon more and more. And you do want to use comments as an extra tool to make your code understandable. Maybe you write code that 6 months from now, you want to go back to understand what you did. But remember, more comments doesn't necessarily mean better code. You want to be concise and keeping things simple, while adding comments only when necessary to help others understand your code, not trying to make your unreadable code more readable. We'll explore this topic and give you advice on it throughout the course. But remember this key developer fundamental, because you're going to need it throughout your career. By the way, this article over here has some really important points that I think you'll really benefit from, especially in the commenting best practices. You can read some of the do's and don'ts and what some of the top programmers do when commenting. I know it sounds silly, but it is an important concept that most courses overlook. So I highly recommend you read over this. I'll link to it in the resources, and I'll see you in the next video. Welcome back. Let's try and do an exercise to tie everything that we've learned up until now together. We're going to create a password checker. Now, what we want to do is to create some sort of an input that we're going to ask. So we're going to use the input function. And here we're going to ask for a username. Then we're going to ask for another input. It's going to be the password. And then at the end, with the input, we want to print something the lines of password, and then we'll have maybe the actual password in here, and it will say is another variable here, long. So what we want to do is the password, and then maybe the password length, so that let's say we printed our username, JJ, and then we give it a password of secret. Well, we should print the password. Secret is 1, 2, 3, 4, 5, 6 letters long. Now, obviously, we don't want to show or display the password, maybe for security reasons. So we want to convert this secret to 1, 2, 3, 4, 5, 6, 2 stars. So your task is to convert these two inputs. And you know what? Let's also do a greeting where we say the username here. So we're going to say, hey, JJ, your password, which will be marked in a star, is 6 letters long. Now, one neat trick here that you haven't learned yet and you might want to use here is this that you can do with strings. I can go star times, make sure that the star is a string, multiply it by 10, and if I print this out, I get 10 stars. So you may want to use this functionality when we're doing this. All right, pause the video, give it a go if you can. Remember, the goal is to print the username and have the password blocked with how many characters the password is. All right, pause the video. If not, I'm going to get going with the answer. So the first thing we're going to try and do is I'm going to create two inputs. So the first one, I'm going to get the username. I'm going to assign it to the variable username. And it's going to say, what is your username? Then the second one will be the password. And the password, well, we'll say, what is your password? And although this is a simple example, this is something that you will see with other big websites like Instagram or maybe Netflix when you're logging in. So now that I've stored this information into a variable, I can use it, right? I can print, and we'll do an F string to make our lives easier. So I've added the F here. And what we'll do is this. We'll say username, your password, and we'll add the password here, is, and then we'll add another variable here, which is the password length. So how are we going to calculate that? Well, let's try something here. Let's see if I can use the length function and in here do password. Let's see what happens here. What is my username? Let's go with Andre. What is my password? Let's just type in secret here. And I get, Andre, your password? Well, I can't speak English properly. My password, secret, is six what? Let's write 6 letters long. Awesome. So this is working because with an F string, I can create or add a Python expression in here using the length password. But there's an issue here, right? We don't want to actually print out secret. We want to print it out in the star form. And this is a good discussion topic on readability of your code. Now, this is a simple example, but we can make this code a little bit cleaner. For example, we can break things down so that we'll have password length will be length password. So we're calculating the length. So this is going to store 6 or whatever the input of our password is. And it's nice and descriptive. It's easy for other developers to understand. And then in here, I can also have hidden password. And this hidden password will be the password length. And we're going to use that star string and multiply it by the password length. Let's make this a little bit bigger, so that now our code can be understood, well, in an easier fashion. So we have the password length. So we're going to say username, your password, but we want to make sure that it's the hidden password. So we'll copy this over here. So username, your password, we're going to print out hidden password is, and then we're going to copy password length. Now, I argue that this reads better because each line is doing something simple, and then finally, we're printing the output. And although this is a small, simple example, this idea of readability and making and writing code that makes sense is an important concept. So let's see if this works. I'm going to click run. My username, Andre. This time around, my password is going to be super secret. And look at that. Andre, your password is 11 letters long. Good job getting this far. Hopefully you got that. I'll see you in the next video. Welcome back. Let's talk about our next data type. And it's a big one, a very, very useful one. It's called list. And list is an ordered sequence of objects. that can be of any type. So you can think of them as strings, right? We had strings previously that we learned about, except that each sequence of this string, was a string, was a letter or a number wrapped in quotation marks. Lists, on the other hand, looks something like this. Let's say we create a variable, li, and lists we denote with square brackets. And inside of these square brackets, we can have different objects. So for example, we can have 1, 2, 3, 4, 5. We can also have, let's say, li2, and this is going to have a B, C, and it can have any collection of items that we want. We can even mix and match and say that we have 1, 2, then A, then maybe even the Boolean value true. So all of these are lists. Now, lists are extremely important. And in other programming languages, you might have heard the word arrays. So in Python, lists are a form of array. And later on, when we get into the modules section of the course, we will talk about the difference between lists and arrays. But if you are coming from a different programming background, then lists are like arrays in your language, a collection of items. Now, the neat thing about lists is that it's the first data structure that we're learning. Now, what is a data structure? Data structure is a very important concept in programming languages. It's a way for us to organize information and data into, let's say, a folder or a cupboard or a box, so that these data structures can be used with different pros and cons. For example, you have a fridge where you store your food. And fridges are really, really good at putting your food inside, keeping it cold, and then taking it out. Or you might have a backpack. A backpack is really, really good to stuff everything in there, but when you're looking for things in a backpack, it's really, really hard. So you can think of data structures similar to that. A container around your data that has different pros and cons of accessing that data, removing that data, writing data. But that's something we'll get into a little bit later. The key here is that these square brackets allow us to contain information and data like strings, integers, floats if we want to, booleans, into a contained fashion. So let's think of a good example here. What if we had a shopping cart? Let's say we're Amazon here. And then Amazon has the Amazon shopping cart. And in here, we can collect different things that we want. Maybe we collect some, I don't know, notebooks. And you know what? Let's get some gadgets. Let's get some, maybe some sunglasses. We can add different items here, different strings, different data into this cart. And now, just like we saw in strings, we can access the Amazon cart in different ways. For example, I can access it, again, with square brackets, and simply say I want item 0. So if I print here and do Amazon cart, look at that, I get notebooks. The second item, I get sunglasses. What about the third item? Nope, list index out of range. But this should make sense now. This is a list where we're accessing the index of, but it only contains 2 items. So if we're going 0, 1, 2, the third item, nothing exists. So our program says, that doesn't work. You're doing something wrong. And just like strings, these list items are in memory, in their separate bookshelf, right? But one right next to each other. So we can go 0, 1, 2, 3, 4, 5, so on and so forth until the list ends. All right, let's learn about lists a lot more in the next video. Bye-bye. Welcome back. Let's continue with lists. Now, so far, these square brackets, we've seen them before, right? We saw them when working with strings. And just like strings, lists are quite similar in that we can use list slicing. If you remember, with string slicing, we had things like hello, and we were able to assign it to a string, let's say a variable string, and we could do string and then slice. So do something like this, where we had the start, the stop, and then the step through. So that we start at index of 0 and end at index of 2, and then go one by one. So list slicing is also available to us. So let's make this cart a little bit bigger. And you can actually just make things cleaner by formatting it this way. All right, so what should we add to our cart? We'll also add some toys. And then, you know what? Amazon does groceries now, so let's add some delicious grapes. Awesome. Now, let's say I wanted to get every single item in the cart. Well, we just simply do this, and we have our entire list. But let's use some list slicing. Let's say I wanted to grab from the first item to the second item. If I click run, I get notebooks and sunglasses. Maybe I want to go all the way till the end, but skip every second one. I get notebooks and toys. We start at 0, we step over to toys, and we step over and we're done. Awesome. And this is something that we've already seen when talking with strings. Okay, but here is where it gets interesting. Remember how I said that strings are immutable? That means we can't change them, right? And we talked about this when we had a string like hello. I couldn't do greet 0 equals to, let's say, Z. I'd get an error here. I get str object does not support item assignment. It's immutable. But the interesting thing with lists is that they are mutable. So that if I change my Amazon cart and say that, you know what, I don't really want notebooks. So I'm going to grab the first item, which is notebooks. And instead of notebooks, what do we want? We'll say we want a new laptop. It's a big upgrade. When I print this Amazon cart, look at that. I'm able to change this list. And it didn't give me an error. In that sense, lists are mutable. We simply replace on the memory bookshelf of our computer notebooks, and I say, hey, change it to laptop. And they let us do that. Okay, so that's awesome. But let's try something here. What if I create another print here? And in the Amazon cart, I'll use list slicing. So let's say I want item from index of 1 all the way until index of 3. Let's run this and see what happens. Try and guess. Is that what you expected? Let's go through this code. When we get to line 10, we grab the Amazon cart, which has been updated with laptop, and I grab item 1 to 3. So that is sunglasses to toys. So 0, 1, 2, and then we stop at 3. Just to make this easier to understand, let's start off with 0 here, so that we see that laptop has been changed. And then here, in the second one, on line 11, we print the Amazon cart. But hold on a second. This list did not change. And that is because with list slicing, we're creating a new list, a new copy of this list. So here we're creating an entirely new list so that I could actually assign it to a variable. New cart is going to be Amazon cart. And let's just do the same thing here. And new cart is an entirely new list on its own. I could change new cart, let's say 0 into, let's say, gum. And if I print this, you see that I have 2 new separate lists. But a list is mutable because I can change whatever is at the index anytime I want. And every time we do list slicing, we create a new copy of that list. But I have a tricky question for you here. What happens if I just do this? If I run this? Did you see that? Instead of slicing my list, I simply said that new cart is going to equal the Amazon cart. And I changed the new cart, index of 0, to equal to gum. But now my Amazon cart got modified as well. Why is that? And this is a bit of a tricky question that you might encounter in an interview. The reason is that right now, the way that I did equals means that, hey, new cart is going to equal Amazon cart. And what does Amazon cart equal to? Well, Amazon cart points somewhere in memory in our machines that says, hey, this is what Amazon cart is. So because here we're not copying the list, instead we're just saying, hey, the value of new cart is whatever is in the memory of Amazon cart. We now, when we modify new cart, are simply changing the Amazon cart all the way back from here. So this is an important concept. If you want to, let's say, copy a list, then you do something like this, where you copy the entire list, and this is something that you'll see a lot in code bases. But this line is saying, hey, I want to create a copy, use list slicing to copy this Amazon cart, and it's going to equal new cart. So that now, if I run this, you'll see that the original Amazon cart stays the same, but the new cart is now something different. This is a quick gotcha that you just have to get used to, but it's an important concept. This idea of copying versus modifying the list. And it's something we'll explore a little bit more in the next couple of videos. For now, take a break, and I'll see you in the next one. Bye-bye. Welcome back. I want to talk to you quickly about something called matrix. And a matrix is a way to describe 2D lists or multi-dimensional lists. What do I mean? Well, I can create a matrix, and this is a name that I just made, so I can call it whatever I want. But usually these are called matrix in programming. And it looks something like this. It's an array with another array inside of it. So let's say, for example, I have 1, 2, 3 here, and then another array, 1, or let's do 2, 4, 6, and then another array, 7, 8, 9. What's happening here? Well, it's a two-dimensional array. We have the main array, and then we have sub-arrays. 3 arrays to be exact. Now, why is this useful? And by the way, this is two-dimensional, but we can have multiple ones. For example, we can have another array inside of this array. But why is this important? These type of matrices come up a lot in topics like machine learning or image processing. For example, a computer doesn't really know what a photo of a dog is. The only thing it understands is zeros and ones. So a lot of photos, for example, let's say we had a very simple photograph of a giant X, maybe this letter X. Well, a computer can understand an image based on pixels on the screen. So maybe we can have 0, 1, 0, 1, 0, 0, or sorry, 1 here, 0 here, and then 1. And right now, a computer can look at this. And if this represented, let's say, a tiny little pixel here, or maybe a pixel here on my screen, the computer is going to say, oh, there's a 1 here, so that means I should make this green in this corner. then dark here, then green, then dark, green, dark, green, dark, green. And a computer is able to draw, let's say, an X. And this is a simple example. And using matrices, we can do a lot of these heavy calculations. And that's how computers work underneath the hood when, let's say, for example, it's trying to display something. But the reason I wanted to talk about this here is when you want to access a multi-dimensional list, well, you would do something like this. Let's say matrix access the first item in the matrix, which in this case will be this first array because it's the first item. And then let's say we want to access the 0 in here, or let's change this to 5. Well, I'll do square brackets again and just do 0, 1. So if I go 1 here, and let's print that out. And I click run, I get 5. So it's accessing the first item in the array. So it's going to look at the first outer array, grab the first item, which is right here, and then grab the second item in that array. So 0, 1, which is 5. And you can keep doing this. If you had multi-dimensional arrays, you can keep adding, keep adding, keep adding to access that information from an array or list. But remember, in Python, we want to use the term list. I'll see you in the next one. Bye-bye. All right, let's learn about some actions that we can take on lists. And this is very exciting because you can perform a lot of actions on lists. Now, we've learned about built-in functions, right? Functions that come with Python. And we've actually seen this one before when we talked about strings, which is the length function. And here we can have it calculate the length of a list. So for example, if we had a basket here that had 1, 2, 3, 4, 5. Well, this basket, if I calculate the length of the basket, let's do print here so we can see the result. And I click run, I get 5. The length of the basket is 5 because, well, there's 5 items. Remember, a length is the actual length. It doesn't start counting from 0. It's going to do human length, which is 5. But lists get really powerful when it comes to methods. So instead of a built-in function, remember, a method is an action that's owned by something, and it's specific, let's say, to a data type. So if we go to list methods, you'll see that Python has a few list methods that we can use. And the way we use these methods is, remember, we just add a dot after a list. So let's have a look at some of them. First, I'm going to start off with the adding ones. So let's say in this basket, we want to add something to it, to the end of the list. Well, we can use the append, and remember, with a method, as soon as you write the dot, it'll tell you what we can use, which is very, very useful when you have an editor. So the first one is append. And if I hover over this, well, it just tells me appends an object to end. And in Python, an object is, well, everything in Python is an object. A number is an object, a list is an object. So just think of it as an item for now. So if I want to append, let's say 100 to the end of the list, and you know what? Let's add a new list here, and this new list will do the append for us. If I print the new list and I click run, I get none. That's weird. What if I print basket here? If I click run, all right. So it looks like the basket was appended to, we added 100, but a new list, when we assigned it the basket.append, that new list is completely none. And that is because append changes the list in place. What does in place mean? It means that it doesn't produce a value. All it does is saying, hey, I'm just going to append 100 to this basket that you gave me. But I don't really care. I'm not producing a result. I'm just changing this for you. I know it's a little confusing. So in order for our new list to have that 100 at the end, we have to do something like this. If I click run, there we go. After we've appended to the basket, then we can assign so that new list points to basket, which points to this list that was modified. All right, what else is there? Well, there's also something called insert. And you see over here that insert gives an index and an object. So we can insert something not at the end of the list. I mean, we could, but we can also insert it anywhere we want in an index. So for example, in this case, if I do insert 100 at 0, 1, 2, 3, 4, so let's do index of 4, and I click run, I've added 100 to the index of 4. If I do index of 5 and I click run, I've added 100 at the end of the list. Now let's try and copy this and see if we can just add it into here. If I click run, again, same thing. Insert modifies the list in place. It doesn't create a new copy of the list. All right, and if we add this like this, well, once again, insert modifies the list in place. That is, it doesn't really output a new list, it just modifies whatever is existing in memory. Finally, there is another method called extend. And extend, instead of an actual item or object, takes what we call an iterable, which we're going to get into later on. But it's something that you can loop over, you can iterate over, which is a list. So we just give it another list, like let's say 100 or 101. So if I run this, once again, it doesn't output a new list, it just modifies the list in place and adds on or extends our list. And we can also just give it one item. All right, let's keep going with the removing methods. Now, with the removing, we once again have a few fun things that we can do. So let's continue with this basket that we've been using that now has 100 included into it. And the way we can remove things is, well, there's a few ways. First one is basket.pop. And basket.pop, if I go like this, and let's print this basket, I'm going to comment out the new list for now, since we're not using it. And then we're going to say basket.pop, and then print basket. Let's run this. And pop pops off whatever is at the end of the list. In our case, at the end of the list, because we've extended the basket to 100, that 100 gets removed. If I do basket.pop again, not here, down here, and I run, you see that both 100 and 5 get removed. What if I do pop 0? If I click run here, it removes the item in the index. So here, pop 0 is going to remove whatever is at index of 0, which is 1. Now, there's also .remove. Remove, again, is we give it a value that we want to remove. So in our case, let's say we want to remove number 4. Well, if we run this, it's going to remove 4 for us. So remove, we give it the value that we want to remove. With pop, we give it the index that we want to remove. And just to see if this is working, let's add a new list here. And we'll say new list equals basket.remove. Add a new list here. See if that gets modified. Nope, it does not get modified. That means remove is working in place. It doesn't return a value. It just simply changes whatever list you give it. What if we do pop? If I run this, I get 5. Why is that? And this is something that you just have to get used to. Different methods do different things. For example, pop, the way it works is that pop returns whatever you have just removed. In our case, when we did 4, that is index of 0, 1, 2, 3, 4, it returned the number 5 for me. Even though it removed it from the basket, it still returned something. And the reason for others is that we got none. That is when a method doesn't return anything. It returns none, a topic we're going to cover shortly. So you have to be careful and understand what each method returns. If I go over extend, I see here that this little arrow shows me that none is returned. That means it's not going to produce anything with this method. It's only going to change or extend a list that it was given. Don't worry if this is confusing. That's something that you're going to get used to as we get more and more practice. Now, the last removing method I want to show you is clear. And clear, as you might guess, if I click run here, well, this is none. But if I go to basket and I click run, the basket is empty. Clear removes whatever's in the list, completely clears it, just as the name suggests. All right, that was a lot, but there's still a few more. So let's take a break and I'll see you in the next video. Bye-bye. Welcome back. Let's keep going with some more string methods. Now we've learned about adding and removing ones. We learned about append, insert, and extend. And then in removing, we learned about pop, remove, and clear. There's a few other important ones. Let's go with the index. So instead of clearing here, let's clean this up. And we'll do basket.index. And index, as you can see, we give it a value, a start, and a stop. What does that mean? Well, we want to say, hey, what index is number 2? If we do index of 2 and I click run, it's going to give me 1. I know this is a little confusing, but it's asking for the index. Where is number 2? Number 2 is at index of 1. Let's change these into letters just so it's more clear. So we have A, B, C, D, and then finally E. And again, if I do D here and I click run, I get an index of 3 because 0, 1, 2, 3. It's on shelf 3 in our memory. And you can also do an optional parameter here, which is where should we start looking? So I want you to start looking at index of 0 and then finish looking at index of 2. If I do run here, I get an error. It says, hey, D is not in list because, well, we started at index of 0 and stopped at index of 2. If I do 3 and I click run, no, it stops right before 3. So if I do 4 and I click run, there you go. I get 3. Now, errors are not good in our programs. Ideally, we don't want to get errors. So how can we avoid this? What if we're looking for something and we're not sure if it's in the list or not? There's another nifty way of looking for things in a list. And this involves what we call a Python keyword. A keyword is something that you use in Python that, well, already has some meaning. For example, a keyword here, if I go to Python keywords, are all these words that already mean something. Now, we're going to go through them, and we haven't seen a lot of them yet. But we might have seen true, right? In Boolean values, true means something. So in Python, we can't really use the word true because, well, it already means something. There's a word called in that, as you can see, as soon as we type, means something, is a keyword in Python. And this is quite nice. We can say, hey, is D in basket? And if I run this, I get true. Okay, is X in basket? I get false. Because, well, it doesn't exist. And this is actually quite useful, and we can even do it for strings. For example, if I'm looking for, let's say, the letter I in a word, and let's say it's I in hi, my name is Ian. If I click run, I get true because the letter I does exist in this string. All right, let's learn another one. Another one is basket.count. And we can count how many times an item occurs. So for example, if I do D and I click run, I get 1 because D only exists once in the list. But if I add another D in here and I click run, we get 2. It counts how many times this value occurs in our list. Very, very useful. All right, a few more still to go. Let's do some exercises and I'll see you in the next one. All right, it feels like it's never going to end. We have so many methods with lists, but like I said, lists have a lot of methods because you can do a lot with them. It seems like a lot right now, but trust me, these are going to become second nature. So hang in there. I have a few more to show you. The next one is called sort. Guess what sort is going to do? If I click run, I get none. But remember, sort sorts the list, as you can imagine, in place. That means it modifies the list. So if I remove this up to here and then do sort or do basket, and I click run, look at that. I get a sorted list where D was moved in front of E. If I add, let's say, X at the beginning here, and I click run, it's going to move the X all the way to the end. It's going to sort the list in place for me. Again, if I hover over, it sees that it's going to not return anything, which is why our print initially didn't work. We had to print our basket, not whatever this produces, which it doesn't produce anything. But what about this one? If we go to built-in functions, I have something called sorted. And if I do sorted, and because it's a function, not a method, I can do sorted dot or basket. So around the brackets, just like print. If I run this, all right, nothing has changed. But what if I remove this and put it in here? If I click run, I get A, B, C, D, D, E, X. What if I comment this out? So that we're not sorting it anymore. We just have the basket and then we run this sorted function. If I run, did you see that? Sorted, I know it's confusing. Why do they even have two? But sorted produces a new array. So if I do print basket here and I click run, the basket hasn't been modified. The basket still remains the same. It's this one over here that's not sorted. Sorted, on the other hand, doesn't modify the basket in place. Instead, it creates a new copy of the basket and sorts it. It's almost as if we're doing this. We're saying new basket equals basket, and then we're going to copy that basket. Remember, list slicing. And then we're performing new basket dot sort on this new list. So that if I do new basket and I click run, we get the same thing. So you have to be careful of certain actions that perform an action in place or create a completely new list to begin with. By the way, there's also, instead of this, a .copy method that we can use. And if I run this, again, we get the same thing. Copy, just as the name suggests, copy the list for us and returns for us a new list. All right, one last one, and that is basket.reverse. What do you think this does based on the name? Well, if I check out the basket here and click run, is that what you expected? It reverses the basket in place. But notice that it's not like sort. It's not sorting. It's simply switching all the indexes into opposite sides. So D is now index of 0, E is now index of 1, index of 2, 3, so on and so forth. So you can see here that it doesn't actually sort it. Instead, what we might want to do is sort first, then reverse, and if we click run, we have a sorted, reversed basket. This is a little tricky one that some interviewers might ask. All right, good job getting this far. We're almost done with lists. So I'll see you in the next video. Bye-bye. Welcome back. Let's talk about some useful tricks with lists that you'll see a lot in Python code. Well, one we have already seen. It's this idea of length. You're going to be using this a lot. That is to figure out the length of a list, which in our case is now 7. Another really useful trick is to reverse a list. Now, I've already showed you how to reverse a list, but sometimes you can do that with list slicing. Again, something that we've seen in string slicing. So I can actually do basket and then semicolon, semicolon, -1. If I click run here, is that what you expected? Let's go through this line by line. I've sorted the basket so that it's from A all the way to Z. And then I've reversed this so it's in Z all the way to A. And then I've reversed the basket again so that instead of being in reverse, it's now in order, A, B, C, D, E, X. And this list slicing creates a new list, right? If I print basket here, you'll see that the basket is the reversed version, the last action that we've taken on it, versus list slicing that creates a new version. So this notation you'll see a lot with lists when you need to reverse a list, or maybe you need to make a copy of the list like this, or maybe you need a portion of the list. Another useful thing that you'll see a lot of is something called range. Let's comment this out for now. If I wanted to generate a list really quickly, let's say from 1 to 100, I can do something like this. I can say range and then start and then stop. So let's do 100. And if I print this and I run, I get a range 1 to 100. But if I wrap this in a list, which is going to create a new list for us, and I click run, look at that. I get a range from 1 all the way to 99. Remember, it's the start and then whatever to stop at. So before it hits 100, it's going to stop. Now, if I remove this and just do one single thing, I get a list starting from 0 all the way to 99. If I want a list that has 101 items because it starts at 0, I would just do 101. And range is something we'll talk about a lot more, especially when we talk about loops in programming. But this is a great way of you to generate a list really, really quickly, especially a numbered list. Finally, the last common thing that you'll see a lot is this idea of dot join. What is dot join? join is actually something that works on strings. It's a string method, but it's often used this way. We have an empty string, and this empty string, let's say sentence. And then we can do sentence dot join, and join takes what we call an iterable, which is a list for now. And in here, we can have a sentence like, hi, my name is Jojo. And now if I print sentence and I click run here, I don't get anything. Let's figure out why. What if I type in an exclamation mark here and I click run? All right, it's printing out sentence, but it looks like .join creates a new item for us. So let's just assign that to new sentence. Now, if I do new sentence and print that out, we see that I get, hi, my name is Jojo. So this is a little funky, right? We have these exclamation marks between our items. And join joins these little iterable items, these lists, by whatever is in front of it. So if we actually change this to an empty string, click run, we now get this. If I add a space in between and click run, we get, hi, my name is Jojo. And sometimes you'll notice this pattern a lot, especially if you want to join and create a new string out of a list of items. Now, a shorthand way of doing this is to actually not even bother with this and just doing an empty string, dot join, and then joining all the list items. There we go. So all we're doing is combining lists into a string, and this is a common pattern that you'll see a lot of. I'll see you in the next one. Bye-bye. I want to teach you one last thing when it comes to lists, and it's called list unpacking. And it's a really, really nice feature. I really like it. With list unpacking, we can do something like this. Let's say I have a list that is, well, very simple, 1, 2, and 3. And I want to assign a variable to this list. Let's call it basket equals 1, 2, 3. But what if I wanted to assign a variable to each item? Well, I can actually do something like this, A, B, C. So that when I print A, and then let's print B, and then print C, and I click run, I get 1, 2, 3. And this is something that we've seen when we talked about variables, where even if it wasn't a list, as long as we gave it by comma, separated by comma, different values, we're able to print 1, 2, 3. But this is where list unpacking gets really, really useful. We can actually, let's say, extend our list to include all the way till 9. What if we wanted to unpack 1, 2, and 3, but keep everything else still in a list? Could we still do that? Well, with list unpacking, we can. All we need to do is say comma, and then add a star, and give it a variable name, whatever we like. Let's say other. So now if I print other, and I click run, look at that. I'm able to unpack my list however way I want. What if I add a comma here and add D? Well, if I run this, I get a list all the way until 8. But now D is, well, actually, the very last item. So that's very, very neat. Maybe the use case right now is not absolutely clear to you, but this is something that might help you, another tool in your toolbox, to unpack a list and change a list in different ways. We'll explore this more later on in this course. But for now, list unpacking. When you hear that word, now you know what it means. I'll see you in the next one. Bye-bye. Welcome back. When we talked about lists, we saw our special type of none, where some methods that worked on lists didn't really produce anything. They modified the lists in place, but the output of whatever they were doing was this thing none. Remember how we had in the output this none? What does that mean? If you remember, I mentioned none as a special data type that exists in Python. And most languages have something like this to represent the absence of value. In some other languages, you might have heard of null, which is another thing that, again, represents the absence of value. Now, why is this useful? Well, for now, it's hard to really conceptualize it. We'll see it being used a lot more as we get further into the course. But I could do something like A equals none. Let's say, for example, we're just starting a video game. And in this video game, we have a user's weapons. But when you're just starting the game, there are no weapons that the user has. Well, in that case, we might want to assign the variable weapons. Maybe in our code, we use this variable, but we also want to know that this user doesn't really have any weapons. It's none. So this is completely valid Python. If I run this, I get none. And we'll explore this a little bit more throughout the course, like I said, but hopefully this way you're not intimidated when you see it. As the name suggests, it's just nothing. Let's talk about our next data structure. And this one is called a dictionary. In other languages, it might be called a hash table, maybe map or objects. In Python, we have this idea of dictionary, or as Python likes to call it, dict. I have to make sure I pronounce that properly. That's a really hard word to say when you're recording and you're repeating it over and over. Anyway, dictionary. What is it? Well, it's a data type in Python, but it's also a data structure. Remember that I mentioned this idea of data structure when we talked about lists. They were the first data structure in Python that we learned. It's a way for us to organize our data in a form that has some different pros and cons on how we access it. For example, with lists, we saw that they're easily ordered. We can access them through indexes like 0, 1. We can reverse them. We can insert into them. It was really, really nice. What about dictionaries? Well, let's see what a dictionary looks like. A dictionary will look something like this. We'll have a key and a value. Then another comma, and then another key and another value. Let's decipher this. So I'm using curly brackets here, which denotes a dictionary. And unlike a list, we have what we call a key-value pair. A key is a string for us to grab the value. What do I mean? Well, in order for us to access any of these values, I would go dictionary and then say the key. In our case, let's say we want to grab B. We would grab the key, and then when we print here, the result, we get the value 2. We're essentially telling the computer, hey, I have this variable dictionary. Remember, I can name this whatever I want. I have this variable dictionary. I want you to go find the key B. And this key B, if it exists, grab me the value. So it's going to go into your memory or into the machine's memory. It's going to find where B is stored in our memory and grab the value. So in the bookshelf B, we have the value 2. What if we do C, which doesn't exist? If I click run, nope, I get an error. It tells me, hey, sorry, you're looking for key C, but I don't really have that key. And this is what a dictionary is. A dictionary is an unordered key-value pair. What do I mean by that? Unordered means that they are not right next to each other in memory. Remember, with lists, we could access lists with index of 0, then index of 1, index of 2. All those bookshelves were right next to each other. A dictionary, on the other hand, they're all over the place. Although I've put A and B here, this might be in one spot in memory, and this one in another spot in memory. And if I added, let's say, X, this will be in another spot in memory. And this might not be in order. Maybe I've written it A, B, X, but when I actually return the entire dictionary, maybe I don't have this in order. These are all just scattered all across our memory. As you see here, when I receive the dictionary, I get these things in order, but that's only because it's small. If I had a really, really large dictionary, I might not have them in order that I've inserted it in. So a dictionary is an unordered key-value pair. And as long as we know the key, that is, whatever the key that we're looking for, then we just give that. And our computer is going to know, hey, where in memory to look to grab the values. Now, here's the cool thing about data structures, like dictionaries and lists. They're containers around data, right? So this can be anything that we want. Let's say we want this one to be a list, 1, 2, 3. Maybe we want this to be a string, hello. And maybe this is a Boolean value, like true. That is completely valid. I can access the A like so, and I get the list. What if I want the second item in the list? Well, I do index of 1, like this. And there you go, I get 2. And this is the same with lists. And you'll see this a lot, where if we had a list, or let's call it my list, and my list contains a dictionary that has, let's say, A, 1, and you know what? Let's just copy and paste this. We'll do this. So we'll have the first item in the array, like this, then comma, then another item in the array, and this time around, this one has 4, 5, 6. So that I can now grab from my list the first item in the array, and then maybe grab the A, that is the A key. So remember, this is a string. And then we want to grab, let's say, the third item. So we'll go 2. If I run this, I should get 3 and 2. There you go. Now, you might be asking yourself, what's the deal with these data structures? Like, why do we need dictionary? Why do we need list? Why can't we just have one thing that does everything? Isn't that simpler? Think about that, because in the next video, I'm going to try and answer that question for you. Let's talk about our next developer fundamentals. And this one is understanding data structures. A really good programmer is a programmer that is able to decide what data structure to use when. Up until now, we've learned about dictionaries and lists, and we'll learn about a couple more throughout the course. But a really good programmer, a programmer who's experienced, is able to understand what the trade-offs are, when to use what. And although I can give you a list of this is when you should do this, and this is when you should use maybe dictionaries, the thing is, this takes practice and experience. So throughout our course and then the exercises that we're going to do, the projects we're going to build at the end, I hope that this idea of understanding when to use what data structure makes sense to you. But let's go back to our example. When should you use a list and when should you use a dictionary? Well, the first thing we have to realize that a dictionary is not sorted, right? A list has order. It has 0, 1, indexes, so on and so forth. A dictionary has no order. So maybe if you want to have a list of people in line at your shop, well, you should probably use a list. But maybe you have a user that is playing a game, and that user has first name, maybe weapons, maybe an age. That doesn't have to be ordered, so you might use a dictionary. Also, you'll notice that dictionaries hold more information than lists, right? Because lists only have that single value. That is, a list has the index and then whatever the value is. And here we have a dictionary inside of a list, which is holding a lot of information. Deep down, a list is simply an index and some sort of value here, right? Versus a dictionary that holds a lot more information. It holds a key. So this could be the weapons of that user. Hello can be the greeting of that user. Maybe is magic is another information about that user. So we're able to have both keys and values in a dictionary. So it holds a lot more information. And as we learn different data structures, you'll have these different pros and cons. You'll start to understand as to when to use what. All right, there's another Developer Fundamentals. I'll see you in the next one. Bye-bye. Welcome back. I mentioned to you that a dictionary's values can hold any sort of data type. But what about the keys? Up until now, I've only used strings to denote a key. But could I do something like this? Could I do 1, 2, 3 like this? Well, let's have a look. Let's give it a try. If I do 1, 2, 3, and I click run, I get 1, 2, 3. Awesome, that works. What about true? If I have a key true and I click run, will that work? Yep, it looks like it works. What about a list? What if I have a list of, let's say, just 100? Would that work? If I click run, nope, it doesn't work. It says unhashable type list. What does that mean? Dictionary keys need to have a special property. A key needs to be immutable. That is, a key cannot change. And numbers, booleans, this is a value that cannot change. A string, if you remember, is a value that cannot change. It's immutable. But a list, if you remember, can be changed, right? On a list, I can reassign, let's say, the index of 0 to something else, right? So because of that, a dictionary says, hey, my keys, because I'm storing them in memory and I don't want to lose them, it has to be something that isn't going to change on me. Maybe a programmer comes in and by mistake changes this array of 100 to have an index of something else. Well, dictionary doesn't really want that because it doesn't want to lose this value. So a dictionary key always has to be immutable. And as we learn a few other things like a tuple that we'll see in upcoming videos, you can use those as keys as well. However, most of the time, 99% of the time, a key for a dictionary is usually something descriptive like a string. Okay, but what about this? What if we have another string, 1, 2, 3, and let's just remove this for now. What happens when I search for 1, 2, 3, the string? If I click run, I get hello. A key in a dictionary has to be unique because there can only be one key, because that key is going to represent a bookshelf in that memory space. So anytime I do the same key and maybe add a value, it's going to overwrite. So this no longer exists. A key has to be unique, and it's something that can only exist, well, just once. Otherwise, we overwrite it, which is why you see hello here. We've lost the array 1, 2, 3. Let's explore this idea a little bit more in the next video. Welcome back. Now, if you remember, let's have something different here. So we have unique keys. If you remember, we have to have unique keys. So let's say this is greet, and this is let's say a basket. And we can access basket like this. If I click run, I get 1, 2, 3. But what if we don't know what this dictionary is? Maybe a dictionary is something, well, somewhere else where we can't see. But we want to know if this, let's call this user, if this user has maybe property like age. So do they have this age key? Well, if I click run, I get an error, key error, age. Age doesn't exist. But remember, errors in our programs, and this is something we'll cover later on, are not good. They're going to stop the program as soon as the Python interpreter enters an error. It's going to kick out of the program and say, hey, you have an error, and it's going to completely ignore what's underneath it. Here we don't have anything, but in a real life program, we want to avoid these errors because it stops execution. So another good way to access a key and to see if it even exists is to use .get. And guess what .get is? Did you guess a method? Well, there you go. .get is a method on the object or the dictionary in Python. So here, if we do get age and do run, I get none. So my program doesn't error. It just says, hey, there is nothing there. It's an absence of value. And we've learned what none means by now. So that's a really nice way to avoid those errors. By the way, if let's say there's no age in the user, but you want to have a default value, you can do something like this. So you add a comma, and then here you say whatever you want as the default value. So let's figure that out. If I click run, I get 55. Because now I'm saying, hey, grab the age from the user dictionary. If age doesn't exist on the user dictionary, use 55. So now we have 55. But if the user already has age, and I click run, I get 20. So this is, hey, in case age doesn't exist, add a default value. That's really, really nice. Now, I'm going to show you another way to create a dictionary, which is not very common. Most of the time, you want to use this syntax. But just so you're aware of it, here's another way. Let's say we have a new user, so user 2. I can create here a dictionary by saying dict, which again is a built-in function. And in here, look at that. It shows me, hey, this is going to create a new empty dictionary. And we can create different values, key value pairs. And we simply say, I want the key to equal the value. So in my case, let's just say that I want the name to equal John. If I now print out user 2, well, before I click run, I see that I have a red underline. And by the way, if you see here PyFlakes, that's something called linting, something we'll talk about when we talk about developer environments. We're using this linter that tells you whenever you make errors in Python, and it says keywords can be an expression. That just means that, hey, the keyword needs to be, well, just a variable that we create. So if I click run here, look at that. I have name John. So we've created a user with this key value pair. Now, like I said, this way of creating dictionaries is not very common. Most of the time, you'll do something like this, but at least now you know that this is why this built-in function exists. I'll see you in the next one. Bye-bye. By the way, there is actually one more way that we've actually seen in lists how to look for an item in a dictionary. Remember how in lists we used the keyword in? We said something along the lines of, hey, is I in a list that contains I? Or we even used a string like hi. Well, you can do the same with dictionaries. I can say, does basket exist in user? And let's print this out. and run. And it's going to say, yep, basket does exist in user. What about size? Does that exist? Nope, that's false. That does not exist in user. But here is where it gets really interesting. And this, again, is another dictionary method that we can use. And by the way, you can see that there's not that many dictionary methods that, well, dictionaries have. Luckily, we're going to go over the main ones here. The one is called keys. And keys simply checks the keys. What are the keys of user? So if I go hello here and I click run, well, no, keys are, on this side, not this. So this is a value. So if I want to check keys, I'd say age, which is true. But if I want to check values, well, in that case, if I do hello, I get true. It's going to go over, or what we call iterate, over the values. Another one that's really useful is the items. And items is special because we've seen keys and values, but items actually grabs the entire item. So the way we can actually see this is, let's just remove and click run. All right, this is interesting. I have dict items here, and I grab, looks like a list, and in here we have a bracket, basket, 1, 2, 3, greet, hello, and age 20. But there's some weird syntax here that we haven't seen before. And this is actually a tuple. So we're going to hold off on this and talk about this a little bit more when we talk about our next data structure. But keys, values, and items is an easy way for us to grab these things for us from our dictionary. Let's continue on with other dictionary methods that we might use. One is a very nice one. It's called clear. And if I run this, you see that I get an empty dictionary. What if I just run users.clear here and run user? Well, it's still an empty object or an empty dictionary. So you can see here that clear doesn't actually return anything. It doesn't, well, it's just in place, removes whatever the dictionary has. So it just creates an empty dictionary. What about copy? Well, a copy allows us to copy a user so that if I print user and user2 and I click run, I get 2 users, each keys and values copied. But if I now, let's say, clear the first user and I click run, the first user is empty, but because I've copied the second user has the old information. And this is a concept that we've talked about before. Another useful command, and let's just go back to having user, is user.pop, which removes a key and a value from the dictionary. So in our case, let's just say we want to remove the key that is age. So I'm going to say age. And if I run this, I get 20 because pop returns the value of whatever got removed. But if I do print user now, you'll see that age does not exist anymore because we've popped it off. But pop, as you can see, removes the actual value or returns the actual value 20. Here's another really fun one, pop item. And honestly, this I haven't used much, but I just think it's a fun one. Pop item, if you guessed, well, you're not going to guess. Oh, and that's because I have to make sure I write it properly with lowercase. If I run this, what just happened? It randomly pops off something. One of the keys and the values. In this case, age 20 is removed. So the last item on the dictionary gets removed, but remember, a dictionary is unordered. So if this was a massive, massive dictionary that, well, doesn't have any order to it, sometimes it removes some pair, as you can see, not the last one, but some pair of key value. So you have to be careful with this one. It doesn't necessarily just remove the last thing that you entered, but it might be useful on some occasions. Finally, we have something called update. An update simply updates, as the name suggests, a key value. So let's have a look here. All we have to do is give it a new dictionary, so curly brackets, and just simply say, hey, I want to update age to 55. If I click run, oh, and I forgot a bracket here. Let's try that again. If I click run, there you go. Age got updated. But if this was a key that doesn't exist, like ages, and I click run, it will still update with a new key item. So this is another really useful method. All right, that's it for dictionaries. I'll see you in the next video. Hooray, it's time for our third data structure as we continue down to our different data types in Python. And this one is called a tuple or tuple, depending on how you like to pronounce it. And we actually saw this slightly when we talked about dictionaries. But before we get into that, what are tuples? Well, a tuple are like lists, but unlike lists, we cannot modify them. They are immutable. So you can think of them as immutable lists. And they look like this. So let's call it my tuple is going to use brackets to denote a tuple. And we can do 1, 2, 3, 4, 5, just like a list. Now, you remember how in a list, we could have modified this and said index of 1, well, now is going to equal z. If I run this, it's going to error out. It's going to tell me, hey, tuple object does not support item assignment. A tuple is immutable. Once you create it, it's the way it is. You can't sort it or reverse it like we saw with lists. It's just there. What about this? Can I just print a tuple and just grab the second item on that tuple? Well, yes, you can. Just like a list, you can access it through an index. Can I maybe do, does 5 exist in my tuple, just like we could in a list? Well, yes, we can. The difference is that it's immutable, right? Now, why do we need this? I mean, we already have lists, so why do I have to learn tuple if, it's pretty much the same as list? It's the only thing is I can't change it. There's a few benefits to this. For example, if you don't need to change the list, that makes things easier because it tells other programmers looking at your code, hey, this shouldn't be changed. Unlike a list, I want this to stay the way it is. Keep this order. So it makes things easier and more efficient. It makes your code safer because people can modify it, right? It makes code more predictable. However, it makes code more predictable, but it's less flexible than a list. I can't really sort a tuple. I can't run reverse on tuple. Now, because of this, because they are less flexible, the other good thing about them is that they're slightly more performant than lists. So they're usually faster than lists. And if you don't need a list to change, well, use a tuple. So a good use of a tuple, for example, if you work at Uber, is geographic location and coordinates, right? You can have latitude and longitude here. And because, let's say, this won't change, or maybe a user's location or pickup point doesn't often change, we can just use a tuple. However, maybe when you're in a car as a driver and you're an Uber driver, well, you probably need your coordinates, your latitude, longitude in a list because your car is moving. That's constantly changing. And we saw tuple when we talked about dictionaries, right? Remember when we did user or we did user.items? And then I said, hey, just print user.items. And we saw here that we got a dictionary items. And inside of this dictionary, we see that basket 123, greet, hello, and age 20 are a tuple. So this actually returns our key and value as a tuple. And as I mentioned before, a dictionary can have keys that are immutable. So a tuple is a completely valid key in Python. So I can do 1, 2 here, and that is a valid key in a dictionary. And the way I would access this would be like user curly bracket 1, 2. So that if I click run here, oh, I have an extra bracket. Let's fix that. Let's click run again. And there you go. I'm able to grab user tuple 1, 2 and grab 1, 2, 3 list. You see here how I'm trying to use different data structures, combining them together. Let's take a break and finish off our understanding of tuple in the next video. Now, tuples, like I said, are quite similar to lists. So if I wanted to, I can say new tuple and use my tuple and then slice that tuple. So for example, if I do 1, 2 like this and print new tuple, I'm going to get 2, comma. Why is that? Well, we start at 0, 1 and end at 2. If I did 4 here and click run, I get 2, 3, 4. It's still a tuple, but you have to remember that a tuple that only has a single item tends to have this little comma at the end, but it's still a tuple. And just like a list, I can assign different things. For example, I can say x equals to my tuple 0, and then I can say y equals my tuple 1, and x and y will equal 1 and 2. But a short form of doing this, again, similar to lists, is to say, hey, I want x, y, z, and you know what? Other to be the values assigned from the tuple. So that if I do x here and I run, I get 1. If I do z and I run, I get 3. What if I do other? And if I click run, I get 4 and 5 as a list. All right, if your head doesn't hurt by now, don't worry, I have some good news. Luckily for us, a tuple has only 2 methods that we care about: count and index. How nice is that? So nice and simple. Guess what these mean? So let's go back to my tuple and now try these out. If I go my tuple.count, well, it's going to count the value. So if we want to count how many 5s occur in the tuple, I get 1. If I had another 5 in the tuple, I get 2. What about index? What's the index of 5? Well, the index of 5 is 4. Because 0, 1, 2, 3, 4, the first value that it finds, it's going to return the index of. And then finally, we can also do length, right? We can use this built-in function to run length, and it's going to tell us that, yep, it has a length of 6. Awesome. There it is. We're flying through them now. This is our third data structure. Remember, they're simply lists that are immutable. I'll see you in the next one. Bye-bye. Can you believe it? I hope I didn't put you to sleep, but we're almost there. We have one last main data type, set, and then we're done. I know this isn't the most exciting topic. Trust me, this is the hardest part. When you're starting out and you're just learning these things without understanding, why do I need this? How am I going to build the next game? How am I going to build the next Netflix? How am I going to build the next coolest Apple app? you're looking at this and thinking, I just learned a bunch of theory. I feel like I'm in math class all over again. I know, trust me, I went through this. I was a self-taught programmer as well. These are the Lego blocks that builds our foundation. Once we learn these, we can move on to new things, and you'll see that once you climb this little mountain, things become so much easier. And you'll realize the power when we start building these projects toward the end of the class, where you're going to say, oh, all these blocks that we learned, all this frankly boring part is all going to make sense. So hang in there. It's supposed to be hard. It's supposed to be tough, but you'll see very soon why this is so powerful and why what we've just learned is going to allow us to build some really awesome things and create some really awesome programs. So let's finish off with the last one. The last data type, the last data structure that we'll see in Python, at least from the main ones. And it's called set. And sets are simply unordered collections of unique objects. Let's have a look. Let's create a my set. And my set we create with curly brackets like a dictionary, but instead of a dictionary, we don't have key value pairs. Instead, we just have values like 1, 2, 3, 4, 5. That's it. That's a set. We just created a set. But remember the definition I gave you. Set is an unordered collection of unique objects. What does that mean? Well, if I print this and say my set, and I click run, I get a set. But if I had, let's say, another 5 in here, and I click run, it only returns the unique sets or unique items. You see, in a set, there's no duplicates. Everything has to be unique. So this 5 just never gets added to a set. For example, you can add things to a set like my set, and then I can say .add and give it a value like 100. And then let's say I do my set.add and then give it 2. If I click run here, I see that I was able to add 100, but 2 wasn't really added because my set already contained that data. It's unordered. I mean, we've created 1, 2, 3, 4, 5 here, but there's no real order to it. There's no bookshelf in our memory space that is right next to each other. These are all over the place in memory, but a set is able to find them because they're all unique. So they're all in just one location in memory. So let me ask you this, and this is going to be a fun little exercise. If I gave you an array, and let's say this array contained, this right here. And I want you to return an array with no duplicates. So I want everything in, let's call it my list. And a programmer has already created this. Okay? And then your task is to create or return a list or a collection that has only unique items. How would you go about converting this into a set? Well, we've seen this before. We have a set function, and we simply wrap my list in that set. And let's print it out. I click run. Check it out. We have formed a new set from a list. And I've removed all duplicate values. When would this be useful? Imagine if we had usernames, right? Or email addresses. We're collecting email addresses on our startup page, but we don't want to have duplicate emails. We might want to convert this, a list of emails, to a set and remove any duplicates so we're not sending emails over and over. So that's really cool. What about this? Let's change this into a set. So let's call it my set. Going to change this into a set. There you go. And then what if I wanted to access my set at index of 0? Set object does not support indexing. Well, again, you can think of it more as a dictionary. In order to access a set, we have to grab by the item that's in it. That's the key to getting the information from memory. The way we would check if something exists is we simply say, hey, is 1 in my set? And we run this, and we get true. We can also do length of my set, and we get 5. Again, nothing too crazy, but 1, 2, 3, 4, 5. Remember, it only counts the unique things because this will never get entered. It's a set. And alternatively, we can also convert this into a list. If I click run here, you'll see that I now have my set as a list. And then we can also do, let's say, my set.copy, and actually copy my set into something, let's say, new or new set. And then this will be completely different or a new copy than this original one. So let's test this out. This new set, if I use a method that we may have seen before, which is my set.clear, which as you can imagine, clears the set, and I click run, I have that new set, but when I try and print our old set, which was my set, it's going to be empty, an empty set. But the true power of sets comes in the next couple of methods that I'm going to show you. And sets have quite a few methods, but don't worry, most of them are quite similar. So let's explore that in the next video. Welcome back. The methods we're going to talk about when it comes to sets are right here. It looks like a lot, but they're quite similar, so hang in there. I have 2 sets for us. Our my set, which is 1 through 5, and then your set, which is 4 through 10. Now, let's go one by one and see what these methods do. And if you've ever seen Venn diagrams in your school, for example, 2 circles that are overlapping each other, what we're about to do is quite similar to this. The first one is difference. And sets are very useful when having 2 sets and comparing them to each other. So for example, in here, difference simply says my set dot difference, and we give it another set, such as your set. If I print this right here and I click run, I get 1, 2, 3. It's going to find the difference of the first my set with your set. So any duplicates between the 2, which is 4 and 5, gets ignored, and it only shows the difference, that is 1, 2, 3. What's different between my set and your set when viewed from my set? Well, your set doesn't have 1, 2, 3. What about the next one? Discard. Again, if we do my set dot discard, it says it removes an element from a set if it is a member. So here we can say discard 5. And if I do print my set and I click run, I get none. But if I print here my set and I click run, I get 1, 2, 3, 4 because we've just discarded 5. It modifies our set. Just to keep our working space clean, I'm going to comment these out. Next is difference update. So I'm going to say my set, and then once again, let's see what difference update does. Remove all elements of another set from this set. So if I do your set here, and once again, I do print, and I click run, I get none because it just modifies my set. So remember, we just have to have our print, my set, and now this my set is updated with just 1, 2, and 3 because we're updating it so that the differences are removed. So 4 and 5 are removed. Unlike difference, where it just told you the difference without changing. Again, if we go back here and simply do my set, and I click run, you see that my set here was not modified right here, but then my set bottom was modified because of difference update. All right, a few more to go. Intersection. And this one, once again, my set. And in here, once again, let's read what it does. It just has intersection with something else. Well, let's find out. If I do your set here, and I do print, and I run this, it's going to give me 4, 5, because that's the intersection, the two common things that my set and your set has. What about is disjoint? Well, if I do my set and then your set, I feel like I'm saying those words over and over. Hopefully that's not too annoying. And then here, if, let's comment this out, we run this, I get false. Is disjoint simply says, hey, are those two circles overlapping? Do they have anything in common? If, for example, my set didn't have 4 and 5, and I click run, I get true, because is disjointed means these sets have nothing in common. Awesome, just a few more. The next ones we're going to see is subset and is superset. But actually, before we do that, let's do union. Let's see what this does. Union will say my set. And in here, we want to add the other set, your set. If we print this and click run, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What did that just do? Well, union just united these sets together, but removed any duplicates. That's kind of nice. And as you can see, it created a new set for us. It returned a new set. By the way, there's actually a shorthand that you can do here in Python, which is the shift and then the key above your enter, which is right here, this straight line. So shift and then the backslash, but if you press shift, you'll get this little straight line. If you print this, well, remove the brackets here. Let's run again. And you see that works as well. And by the way, this also exists for intersection. Again, you don't see it that often, but with intersection, you can do the same thing where you just do the and. And if you do that, it gives you the intersection of my set and your set. All right, I promised you this is going to be short, so 2 other ones. Is subset and is superset. As you can imagine, my set, if let's say my set only has 4 and 5, and I say, hey, is my set, is that a subset of your set? And I print this. If I click run, it's true. My set is a subset. That is, it's inside of the circle of your set because 4 and 5 is inside of it. So my set, the entirety of my set is inside of this other set, which we call a subset. On the other hand, we also have this idea of superset. So if I do, instead of is subset, is superset, I'll get false because, well, my set is not a superset. It doesn't encompass your set. It's the other way around. Your set is a superset of my set. Because your set encompasses everything that my set has, which is 4 and 5. Oh boy, that was a lot. And you're asking yourself, there is no way I'm going to memorize any of that. Well, good. I don't memorize any of this either. As a matter of fact, I usually go to the Python documentation or just Google around And because I know sets exist, if I ever want to compare, let's say, two sets, I know to just go here and find the tool that I want. That's the key of a programmer that I keep mentioning over and over. It's not memorization. It's the ability to know that there's tools that you can use and being able to Google for them. I know it doesn't sound exciting because in movies you see everybody typing super fast and coding everything, but that's just not real life. In real life, you just Google around, find solutions, because by now you know what sets are, you know what sets can do, so that you can Google for methods that are appropriate to your problem. I'll see you in the next one. Bye-bye. Welcome back. We learned about our basic Python data types. We also learned a little bit about some of the terms that we might use when talking about code. We learned a few best practices, but most importantly, we learned how to perform actions on these data types. We saw that there's built-in functions that we can run on any data type, such as the print function. But we also learned that most of these data types have their own methods. That is, that dot some sort of a name and then the brackets to perform some actions on them. Now we're still scratching the surface here, but we now go into an area that gets really, really exciting. Because up until now, what we've been doing is this. Every time we write code, we do something here, and then we go to the second line and do something else, and then finally go to the third line and do something else, and so on and so forth. Our Python interpreter just went line by line, one all the way to whatever line number we have on our .py file, and just ran the code. And it ran it really fast because machines are good at that. They run code really fast. But we haven't discovered the true power of programming, and specifically programming for machines. You see, the power comes when we start to incorporate the idea of maybe running multiple lines over and over, or maybe skipping a line and going from line 1 to line 3. And in this section, we're going to talk about the idea of conditions and conditional logic. We're going to talk about looping and loops, where we can perform actions hundreds, thousands, millions of times over and over, something that machines are really, really good at. And that's when programming becomes really powerful, because machines can do certain tasks a lot better and a lot faster than humans. So we're now going to break into a new world where instead of going from 1, 2, 3, everything in order, we're going to start to break some of that apart so that we have more control over our programs than just going line by line. Let's find out how to do that in the next video. Let's talk about conditional logic, an important concept all over programming. What do I mean by conditional logic? We've learned about Booleans, right? We have true and we have false. And some of you might be wondering why they're so useful. And when it comes to conditional logic, Booleans are really, really important. For example, let's say we create a variable, is old. And you know what? We're going to create a car that automatically detects if you can start the engine. Maybe if you're not old enough, the engine won't start and it won't let you drive. So that they make sure that this car is super safe and only people that are perhaps over 18 can drive it. So how can we code something like that? Let's assume Tesla has a new feature like that. Well, we'll have something like is old, and we'll set this to true, right? Maybe we have something else. Maybe it checks the license to make sure that we have a license. So we can say is license. And then we can set it to true. Now, these could change, true and false, depending on the user and the driver. But when I talk about conditionals, this is what I mean. In Python, we can use the if keyword to say if some condition exists, and this is just me writing it doesn't exist. You can see that I get a red underline with invalid syntax. But here we want to say a condition that evaluates to true or false. In our case, we can say, hey, if is old, which what does it evaluate to? Well, it evaluates to true. If that's true, then let's say print you are old enough to drive. Now, there's a few new things here. One, I've added a semicolon or a colon, and then you'll see here that the indentation is different. As a matter of fact, when I press enter after the colon, you see that it automatically gives me a space. This tells the Python interpreter, I'm going to do an if statement, a conditional operation. And if this happens to be true, run everything that's inside of here that has this indentation. And if I do something without the indentation, let's say print check, check, this to the Python interpreter is like a completely new line. It is not part of this if block. And if you're using the REPL, you see over here I get a little minus sign. If I click this, you see how it hides? Well, what it does is it's saying, hey, this is a code block over here. It's an entire thing in itself. But anything outside that is not indented, well, doesn't belong to it. So to a Python interpreter, it's going to say, I have this line, and then I have this line. Let me show you what I mean. If I run this program, I get, you are old enough to drive, and then I also get check, check. But what if I say is old is now false? What do you think will happen? If I run this, I get check, check. Our Python interpreter is going to say, hey, set variable is old to false. Hey, set is licensed equals to true. And then it's going to go to line 3. Nope, nothing there. I'm going to keep going. Line 4, hey, if is old, is this true? No, if old is false. And the interpreter is going to say, okay, I'm only supposed to run this piece of code if this is true. Because this is now false, I'm just going to completely ignore what's underneath here and just go to the next line that has, well, no indentation. So it's going to print check, check. And this is the power of conditionals. We're able to essentially skip lines. The interpreter doesn't even care what's in here because I just told my program to skip from line 4 to line 6. How cool is that? So we learned that there's this if keyword, but there's also another thing we can use called else. And you'll notice here that I didn't add it to the indentation. And else, as the name suggests, simply says, hey, if this something is true, then do this. Otherwise, also else, do this. And again, you see that I've added the indentation. So try to guess what's about to happen in this program. If I click run, I get check, check, because it's saying, hey, is old, is that true? Nope, it's not true. Okay, I'm going to completely ignore that. The interpreter sees else. Okay, well, this wasn't true, so I'm going to run. Whenever this evaluates to false, I'm going to always run print check, check. What if I change is old to now equal to true? What will happen next? Well, I get you are old enough to drive. Else only runs if the if block of code evaluates to false. Very, very cool. All right, let me ask you another question. What if I did print here? And let's change this to you are not of age. If I run this, is that what you expected? Well, I hope by now you agree that this is the expected behavior. Because is old is true, I'm going to print this. And then Python interpreter is going to say, well, this was true, so I'm going to completely ignore the else block and then just go to the next line. What's on line 8? Nothing. So I'm going to go to line 9. And now I'm going to print OK, OK, OK. As you can see, we're now controlling the flow of our programs, where instead of going from 1 to 9, just line by line, we're now saying at line 4, do some sort of check, and based on that, skip a few lines. Very, very cool. All right, there's one other thing I want to show you, and it's the if. And I know this kind of looks weird. You would think that it'll be else if, but no. It's if. And what do you think this does? Well, you use it in combination with if. You say if something, if otherwise, else, if another condition, so let's say is licensed, then do another condition. So let's say print you can drive now. So let's go through this again. I'm going to say, is this person old enough? If that person is old enough and this evaluates to true, well then I want you to run this. Otherwise, I want you to run this condition. Hey, is this true? No. If it's not true, then jump to else. So what will happen here? If I click run, we get true for the first conditional block right over here. So automatically Python interpreter is going to say, well, we just got true here, so I'm going to ignore this and ignore this, and then print OK, OK. But let's say that is old is now false. What will happen next? If I click run, this is false. So Python interpreter is going to say, nope, not going to care about this block. And I'm going to go, hey, else if a condition, hey, is this person licensed? Yep, they are. So I'm going to print you can drive now and ignore else. So it works like this. What if both of these were false? Well, as you can imagine, the Python interpreter is going to ignore, it's going to run this, say, nope, this is false, this, nope, this is false, and then finally it's going to run this. You see that else is a catch-all. That is, if none of these conditions are true, then we're just going to run this. So it's a backup in a sense. Hey, if all things fail, then just do this. Very, very cool. Now, if you look at this program, you're thinking, this program doesn't really work that well, does it? I mean, we're checking if the person is old and if person is licensed, but shouldn't we check both? We want somebody who has a license and who's old enough to drive. This is a buggy program. If we implement this in a Tesla, well, we're gonna get a lot of lawsuits, right? Because we can get somebody who's maybe licensed but isn't old enough, which I guess doesn't make sense, but we can get somebody who is old enough but never got their driver's license, and somehow we get access to the car and they can start the engine and drive, and that's a lawsuit waiting to happen. So how can we fix this? You know what? The power is that this is an expression, right? An expression, if you remember, is something that produces a value. And that means that this doesn't have to, just have true here. It could be an expression. So I could say, if is old and is licensed, then I can do that. And this is something new that we haven't seen before, the and. This is another keyword in Python. And in an upcoming video, we're going to talk about more of these keywords. But this should read like English, right? If is old and is licensed, then do this. So we can now remove the elif, and then here, both expressions need to evaluate to true. That is, whatever happens here, this has to evaluate to true and this has to evaluate to true. And only when both are true, again, as and states, then you're old enough to drive and you have a license. So that if I run this, well, I get an error, right? Or not an error, but it goes into the else block because both of these are false. If only one of them is true and I click run, you are not of age because both of these have to be true. If I click run, hey, all right, the car is starting. You can drive away with your Tesla. Okay, before I finish this video, because this is a lot, I want to just note one thing. That is the elif statement. The elif statement is really, really useful because when you have code like this, where you have an if statement and an else statement, usually you only see one of each. I mean, sure, in another part of the program, I could have another if statement and an if statement with another else statement inside of here. But usually, when you have this grouping together, you only see one if and one else, but you can have multiple elifs. So I can have elif another condition here, and then I can have another elif another condition here. And you can have as many as you want. Eventually, the program is going to either evaluate one of these conditions to true, or it's going to go into the else block. But usually you follow this order. All right, that was a lot. Let's take a break and explore this topic a little bit more. I'll see you in the next one. Bye-bye. I want to add a quick note about this spacing that we see in this code. Now, this isn't just for Python. In other languages, you'll always see this. You're not going to see that every single line of code always starts as, well, in the first space. Different languages will use this differently, but in order to organize code, usually you'll see some indentation like this. Now, Python, however, is unique because the indentation and spaces that we see here makes the interpreter see it and say, hey, this means something. The interpreter would actually see the space and say, because there's space here, I know that this is part of the if block. In other languages, like JavaScript, well, you have something similar, but usually you'll have an if statement and then some condition, followed by, make sure I spell condition right, followed by something like a curly brace. And in here, whatever is in here, you can see that I still get the space and I can do whatever I want. But JavaScript interpreter doesn't really care that there's spaces. If I want, I could write my code just on one line like this. And it's still valid JavaScript code. So people usually do this spacing more for style purposes. Python, on the other hand, is not just for styling that we do this, but because the interpreter actually finds meaning in the spaces, which is actually one of the big selling points with Python. It's very clean. There's no extra stuff here that makes it difficult. I mean, it's just English, right? If is old and if is licensed, then print this. It's just really nice to read and really clean. Now, if you notice here, my editor, and we're going to talk about editors and IDEs in an upcoming section, but if you are using the proper tools, this automatically is created for you. Now, in the programming world, there's this debate about tabs and spaces, and we're not going to get into it. It's frankly a little bit silly. That is, some people prefer to here, if they want to create a space, they might use spaces or they might use tabs. At the end of the day, with Python, the rule is you can use spaces, you can use the tab, but the idea that if you use spaces, you usually use 4 spaces. It's just a standard. Now, if you notice here, I actually don't have 4 spaces. It's 2 spaces here. And that is because up until now, well, I've just been following along whatever this editor gives me. But if you look over here, there's an auto format button. If I click on this, it automatically formats my code into the appropriate format. And you see right over here that I now have 4 spaces. But you see that the code still works. Again, it's because at the end of the day, the important part is that there's a distinction between hierarchies, that is the top and then maybe the children. But the interpreter itself is going to notice these spaces. So you do have to be careful because based on where this print is, as soon as I add a tab in here and I click run, well, I get is old and is licensed. But as soon as one of this is false and I click run, you see that OK runs only if this condition fails. Again, if previously both of these were true, I only get the first line printed. So that little space here changes the outcome of my program. So you have to really be careful with this. And luckily, your editor or where you code is going to help you out with this. But it is a gotcha that if you're just starting out, you want to be mindful of. All right, no more debates about spaces and tabs. I'll see you in the next video. Bye-bye. Welcome back. In this video, I want to talk about the idea of truthy and falsy. What do they mean? And you'll hear this a lot in Python programming. You see, up until now, you've used booleans here as values. So it was really easy. If true and true, then run this code. But Python can do other things as well. For example, if this was 5 and this was, let's say, hello, what do you think will happen here in our program? Well, if I click run, you are old enough to drive and you have a license. Is that what you expected? And this is because what Python does underneath the hood is actually convert these to booleans for you. So it's almost as if it is doing this. Remember type conversion. We're converting the type to boolean as soon as we get to this if statement because Python is saying, hey, I want true or false. I don't care what is old is. I don't care what is licensed is. Just give me true or false so I know whether to do this or to go to the else block. Now, if I was to just print, let's do this here. Let's do print boolean hello, and then finally print boolean 5. Let's see what we get. We get true. True. And this is what we call a truthy value in Python. That is, it's a truthy value because if we run the boolean type conversion on it, it evaluates into true. What's a falsy value? Well, if I do 0 and if I do, let's say, an empty string and I click run, those are falsy. That is, it's not actually false, but it is falsy because if we run boolean on it to Python, it's going to say, oh, this is false. And 0, that's false. And that kind of makes sense, right? And if you actually go to Stack Overflow, if you've never seen Stack Overflow before, if you ever have programming questions and you're Googling them, usually the top 5 answers will contain either 1 or 2 Stack Overflow answers. And basically what happens is people ask questions like, what is truthy and falsy in Python? And you get answers. So you can see over here that it has 4 answers, and you usually look for the check mark, which means that this is a verified answer. It means that, hey, this question owner has accepted it as the best answer. So the person who asked this question just said, yeah, this is the right answer. This is the best one. But you also have other people voting. So you can see that this answer received 46 marks, and although it was marked as the correct answer by the user, maybe somebody else came along later on and gave an even better answer. So now we have 123 upvotes. And you see that this answer is a lot better. All values are considered truthy except for the following. So you can actually see here that in Python, these values are considered falsy. You can see 0 here, you can see an empty string here, and then there's a few other ones. Empty set, you have an empty dictionary, empty list, empty tuple. You have decimals. You have things like fractions. You have 0.0. False is that. And also none is falsely. So that if I type in none here, that's false too. Now, you don't need to memorize these because most of the time it makes sense, right? But it helps us do conditional logic very nicely. For example, let's remove this. And let's say that we have a user. And this user has to have a password and a username. If, let's say, the username is Johnny and the password is 123, well, instead of me saying, hey, if this user has password and username, and we're not checking if the username exists or password exists, we just want to make sure, hey, did this person fill out the form and did they try to submit a username and password? I can just simply say password and username. And I don't have to worry about converting this to a Boolean or anything like that, because if password and username exist, then try to log them in. And you see that it reads a lot nicer, because each one of these get evaluated into a truthy and falsy value. It's a nice little feature to keep Python, well, nice and simple and reading like English. I'll see you in the next video. Bye-bye. I want to talk to you about another way to do conditional logic. We saw the if, elif, and then the else statement. But there's another way called the ternary operator. Now, this is still the same as the else if or if else statements, but it's a shortcut. So you can only use these on certain conditional logic. So it doesn't mean that, hey, this is just an entirely new way. This is a shortcut in a sense for you to make your code a little bit cleaner. Let's have a look. By the way, these ternary operators can also be called conditional expressions. And when you hear the word expression, that should mean something to you, right? It's an expression because it evaluates to a value. So a ternary operator or a conditional expression is an operation that evaluates to something based on the condition being true or not. And it's actually a new feature of Python as of version 2.4. So let's have a look. The way we use this is to say is condition, if this is true, then do this. So this is the condition if true. And bear with me here, it is a little bit confusing at first. We say if, and here we give condition, otherwise condition if else. All right, that is a little confusing. So let's go through it. So the if is going to check this condition. So it doesn't actually start with here. It's going to say, hey, if this condition. Now, this is going to evaluate to either true or false. If it's true, then we're going to do this. Otherwise, we're going to do this. So let me show you an example of how that would work. Let's say we're trying to determine if a user is your friend. So we'll say is friend. And here we can set true or false for friend. Maybe we can check on Facebook if users can message you. Or on Twitter, whether Twitter users can give you direct messages. Well, here, and let's do can message. And here we can do our ternary operator. We're going to say message aloud if, so this is if the condition is true. The condition is, hey, is this person your friend? Otherwise, condition that is false, well, I'm going to say not allowed to message. And you can see here that this is a one-liner. It looks like 2 lines, but you can see over here that it's not really. It's just that we're wrapping so we can see the entire code. So let's run this and see what can message prints. If I run this, message is allowed because, well, we've assigned message allowed to canMessage because, well, the condition was true. If this person wasn't my friend and I run this, not allowed to message, because the condition, the if condition, evaluates to false. I know the ordering here can be a little bit confusing, so you might have to look at it a couple of times, and you do need to use it a few times to really remember it, but this is the general rule. Condition if true, if condition, else condition if. Not if else, if false. Can't spell. All right, a nice shorthand way to do something when a condition is either true or false, or evaluates to true or false. All right, I'll see you in the next video. Bye-bye. It's time to talk about another topic that sounds a lot more confusing, short-circuiting, than it actually is. It's quite simple. Short-circuiting looks something like this. Remember when I taught you the word and? So we can use, let's say, for example, is friend equals to true, and let's say is user is equal to true. And I can do an expression here saying is friend and is user. Now, in here, when we run this, let's print it here just so we can see. If I run this, I get true, because both of these evaluate to true. So that if I had this as an if block, let's say if it was if is friend and is user, print best friends forever. Now, short-circuiting can be done when we use something like or, which we haven't seen before. But again, you can see here that it's highlighted in blue, so it is a keyword, a Python keyword. Now, or says if either one of these conditions are true, then run this piece of code. So if I run this, I get best friends forever. Now let me ask you this. Which operation do you think is more performant? The or the and? Is there a difference? As a matter of fact, there is because of short-circuiting. You see, when I do or here, because I only care if either one of these is true, the Python interpreter is going to say if is friend, and it's going to evaluate that and say, oh, this is true. And then it's going to see the word or, and it's going to say, hey, I don't care what this is. Maybe this is a really heavy operation or something that I need to look up. Well, I don't really care because this is already true. Whether this is true or this is false, I don't really care because either way, I'm going to have to print this. As you can see, it still prints best friends forever. So short-circuiting happens when the interpreter is smart enough to say, I already did enough work. I don't care what this is. This is just wasted work if I do it. So I'm going to short circuit and say, hey, I'm going to just ignore this and I'm going to start printing. So using or is a little bit more efficient. But again, it depends on what you need. If you need to check if both is friend and is user is true, you'll have to use and. But this works both ways with and as well. For example, if is friend is false, this is going to get short-circuited because I'm going to say, hey, if is friend is false, well, I don't really care what is user is because there's no way that both of these are true. I've already seen that one of them is false. So I'm going to ignore this and I'm going to print this. And when I say I mean our good old friend Python interpreter. Now, this topic of short-circuiting doesn't really get taught in beginner Python courses, but now if you hear this, maybe you hear this in an interview, as you can see, it sounds a lot more difficult than it actually is. And frankly, it makes a lot of sense, right? We want our machines to be efficient, and it is quite efficient due to short-circuiting. I'll see you in the next one. Bye-bye. Welcome back, and let's talk another term. Logical operators. And they're very, very useful when it comes to conditional logic. Let's have a look. Logical operators are, well, as a matter of fact, you've actually seen them before. AND is a logical operator. OR is a logical operator. It allows us to perform logic between two things. What else is a logical operator? Well, let me list it out for you. We have greater than, less than, equal to. Let's actually use them in an example. Is 4 greater than 5? Well, if I print this, what do you think will happen? Shouldn't be a surprise. That's false. 4 is not greater than 5. This is a logical operator that you may have seen in math class. If I do the opposite, is 4 less than 5? That makes sense. That's true. What about is 4 equal to 5? If I run this, I get false. Now, why did I use two equals here? Why not just do this? Well, if I run here, I get an error. Syntax error. Keyword can't be an expression. It's because, remember, equal is what we use to assign to a variable, right? And if you remember, I told you that a variable in Python can't start with a number. It has to be a letter or underscore. So when I do this, it's going to error because the interpreter is going to say, hey, I'm trying to assign variable 4 the value of 5. And, well, that's not really allowed. So we use double equals to tell the interpreter, hey, I'm not assigning a variable here. I want to compare things. And we can compare different things. I can do hello equals to hello equal to true. What if I do A is greater than B? I get false. Now, why is that? This I want you to Google on your own and figure out why is A greater than B. What if I do A, is that greater than capital A? That's true. This is interesting. And this is actually quite an interesting reason. So I know it's easy for me to just give you an answer, but I want you to practice Googling this. And the reason I'm not giving you an answer is it's also because it's not very important. Because most of the time, you want to make code that is easy to understand and understandable. You're most likely using greater than and less than with numbers. So if you see something like this in code, well, you wouldn't know what's going on. What is this person trying to compare? Why are they doing is lowercase a greater than capital A? It's not something that you see very often. But the reason you get this expression is quite interesting. So I do recommend you Google into it. Like I said, I'm a strong believer in not holding your hand the entire way. I know so far the videos up until now have been quite easy, especially if you are an experienced programmer. But as we progress, you'll see that after this course, you need to figure things out on your own. And my job is not to just handhold you the entire way. It's to develop the skills in you to become an employable programmer. So I hope you bear with me as I just give you this little challenge. All right. We went a bit on a tangent, so let's bring it back. Can I do things like this? Is 1 greater than 2? Or you know what? Let's do less than 2 and less than 3 and less than 4. Will this work? Well, of course it will. It's just an expression, right, that we're evaluating. And all of this is true, but as soon as I change and something is false, it's going to short circuit, which we learned about previously, and return false. All right, so we know the greater than, equal to, less than sign. We also have greater than or equal to. So that if I do 0 here and I click run, I get true because it's saying, hey, is this greater than or equal to 0? I can also do less than or equal to 0. And here I get false because 0 or 1 is not greater or equal to 0. But if I do 0 here, I'll get true. Here's another one. what if I do this? Exclamation mark equal. This means in Python not equal to. If I run this, I get false. And this is a little tricky. What it's saying is, hey, is this not equal to this? So it's the opposite of doing equals. If these two things don't equal, it's going to say true. So if I do 1 here, I'll get true because these two things do not equal. So we've learned greater to or less than, greater to, equals, equals or greater or equal to. We've learned about less than or equal to. We've learned about not equal to, but we've also learned about and or. And finally, there's one more I want to teach you, and it's the not keyword. I know, it's a little much, but it's not as hard as you think. Not is, well, the opposite. So if I do here, not true, what do I get? I get false. And you see that not is also a function. So it's a keyword, but also a function that we can use. If I do not false, again, I just get the opposite. What if I do this? What if I do not 1 equals to 1? What will I get here? I get false because this expression evaluates to true, and then not just does the opposite. So let's take a break here and work on a little bit of an exercise to make sure that we understand this. Welcome back. Let's do a fun little exercise. We just got hired by a gaming company, and we're creating this wizard game. And this wizard game has the is magician in the user's profile, and for now we'll just set it to false. We also have is expert. And whether this user is an expert at this game, we'll leave it at true for now. And then, let's do this here. I want you to check if both, or check if magician and expert. And if that's the case, if true, then I want you to print you are a master magician. And also, I want you to check if magician, but not expert. If that's the case, I want to just print at least you're getting there. And then finally, let's do a check that says if you're not a magician, I want you to say, well, you need magic powers. Now, I want you to use what you've learned about logical operators to create this conditional logic. You can pause the video if you want and try it yourself in a REPL. Otherwise, I'm going to keep going with an answer. But you should be able to solve this fairly easily if you've been following the videos and exercises so far. So let's start with the first one, where we say you are a master magician. So I'm going to say if is expert and is magician, I'm going to print you are a master magician. So I'm going to copy that and say print you are a master magician. Nothing too crazy here. And then next one, I'm going to say if, or I could even say elif if I want. And again, this is something that you can decide what you prefer. I usually like using elif if it's part of the same concept as the first one. In this case, yeah, we're still trying to figure out what type of user it is. So we'll use elif and we'll say elif. We want to check if it's a magician. So that is magician. So we're going to check if that's true. But we also want to check if, well, not an expert. Now, how do we do this? I mean, we could say use short circuiting and say is expert. And even if this is false, we can get true here because is magician, short circuit, and print this part. At least you're getting there. Because the interesting here is that this code block is never going to run if both of these are true, because in the first if block, we're checking that. So that as soon as this is true, we're going to completely ignore the elif. So we could do that, but this is a little bit hard to read because I really have to think about it. If I come back to the code or somebody else looks at my code, it's not clear that unless I comment that I'm checking if it's magician but not expert. Because this will never run if is magician is false, then that's what they're checking for. I know it's kind of confusing even saying it. So I prefer using something like this, using and not. And that reads a lot better, right? It makes a lot more sense. Hey, if this person is an expert and magician, do this. Otherwise, if this person is magician and not an expert, then print this. That reads pretty nicely. And yes, you can do this because remember, not is simply checking and inverting whatever the Boolean expression is. So this still evaluates to a Boolean that and can check. All right, let's finish the final one. If you're not a magician, you need magic powers. So how do we check here? Well, we can do another elif and say not is magician. And if I run it like this and say print, and we'll just copy here, you need magic powers. And let's remove the comments for now, just so we can see the blocks of code. And we're going to test our program. Hopefully we coded it properly. Hopefully there's no bugs, but let's have a look. If I run this, you need magic powers. Why is that? Well, if magician is false, none of these are going to work. What if I change this to true and I click run? All right, I am a master magician because I'm an expert as well as a magician. What if I turn this to false and I click run? Hey, at least you're getting there. I'm a magician, but I'm not an expert yet. I still need to improve my gameplay. Now, you may have gotten a different answer than me. And there's many ways to do this, right? You could have used an else statement. You could have used or. Conditional logic is all about writing code that makes sense, not only to you, but for other people reading your code. The idea is not to be extremely clever or really worry about short circuiting. Yes, it can be more performant, but a machine is so powerful that just tiny bit of optimization there is usually not worth it when you're losing perhaps readability. So you want to make sure that your code reads like English. And this is a topic that, frankly, a lot of beginner programmers have a hard time understanding, where they try to be as clever as possible, write as little code as possible in the shortest possible lines, when instead you want to focus on readability. Because a code that is easy to understand is a sign of a good developer. And I hope looking at this, you're thinking, yeah, this is pretty easy. I mean, this all makes sense. But this is not the only way. Maybe my version of what reads well is different than yours. The idea is to each of us try our best to make our code simple and nice. And in programming, there is no one right answer. There are many ways to solve a problem, but the key is to solve it in a simple manner that is readable. I hope you had fun, and I'll see you in the next one. All right, in this video, I'm going to try and trick you. I want you to look at these expressions where I'm checking for equality, right? I'm saying, hey, does true equal 1? Does empty string equal 1? Do two arrays that are empty equal, well, each other? Now, pause the video here and try to guess what the outcomes of this are going to be. Ready? By the way, if you get 100% on this, well, good for you, because if this was my first time learning Python, I wouldn't get this. Let's go. Is that what you expected? True evaluated, so true equals 1, evaluated to true. An empty string equals to 1, evaluated to false. That makes sense because they definitely don't equal each other, right? An empty array doesn't equal to 1. And a 10 equals 10.0. And then both arrays that are empty equal to true. Now, the reason I'm showing you here is that the double equals checks for equality, or equality of value. That is, if, for example, the first one, true equals to 1, there's two different types. One's an integer, one's a Boolean. It will convert them into the same type. In this case, this will be converted like this to a Boolean value. And if you remember, 1 is truthy. So this will evaluate to true, which is why we get true. What about the other one? Well, an empty string is falsely, so it evaluates to false, and false doesn't equal true, right? Because we're checking for equality here. So one of these gets converted to the other's type. What about an empty array? Again, an empty array is actually falsy. So that's not going to equal 1. A 10 equals to a float of 10.0. That gets converted to an integer or a float, and they're going to equal each other. And that's an expected behavior. And then an empty array, well, equals an empty array. If I add in this array 1, 2, 3, 1, 2, 3, and I click run, I get an invalid syntax. Oh, because I have this here. Let's run that again. I get true. That makes sense. Let's change this to 1 and see what happens. If I click run, all right, still false. Now, this does get a little tricky, right? Like, should this have evaluated to true? But no, we get false. So this doesn't get converted in type versus what we had here. Now, don't get confused by this, because this would be bad code. If you're checking something like this, well, obviously you should be checking two types, two of the same types together. Ideally, when you use comparison operators or logical operators like this, you're comparing two types and you're not letting Python do this type conversion, and hopefully Python figures it out for us. But I hope the double equality makes sense, because there's another check that we can do, which is. And is, well, is a keyword in Python. What happens if we change all these equal signs to is? Do you think there would be a difference? Let's have a look. If I click run, I get false for everything. So what's the difference here? Equals checks for the equality in value, such as 1, 2, 3. Well, that has the same value as 1, 2, 3 in a list. Is actually checks if the location in memory where this value is stored is the same. Let's go through that. So true, is that 1? No, true is not 1. True is, well, only true, right? That will be true. What about string 1? Is that 1? No, I mean, for 1 to be a string, that needs to be 1, right? Because the 1 string isn't only in one place in memory. It's literally the exact same thing. What about this list? As a matter of fact, let's do is array, empty array. Is that, or is this list a list? Well, if we run this, I still get false. And this is a little tricky and also advanced. Every time I create a list, it's added in memory somewhere. So this is in a location in memory. But whenever I create a new list, it's created in another location. So these are two completely different lists that live in different locations in memory. So it's going to check, hey, is this in the same memory space, same bookshelf as that one? Nope, that's not it. But why does this work for things like numbers and strings? And that's because underneath the hood, these are types that are very simple that are in memory but in one location. Versus something like a list, even though this might be the same list with the same items, because this is a data structure, every time we create it, it's created in a new location. So that even if we have a variable A that contains this list, and by the way, this will be the same for all our data structures like dictionaries, sets, tuples. If I do B equals this, and I check A, is that B? Nope, they're created in a different memory space. So this, where A points, is in a different place than where B points. But if I do A equals to B, I get true because this double equality checks only the values. Now, this is a bit of a hard topic. So you might have to watch this video a couple of times. You might have to practice this a few times yourself. But just keep in mind the difference between is and double equals. Is tends to be a little stricter. You're checking for the exact thing that you're looking for versus equality, which checks the value. All right, that was a doozy. I'll see you in the next video. Bye-bye. Let's talk about loops. We've talked about conditional operators, logical operators, but loops gives us a whole new power when it comes to our machines. The concept of loops or looping in programming is really, really powerful. We saw that with logical operators and conditional logic, we're able to skip lines in our program so that we don't always go 1, 2, 3, 4, 5, 6, so on and so forth. But loops do a really interesting thing. It allows us to run lines of code over and over and over. And that's really powerful because that means we can run things thousands of times, millions of times. And this is where machines excel. Machines excel at doing small tasks over and over really, really fast. Way better than humans. So loops are one of the most powerful features of programming languages. So how do we create one? Well, it's as simple as using what we call for. Or in Python, we call them for loops. With this keyword, for, we're able to say for, let's say item in 0 to mastery, do something. So they're kind of like conditional operators. Instead of if, we have for, but then we have this thing, right? Where we have item, which, what is that? We don't really know. Well, this is a variable that we create. We can name it whatever we want. We can say I. We can say teddy bears. Whatever we want. This is a variable. And a variable is created here for each item after the in. So it's saying, hey, for every item in 0 to mastery, do something. And we've seen this in keyword before. And we'll dig deep into this later, but we call this an iterable. An iterable is something that is able to get looped over. So an iterable allows us to use this notation of a for something in an iterable to iterate over each item. In our case, if I print item here and I click run, look at that. It prints each item in the iterable, which is the string 0 to mastery. So every letter, it goes into every bookshelf in our machine's memory and prints each item one at a time. Now this works with strings, but we can also use lists like 1, 2, 3, 4, 5 that we've seen before. If I click run, again, this is an iterable. We're able to iterate over it and it grabs each item in the list. Let's do a set. Can we do this with a set? Well, if I click run, that works as well. What about a tuple? Let's do it with a tuple. If I click run, that works as well. That's amazing. What about a dictionary? Well, we'll get to dictionaries in a bit. So for loops allow us to iterate over anything that has a collection of items. So that in this case, we're looping 1, 2, 3, 4, 5 times. And you can see over here that we have the colon and then the indentation to tell Python, hey, whatever comes here, I can print item again, I can print item again. I can do it as many times as possible. As long as I have indentation, it's going to keep printing our numbers. But as soon as I open up here and print something else, well, I only get that once because it's not in the loop. So our program first runs this for 1, so it's going to print 1 3 times, then 2, then 3, then 4, then 5, and then only finally then it goes to print. You see how we're looping over and over and over. Now, what happens if I try and print item here? And I click run? Did you see that? Item gets printed at the very end here. I don't know if you can notice it, but you see that there's 4 5s. We've printed 1, 2, 3, 4, each 3 times, but 5 gets printed 4 times because this last print at the very end is, well, 5. Because by the time the loop ends, the value of item is actually 5. Let me ask you this. Can I do something like for, let's say, X in another list that contains strings A, B, and C? Could I do something like this? Absolutely. I can nest things in Python. And as a matter of fact, when we do conditionals in Python, like if statements, we can always nest those as well. Because in Python, it's always the indentation, right? So I can say print here item, and then also print, and you know what? Let's print them one next to the other. So I'm going to say print item and print X. If I click run, you see that we're printing 1 and A, 1 and B, 1 and C. Because item, we run line 1, so item is currently 1. So we're going to go to the next line, line 2, and we're going to say, we're going to loop over this iterable, and we're going to say this is X. So this is going to be 1, this is going to be A. And then Python comes back to line 2 because we're still in this loop. And we're going to say, hey, what's X now? Well, we're done with A, so let's go to B. So it's going to run B. And then C. And only once this is done does it go back out and now starts with 2, which is right here. 2A, 2B, 2C. So you can have nested loops over and over and over as well. All right, so these are loops. And right now, maybe it's not completely obvious why these may be useful. But before we get into that, I want to talk about this idea of iterable in the next video. Welcome back. I kept mentioning this key term, iterable. But what does it really mean? Iterable, you're going to hear that over and over in Python programming and other programming languages as well. And as we discussed a little bit in the previous video, iterable simply means it is an object or a collection that can be iterated over. So again, an iterable can be a list, can be a dictionary, can be a tuple, can be a set. It's a collection of items. We also saw that a string could be iterable. Now, these things are iterable. Why? Because they can be iterated. That is, iterated means we can go one by one to check each item in the collection. And you're going to hear this over and over when talking to Python programmers. So you want to make sure that you have that vocabulary. You're iterating over something. You're looping over something. So iterable is the noun, and iterated or iterate is the action of iterating over an iterable. I know, it's a little confusing. Now, many objects in Python, like I said, are iterable. But there's a few special ones that we haven't covered yet. Specifically, dictionary. We saw how lists, tuples, sets, and strings can be iterated. But what about an object? Let's say we have an object here, and this object will be users. And users, or user, will have a name of Gollum. We'll have age of 5006. Gollum's pretty old. And then we'll say can swim. Gollum, let's say, cannot swim. False. What if we use this object right here for item in user, and we print right here the item? What do you think will happen? Let's run this. Well, I get an error because I forgot a semicolon here, and we don't want equals, we want semicolon. And then obviously this needs to be a string as well. Now, if I click run here, look at that. I get name, age, and can swim. So I've printed the keys of the dictionary. Now, this dictionary, we have the keys. That's great, but what if I wanted actually the values? Is there a way to do this? Well, dictionaries have 3 methods that are really, really useful when we want to loop over their keys and values. The first one is items. And with items, when I do this and I click run, you'll see that I get the key value pair in a tuple. And this is a very common pattern that you'll see a lot. Another one that we have is values. And guess what that does? That gives us the values of the dictionary. And we saw that user, just leaving it blank, gives us the keys. But we have a method that is more descriptive and allows us to show exactly what we want to do, which is keys. And if we run this, you'll see that I'm able to iterate over the keys. And these 3 methods are very common, and you're going to use them a lot in your programming career. So make sure you take note of them. Items, values, and keys. It allows us to iterate over dictionaries. But another interesting thing that you can do, and another common pattern when iterating over dictionaries, is what if you want to print, for example, separately the items, name, and Gollum. So right now we're returning a tuple. And we saw that we can do tuple unpacking, right? I can say key value equals item, and then just print key value. If I run this, you see that I'm able to print these. But there's actually a shorthand way of being able to do this. In here, in the for loop, I can say key value and just completely avoid this entire line. And if I run this, there you go. It still works. And this, again, is a very common pattern, where if you're collecting the items of a dictionary, you can separate them into key and value, or you might even see shorthand K and V. Again, these can be any variables that you want. You can name them whatever helps your code be more readable. By the way, just for fun, let's say in the last line here, I want to iterate over the number 50. What do you think will happen then if I click run? Sorry, name error. Name key. Oh, I get an error here because I haven't changed these, so let's change these back. That's not the error I was expecting. The error I was expecting was this. Type error. Int object is not iterable. Now this error should make sense now because I've said it over and over. Why is it not iterable? Well, because it's not an object that can be iterated over. It's not a collection of items. Because we learned that in Python, these are iterable. I'll see you in the next video. Bye-bye. Welcome back. Let's try a simple exercise. I want you to build a simple counter. And this counter is going to count the items in our list. What does that mean? Well, let's say I have a list, and this is a reserved word. Remember, it's an actual word in Python. So let's name it my list as a variable. And this list has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What I want you to do is using looping to loop over this iterable list and sum up the total of the list. Pause the video if you need to. Otherwise, let's see how we can do that. What I'll do is create a counter variable that will equal to 0 to start off with. And then I'll say for item in my list, I'm going to counter equals counter plus item. And then at the end, I'm going to print counter. Let's see if this works. I'm going to hit run, and I get 55, which, if my quick math is right, should be correct. Now, when doing this exercise, you may have gotten tripped up a bit. So let's think about this. Some of you may have made an error where you did the print here. But if you did the print here, you remember that it's going to get looped over. It's part of this code block because of the indentation, and it's going to print as many times as there are items. So you have to make sure that the indentation is like this so that you get the total. The other thing that you noticed is that in order for you to keep a counter or a total of all these items, you had to make sure that you had a variable outside of the loop, because the loop runs the code over and over. And you needed something on the outside that doesn't change. Because if you moved the counter to 0 here, well, every time the counter would be reset to 0. So that by the time we get to 10, counter would be 0. So you get 0 plus 10, which equals 10. And then you'd get, well, 10. So you have to be careful here that the indentation is an indication of us looping. And when you loop something and you want to keep a tally or total of something, that you have these issues of making sure that what you want to loop over is inside of this code block. But what you don't want to, if you want to have some sort of information that's outside of this loop, that you keep it like this. If you weren't tricked by this question, good job. If you were, don't worry, it's all part of learning. I'll see you in the next one. Bye-bye. When looping in Python, one of the most common tools is this range function that we get out of the box with Python. And you see here that range, well, is a range object, a special type of object in Python that returns an object that produces a sequence of integers from start to stop. Let's explore that a little bit more. if I print here a range and I say range 100 and I click run, I get range of 0 to 100. So it looks like a tuple, but it's not. It's a range object. It's a special type of object. And range, you can give it like this, which gives you a default of 0 to whatever you give it, which is 100. Or you can just simply type 0, 100. And if I click run, it's the same thing. But where range becomes really useful, and you'll see this in 99% of cases in Python, is in for loops. You see, besides tuples and lists and sets and dictionaries and strings, you can iterate over a range. So for example, if I do for I in range, and let's just say item, or in our case, let's just do number in range, and in here I do print number. If I run this, you'll see that I'll get numbers 1 to 100. And why is this useful? Well, using range, I was able to loop 100 times. As you can see, all the way till 99 because our count starts at 0. And we're able to loop as many times as I want. So I can tell the loop, maybe we want to loop a certain number of times. Maybe you want to loop 10 times, where I can tell the loop how many times to run. It's extremely useful. Maybe here we're performing some action where it says, I don't know, email list. So we want to send 10 emails to an email list, for example. Well, again, I can just click run and I sent that email, well, a bunch of times, 10 times. Another neat trick is that, well, you might not even need number, right? We're not really using it in our code. And often what you'll find in Python programs is if a programmer doesn't need this variable, you just do an underscore. And this is just a variable. I mean, you could use it like this, and you'll still get these numbers, but it just indicates to other people that, hey, I don't really care what this variable is. I'm just trying to use range so that we can loop over things, let's say 10 times. Now, range also comes with a third parameter. And what that is the step over. So if I do 2, and by the way, default is 1 here. If I do 2, it jumps from 0 to 10 by 2, which is very, very handy. So what is range? Well, range creates a special kind of object that we can iterate over. Okay, what if I do minus, right here. What if I do -1? Well, if I run this, that's not going to work because, well, let me show you why. If I change this to 0 and 10, and I do -1, it's going to go in the opposite direction. But if I did just 10 and 0, that's not going to work. If we want to do something in reverse, we just have to make sure that we add that -1. Or if we want to step back twice, then we click run. So you have a lot of options to play with the range. You can do ascending, descending. One final thing. Another place that you might see ranges, and like I said, most of the time they're in for loops, but you can also do something interesting like, let's say, a range of 10. And then if we wrap this in a list, remember a list function allows us to convert something to a list. If I run this, did you see that? Let's simplify this so that this range is going to just be 2. If I click run, you see that I loop 2 times. And in here, I'm going to print, first of all, I'm going to create a range, an iterable object that has 10 items. And then I'm going to convert that into a list. So you can see here, 0 to 9 into a list. So this is a quick way to create a list that, well, has integers. A neat trick that you'll definitely use along your programmer journey. I'll see you in the next one. Bye-bye. Let me show you another useful function that we'll use just like range. Mind you, it's not as common as range. Range, you'll see it a lot in Python code, but this other one is still very useful, and it's called enumerate. Now, what does it do? Let's have a look. I can do a for loop, and I'll say for, and we'll say character in enumerate, and then enumerate, we wrap around something that, well, we want to enumerate. So let's see what that means. It returns an enumerate object. So iterable must be another object that supports iteration. So we have to give it something that enumerate can iterate over. So this time around, let's just do a string that says hello. Now, enumerate is special because what it's going to give us is it's going to take an iterable object and gives you an index counter and the item at that index. What do I mean by that? Well, you can actually say I, comma, character. So we're unpacking this and we're saying, hey, print I and character. If I click run, look at that. I get hello iterated over. Again, if we don't have enumerate, then we would have just gotten hello. But we also, because we use enumerate, we get this I, or index, of each item and where it is in the index. So that if I had a list here, let's say 1, 2, 3, again, I'm able to use and access the index number of the item as well. What if we had a tuple? Again, we get the index number. So enumerate is very useful if you need the index counter of the item that you're looping through. So let's do a little exercise. Let's say that we want to create a script that enumerates a list of numbers 1 through 10. So we'll use range to create that. I'm going to say list, and then I'm going to say range. I know there's a lot of functions here. Range, that is 100 actually. Let's do that. And I want to be told what the index of the number 50 is. So pause the video if you need to do that. Now, here, I want it so that, let me make this a little bit bigger. I want it so that we only print the index of, let's say, the value 50. I want to know where 50 is in the list. Now, again, this is a simple example, so you can probably already guess what the answer is. But how would you code this so that only in here we get the index of 50? Or it says the index of 50 is whatever. Pause the video if you want to give it a go. Otherwise, let's try this. I'm going to do a conditional and says if character is equal to 50, then I'm going to print index, or I'm going to do an F string, and I'll say that the index of 50 is, and then I'll add the index in here. So that if I run, I get index of 50 is 50. And just to confirm, if, for example, I just print here, and let's say print I in character, I click run, we see that, yep, we have the indexes the same as the numbers. Again, not too difficult of a question, but you see here that we're able to extract this information. Again, not as useful as range, but you will see it occasionally in code. So I wanted to make sure that you're not surprised by it. As you can see, it's not that difficult. Welcome back. Up until now, we've learned that with looping, we can use for. But there's actually another way for us to loop. And it's called, instead of a for loop, a while loop. And while loop is a little different in that we say while a condition is happening, do something. So you can see that there's a bit of a difference here. For example, I can say that while 0 is less than 50, do something. Or I can say, for example, I equals to 0, and I'm going to say while I is less than 50, print I. Now, if I ran this program, what do you think will happen? Let's find out. If I click run. All right, do you see that? I don't know if you can tell, but I'm scrolling right now through all of this. It's looping, 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 looping. And you see that the programming's still running. As a matter of fact, I have to stop it because what it was doing is it was looping and looping and looping, because if we look at the code, well, 0 is always going to be less than 50. So what happened was, while this was true, we printed I. And then the Python interpreter went back to line 2 and says, hey, is 0 still less than 50? Yep, okay, next line, print. Hey, is 0 still less than 50? Yep, okay, next line, print. And it kept going, kept going, kept going. Now, this is what we call an infinite loop. That is, the program doesn't know when to stop. I mean, we're telling it to just keep going forever, for eternity. And I have some safeguards in place here, but if you did this in code, you'd get this infinite loop until your program crashes. If you actually ran this code, well, it's going to keep running until the machine just doesn't have enough power anymore, enough resources to keep doing this over and over. Everything has limits, right? So with a while loop, we have to be really careful. This infinite loop can be very dangerous. So how can we solve this? We have this idea of a break statement. And break is, well, just another keyword in Python. And as you may have guessed, if I click run, look at that. It only runs once. As soon as Python sees break, it's going to say, all right, break out of the while loop. So it's going to go to line 5, and it's going to say, got nothing there, program's done. I'm going to exit out of the program. But okay, what if I want this to be looped 50 times? How can we solve that issue? Think about it. Well, we can just simply say I equals I plus 1. And then make sure that we change this to I. Now what's going to happen? If I click run, we stop, well, at 49. We've done it 50 times. We've looped through it 50 times because we kept incrementing I over and over. So that I, each time we came back to the loop, was incremented by 1. Now a shorthand for this, we've seen it before, is to do plus equals 1. So that if I run, look at that, same thing. So we're also able to break out of the while loop as long as we're able to turn a condition into false. So you'll see this a lot as well. So to jump out of a while loop, you can either turn the condition false, or you can break out of the while loop. Now, another interesting thing that we can do with a while loop is we can have else blocks. And here we can say print done with all the work. And if I click run here, at the very end, look at that, done with all the work. And this should read like English, right? While I is less than 50, keep looping through here. And as soon as we get to the last part where I becomes 50, where 50 is no longer less than 50, Python interpreter is going to say, all right, I don't care about anything under there. Let's go to the next line. And I get otherwise. So in this case, we don't have anything else happening. We can print done with all the work. But you're probably asking yourself, hold on. Can't I just not do this and just make sure my indentation is at the end? Click run and that works, right? Why would I ever want to write else here? Well, else is a special case here. There is one thing that is useful. That is, if we added for example, a break statement here, and I click run, you'll see that the else statement does not print. And that is because the else block will only execute if there isn't a break. That is, if the while condition turns to false, then it's going to keep going and do the else. But if there is a break, it's going to break out of this whole thing and go to the 8th line. So a little gotcha here that you won't see else too often next to while, but there is that special case where else is used when you want to make sure that this will be executed only if there isn't a break statement. Only if the loop is finished doing whatever it's doing without the break statement. Let's take a break and explore while loops a little bit more. So when should you use a while loop and when should you use a for loop? And it really depends on the problem you're trying to solve. For example, in a for loop, I could do for item in, let's say, a list, 1, 2, 3. And just looking at this code, you know right away that it's going to be looped over 3 times, right? And I could say here, print item. But you can do this in a while loop as well. I can say I equals to 0, and then while I is less than, let's say, the length of the list, that is 1, 2, 3. Well, in that case, I want you to print I, or the item, and then increment I by 1. If I run this, I see that, well, technically here we're incrementing the I, which is the value, but let's say we had a list up here. So my list, and this list will be 1, 2, 3. Well, my list can be iterated with a for loop, or it can be iterated with a while loop, and we simply say my list at index of I. And if I run this, I get the same results. But which one do you think is better? First off, while loops are very flexible. We can do a lot because we have this conditional statement. We can loop more than 3 times if we really wanted to. So in that case, while loops are more powerful. But for loops are simpler, right? Like this code reads really nicely and really well. It makes sense. We just want to loop over something that we already know how many times we want to loop over, 3 times. With a while loop, we have to create this variable, and we have to make sure we remember to increment the variable so we don't get an infinite loop. So with a while loop, you need to make sure we remember to halt the loop at some point. So my rule is usually this. For simple loops or iterating over iterable objects, for loops are great. But let's say you're not sure how many times you want to loop over something. You're not really sure how long it's going to take for looping. So you want to say, while something is true, just keep looping. For example, let's say we're trying to go through an email list that we've collected on a website. And for each email list, we want to send an email. Well, while the list is still there, let's just keep sending emails. There are many, many cases, but one of the most useful ways to use the while loop is like this. Is to say, while true, do something. And make sure that at the end, we break. Hold on, what's happening here? I'm saying while true, wouldn't that create an infinite loop? I mean, true is always going to be true. And you'd be right if you notice that. But again, we have a break statement here. So at the end, after we run line 3, it's going to break. But now we can do something powerful like input here. And if you remember, an input is going to ask us for a prompt to enter something. So I can say, hey, input, say something. And if I click run, it's going to say, hey, say something. You know what? Let's add a semicolon here or a colon here. And let's try that again. And look at that. It's saying, say something. I'm on line 3 right now. So I'm going to say, hi. And did you see that? We just broke out of the loop. It only asked me once. Even though this was true, as soon as we got to line 4, I was done. But what if I remove this and I click run? If I say something, I say hi, and then it asks me again, hi, hi. I'm telling hi, and it keeps asking me, and we have an infinite loop. But the interesting thing here is that we can use conditional logic, right? What if we said response here and collect whatever the response is and say if response is equal to, let's say, bye, then I'm going to break. So that if I run this again, I say hi, keeps asking me, and you know what? I'm getting annoyed with you, machine. I'm going to say bye. It's going to exit it out for me. How cool is that? So while loops are extremely useful for tasks like this, where looping can happen for a long time. You don't know how many times it's going to happen. But this is something that you're just going to have to get used to with practice. Eventually, and I promise you this happens where you'll figure out when to use while, when to use for loop. But at the end of the day, use whatever solves your problem. I'll see you in the next one. Bye-bye. Welcome back. Now, up until now, we saw the break keyword that we can use to break out of a loop. And you see here that we're able to loop with a for loop, but with a while loop, as soon as we break, we're done. We've just, well, broken out of the loop. But could we do that in a for loop? Let's find out. Yep, break keyword works in a for loop as well. But there's actually 2 other things that we can use besides break. One is called continue. And you can see here, again, blue highlighting. If I do continue here and I click run, there you go. We get our looping again. But you're thinking, why do we need this? Like, it seems completely useless, right? Well, a break, when we use the break statement, it breaks out of the current and closing loop. So when we used a break statement, we broke out of this loop, right? This whole while loop, we just exited it. And same with the for loop, we completely exited it. However, with a continue, what we're saying is, hey, whatever happens when you hit this line, continue on to the top of the enclosing loop. So the current enclosing loop, what is it? It's this for loop. So it's going to go back to the for loop. So that if I do something like print here, so that we get it printed twice, or you know what? Let's just move print down here, like that. And then same here, we're going to just print at the bottom after continue. If I click run, nothing gets printed because as soon as it sees continue, it's going to say, okay, I'm going to go back to the loop. And it's going to keep going until, well, the loop ends so that we never actually hit line 10 and line 4. So that becomes really useful in conditional logic as well. Finally, the third one is called pass. And pass is, well, not very useful. It essentially does nothing. If I click run here, and again, it shows me here, line 10, something's wrong. Well, we have to move print up to the top so that, well, we don't get my list of index of 3, which doesn't exist. So again, going back here, if I click run, pass doesn't do absolutely anything. It just essentially passes to the next line. So why is that ever useful? It's very rare that you'll see pass in your code, but pass is a good way to have, let's say, a placeholder while you're coding. For example, you want to loop through the for loop, but we don't know what we want to do yet in the code. Let's say that here we're still thinking about it. If I do this and I click run, I get an error here because, whoa. Expected an indented block, because now the for loop or the Python interpreter is looking for the next, like, what am I supposed to do with the loop? I'm trying to loop and there's no code for me. So you can add a pass here to at least fill something for the for loop to say, hey, I'm thinking about it. I'm just going to pass it for now just so you have something so you don't bug me, and I'll come back to it. So if I click run, that still works. So pass is one of those placeholders that we can use so that there is a line of code that does absolutely nothing that we can still pass through. Again, a very rare thing to see in production code, but while you're developing, some developers like using pass. And there you have it. Break, continue, and pass. I'll see you in the next one. Bye-bye. All right. Your head must be spinning because of all these looping. That's a really bad joke, but I thought it was funny because I've been recording for hours now and I think I'm going a little kooky. So this is going to be my last video for the day, not for the course, but we're going to do a little fun exercise. Now I call all exercises fun. Obviously I'm biased, but this one's especially fun. What are we going to do? Well, we're going to simulate what a computer does when we have something like a graphical user interface. That is, a computer is able to display, let's say, even an image over here, right? I can see the robot over here. I can see the mouse. This is a graphical user interface. I see pictures, I see images on my screen, these pixels on my screen, and I can control them. Well, we're going to create a basic version of this to show you how a computer would work just from the stuff that we've learned up until now, using loops and using conditional logic. So what are we going to do? Well, this is the exercise. And you can check out the REPL here, or you can recreate this, or again, in this video, you should have resources attached that you can play with it yourself. And what I want you to do is I want you to loop through this list of lists, and every time you encounter a 0, I want you to display on the screen over here an empty space. Because 0 in a computer denotes nothing, right? We want a blank on the screen. However, when I see a 1, I want to simulate a pixel, right? That tiny, tiny dot on our computers that can be full of colors. It could be green, it can be blue, it can be orange. But for our case, I want it to be a star. And using that, I want you to create a program that takes this picture that, let's say, is in our database or in our computer's hard drive and displays it on the screen using space or multiply. And all I want you to do is when I click run, I want you to display that image right here. All right, this is a little tough one and I'm kind of letting you figure out on your own, but trust me, you've learned all the tools necessary to do this. Pause the video, give it a go. Otherwise, I'm going to show you how it's done. So the very first thing I like to do is to think about what I'm about to do. I want to make sure that we have a plan in mind. So I'm going to comment first, and I'm going to say, well, we definitely want to iterate over a picture, right? So we're going to do some sort of iteration here. So that's number 1. And then in here, I want to say that if it's a 0, then I want to print an empty space. And if it's a 1, I want to print a star. All right, so that's the plan. Okay, so this shouldn't be too hard. Actually, before you get started, in order for this to work, you need to Google a special parameter or special option that you can give the print function. And as a matter of fact, the print function that you need to add, or the option that you need to add, is this end option. And if we scroll down, it doesn't display it that well, but you can see here, string appended after the last value. So the default when we print something is a new line, but ideally we might not want a new line. So when that happens, you might have to use this end option. Now, I know I left it really vague. I want you to practice Googling this and figuring out from your mistake. You're going to have a bug when you create this code, when you try to display this information. But try to solve it using the tools that you have of problem solving. All right, enough talk. Let's get to it. So the first thing I want to do is iterate over the picture. I'm going to say for image in picture, because, well, this is one picture right here. So this is the picture, but it's inside of a list because we can have multiple pictures. And then I'm going to loop once again over this individual list. So once again, I need to do a for loop, and this time I'm going to say for pixel, because each one of this is a pixel in the image. So this is a nested for loop. Now, I'm going to add a conditional and say if pixel equals 1, then I'm going to print a star. Otherwise, I'm going to print an empty string. Well, maybe not empty, right? Because we do want a space, a blank space in the image. All right, so let's see if this works. If I click run, that's not really what I wanted. I want a clear image here, but I'm just getting things one in line. And remember, this was the little trick where a print, every time it prints, it creates a new line. The default, again, if we close this, you'll see is that end equals to this escape sequence of new line. So we can change that by simply saying star, comma, end, and then I'm going to say for the end, I don't want a new line. I just want, well, a string, but an empty string. And same over here. If I do comma, end, and if I click run, all right, it's getting a little bit better, but now I have an issue where we don't have any new lines. Everything is on one line. That's not good. How can we solve this? Well, ideally, at the end of this first loop, where we're just going the image or the line in the image, at the end of this, we create a new line right here, right? So again, looking at the indentation, I don't want a new line on every pixel, which we had the first time, but I also want to add a line between the lists of rows. So maybe a better name for this will be a row in picture. And in here, I'm going to add at the end of this for loop, so after we're done looping through the entire row, at the bottom here, I'm going to print an empty line. But remember, the default is going to be a new line. So again, an empty string, it's going to default to a new line, and we're still going to have this code. If I run this, I get an error because image is not defined because I've just changed this to a row. So let's do row here, click run, and look at that. We have our beautiful Christmas tree. If you don't think this is beautiful, this is the best I could, but this is a Christmas tree. And we finally have it displaying. We've used loops, we've used conditional logic, and we used a little Googling to figure out, hey, we need this option. Now, our code works, but I want to do something better here. And in the next video, I want to clean up this code a little bit and cover a very important topic when it comes to programming. I'll see you in that one. Bye-bye. It's happening, our next developer fundamentals, and that is, what is good code? I mean, what is good? That seems so vague, right? Like when somebody says, I'm a good coder, I'm an excellent programmer, he's a senior programmer, he's an expert programmer, he's a tech lead, he's a genius. What does that really mean? Well, you can narrow it down to these simple statements. What is clean, good code? I kind of gave it away. The first one is clean. That is, we want to make sure our code is following a style that, let's say, the Python community endorses. Are we following the best practices? And Python has this great feature of auto format. And Python has standard ways of using spaces to make sure that our code is clean. I'm not using unnecessarily ugly spaces like this, or maybe making lists really weird and funky, maybe no spaces in between here. Maybe I have a lot of random comments over here. We're keeping our code clean. We make sure that every line that we have is easily readable, but also we don't have any extra stuff that we don't need in there. And this also relates to the idea of readability. Now, readability means the ability to read your own code. Maybe 2 years down the road, you're going to come back and look at the code. Are you going to be able to understand it? If you work in teams or for companies and other coworkers come and look at your code, is it easy to understand? And here, this is obviously personal preference, but most of the time the ideas are simple. For example, I'm using names here that make sense. If I had variable names that don't make sense, it'll be really hard for somebody to read my code. Maybe people will be confused why I have this print statement here. In that case, maybe I should comment in here being like, need a new line after every row. Or maybe they'll be confused why we need this as well. So depending on your style, you might want to add comments. Make sure that the naming of your variables are good, and maybe making sure that it's not only you that understands the code. The other one is the idea of predictability. And this is my favorite one. That is, sometimes people try to be really clever with their code, trying to have the most compact code, or using the newest features or some really obscure tools or functions that are not very common just to look, well, frankly, smart. But you want to have code that makes sense, that does things, just one thing really well. Now, this code is quite small, so it's quite predictable. You know, it just has one pass-through and it's easy to predict what's going to happen. We're going to print. But as we get more and more into the course, you'll see that our code is going to get larger and larger. And having predictable, easy to understand code is really important. And then finally, this is an important principle that you hear everywhere, is DRY. Do not repeat yourself. You don't want to have code that you're constantly repeating yourself over and over. Again, this is a small example, but it's very easy as a programmer to say, oh, I'm going to copy this and then I'm going to run this again so that if I click run, look at that, I have 2 trees now. This is amazing. But maybe that's not the best idea. You now have 28 lines of code, and people might be confused why we're doing this twice. Maybe instead, we want to programmatically have a counter here of maybe saying running this twice, or maybe using something like functions, which we'll learn later, to make sure that we can repeat this process over and over and over. Now, keep these in the back of your mind, because throughout the course, we're going to explore these topics. But let's say I just came onto this code and I wanted to clean it up a bit. Again, this is just personal preference, but these are some of the things that I would do. One is here, pixels equal to 1. Instead, this is kind of confusing. I'm just going to say if there's a pixel here, and I know that pixels are either 0 and 1, then print here, because this is a truthy value that will just evaluate to true. So that just kind of cleaned out my code a little bit better. Next, another thing that I might do, maybe I want to make this more extensible, which might mean doing something like, let's say, fill variable that equals to the star, and then maybe empty, which equals to an empty string, and change these to fill and empty. Now, this is extra line of code, but for example, if we're doing this multiple times, instead of perhaps maybe we're running print over and over and over, or maybe we have another line of print over here, and another line of print over here, and then maybe another line of print over here that is empty. Instead of me having to change 5 locations here, I can now change just this part. And maybe instead of star, I want to display, I don't know, $sign. And if I run this, all right, I get a little different image here. But again, I was able to just change the variable, and the variable was used to fill out whatever I needed done. Now, these are all things that you do need a bit of experience to get used to, but we'll hopefully explore this throughout the course, and by the end of it, you'll have all these best practices in mind. I'll see you in the next one. Bye-bye. Welcome back. Let's do an exercise where we check for duplicates in a list. So I have some list here, and I want you to be able to check this list and print whatever the duplicate values are. In this case, we see that N has duplicates and also B has duplicates. So I want you to print B and D as a list in here. How would you go about doing that? Pause the video, give it a go. Otherwise, I'm going to keep going with the answer. And by the way, you're not allowed to use sets for this. So for this exercise, you can't use the data structure sets. Instead, you have to just use conditionals and loops that we've learned in the past couple of videos. So give it a try, pause the video, and when you're ready, I'm going to go ahead with the answer. First, I'm going to create a variable called duplicates, and this is going to be an empty list that we're going to populate with any duplicate values. Next, I'm going to loop over this list, so I'm going to say for value in some list. And in here, well, what can we do? This is a tough one, but what I'm going to do is say if some list dot count. Remember, count allows us to count how many times an item in a list exists. And I'm going to say value so that some list dot count, and I give it A, it's going to count for me how many times A happens in the list. Very, very useful. Again, if you didn't come up with that, there's many solutions to this problem. So there's no one right answer. I'm just showing you how I would have done it. Now here, I'm going to say if that's greater than 1, in that case, that means there's a duplicate. So I'm going to add it inside of the duplicates. So let's just go ahead and say dot append, because I want to append, and in here say value. And at the end of all this, let's just print duplicates. Now let's see if this works. I'm going to click run. And all right, I get both B and N. But I don't need this duplicates. I just need to know what are the duplicates. I just need one instance of B and one instance of N. So what we can do here is do another if statement and say if value is not in duplicates. And yes, this is a bit of a trick. You may remember that not is the opposite, right? So we're checking, hey, is value in duplicates? And not, essentially says, hey, if value is not in duplicates, it reads like English. And this is going to evaluate to true and false. And then finally, make sure that we get the indentation right. We're going to append the value. So if I click run, I get B and N. Again, if you didn't get this right away, don't worry. It can get tricky, and this is one of those things that you just need to keep practicing. But you see here that I was able to use loops. I was able to use logical operators like not and conditionals like if statements to solve a problem in just a few lines of code. It's time to talk about functions. This is where things get really interesting. Because up until now, we've seen functions, right? Functions were things like print, like list, boolean. We even saw the input function to get the input of whatever the user types. And those allowed us to perform actions on our data types. But the true power comes when we can start creating our own functions. That's right, we're not limited to whatever Python gives us. We're able to create our own functions and use them in our programs. So let's learn how to do that. The way we create a function in Python, and functions, by the way, exist in all programming languages. They're very, very important. If we do def, that lets the Python interpreter know that we're about to define a function. Def is short for define. So the interpreter is going to say, all right, they're about to define a function. What's the function going to be? Well, we can create whatever we want. We use the same naming case as we do with variables to define our functions. So let's create a function. Again, we'll call it, say, hello. Just a variable that I created, but this time it's a function because we use the def keyword. Now in here, in say hello, we also add the brackets to let the interpreter know that this is something that we're going to take action on, or this is going to perform an action on a data type. We use the colon, and then within this block of code, we can say print hello. And that is a function. If I click run, nothing happened. Why is that? Well, we've created the say hello function. We've defined it, and now it's living somewhere in memory on our machine. However, in order to use a function, remember, just like we use the print function, we have to call it with the brackets. So after we define a function, we say hello. And did you notice how my REPL, as soon as I said say, actually gives me this say hello command because I've created it. And you see this purple box, which shows that it's a function. Well, we now have it available for us to use, just like we had the print function available for us to use. So if I do say hello and run it with the brackets, and I click run, I get hello. How cool is that? By the way, what happens if I run it without the brackets and I click run? Nothing happens. Because remember, in order for us to take an action, we have to let the interpreter know, hey, I want to run say hello. Now, the reason functions are so powerful is because of the principle that we've talked about, right? The idea of DRY, which stands for do not repeat yourself. Functions are really, really useful when you have things that you want to do over and over. For example, the print function, we've used it a lot. Imagine if we had to code that ourselves every single time and say what print function does. Luckily, Python gives us print because it's such a useful tool. But if in our program we want to say hello multiple times, and you can imagine this actually being a lot more complicated, maybe 10 lines of code. Instead of writing those 10 lines of code over and over, I can just define it as a function and use it anywhere I want in my program. For example, remember this, where we had a picture and we printed a Christmas tree? Imagine if we wanted to run this multiple times. Well, in order to do that, I would copy and paste this code and then add it again. And if I click run, I now have 2 Christmas trees. But look at that, 26 lines of code. I just copy and pasted the same thing over and over. With a function, we can do something like this. I can say define show tree colon, and we now have a function. But remember the indentation in Python, right? Indentation is important. We have the semicolon, we're defining a function, so we have to create that code block inside saying, hey, whatever's indented here, that's part of this function. So now that we have the show tree, check this out. I can say show tree, run it again. Maybe let's run it 3 times. If I click run, how cool is that? I'm able to do the same thing over and over by just calling this function. And that's the power of functions. Functions allow us to keep our code dry, we don't repeat ourselves, and reuse things that our machines can do over and over. And the beauty is that this stays in memory for us. Show tree now means something to this program because we've created it. So we have our own custom action that we can take. Now, what happens if I move show tree here to the top? Well, if I run this, I'll get an error, name error. Name show tree is not defined. Why is that? Well, because our interpreter goes line by line. It first says, all right, picture equals to this value. And then it goes to line 11 and says, run show tree. But we haven't defined show tree yet. So the Python interpreter is going to error out and say, hey, I have no idea what show tree is. What are you talking about? Instead, with a function, we need to make sure that we define the functions at the beginning so that Python interpreter says, all right, show tree now means this. I'm not going to run it. I'm not going to use it yet. I'm just going to keep it in memory. And when I finally come across show tree, I'll know that it means something. I'm going to grab it from memory using show tree, and then I'm going to run it using the brackets. For example, if I do print show tree without anything, without the brackets, if I click run, you see that I get function show tree at this location. This is just the location in memory. This is the bookshelf where we store that show tree function. Very, very cool. And functions are an important, powerful concept in programming. And in the next video, we're going to extend this and explore this a little bit more. I'll see you in the next one. Bye-bye. Let's talk about arguments versus parameters, which is one of our key terms that we use when describing functions. Let's see what they mean. You see, right now, our say hello function is pretty generic. Very simple, right? We're just, printing hello. It's kind of useful, but not really. The power of functions, beyond just being able to call this multiple times, because it only lives in one location in memory, is this ability for us to make it dynamic. For example, in these brackets, I can give it what we call parameters. So in here, we give it parameters inside of the bracket. So for example, I can give it name, which is a variable that I just made up. I can call whatever I want. And I can leave it like that, or I can keep giving it parameters, as many as I want. I can keep adding 100 if I wanted to. So in this case, let's just say this is an emoji. So these are 2 variables or parameters that I've created. And this say hello function is able to receive these 2 parameters. What does that mean? It means that we're able to use these variables inside of this function. For example, I can create this as an f string and say, hello and add the name, and then finally add the emoji. And because I have these as parameters, I can use them as variables inside of this code block. Now, these parameters allow us to give the function, when we call it, what we call arguments. And by the way, the confusion between parameters and arguments, people usually say one when they mean the other. It's a little tricky, so hang in there. Arguments are used as the actual values we provide to a function. So now in say hello, I can give it a name. In my case, let's just say hi to myself. And then I can give it an emoji. And you see how my editor is giving me the hint that I should give it an emoji because, well, I defined it here. Again, something that editors help us do. So let's just give it just a smiley face with the tongue out. Now, these are arguments. These are the actual value we provide to the function. And the name of the variables that we use, that we receive, are called parameters. So parameters are used when we define the function, and arguments are used when we call the function. Define and call. And by the way, some people also like saying call or invoking the function or invoke the function. So if you ever hear those words, you know what they mean. So if I run this, I get hello, Andre, with that smiley face. And this is when functions get really powerful, because we're able to not just make generic functions that always do the same thing, but we can create functions that do things based on what parameters we give it, or what arguments we call it with. So that now I can use the say hello function to say hello to my friend Dan, and also my friend Emily. And if I click run, we've made our function more extensible. We can use it in multiple places. And if we're designing a game, well, we've just used this to greet our users. And based on the username, I can use the same function over and over. Again, we're keeping our code dry and clean by doing something like this. How cool is that? All right, let's take a break, and I'll see you in the next video. In the previous videos, I showed you how to define a function with parameters. Now, the way I've shown you this and these parameters is what we call positional parameters, or we might want to call them positional arguments. And they're called positional arguments because the position matters, right? If I change our arguments to, let's say, Andre as the second argument, and if I click run, you see that I get hello, smiley face, Andre, which maybe is not what we wanted to do. Positional arguments are arguments that require to be in the proper position. So if we defined name here first and then emoji second, you have to make sure that the first argument will be the name and the second argument will be the emoji. However, there's something called keyword arguments. And keyword arguments allow us to, well, not worry about the position. What do I mean? Well, I can do something like this. I can say hello, and in here, give it a keyword and a value. So I'm going to say emoji equals to, let's say, this smiley face, and then comma, name equals to BB. Now, if I run this, you'll see that I get hello, BB. Because I was able to use keyword arguments, I tell it explicitly, hey, I want emoji to be this and name to be this. So positional arguments, these matter, but keyword arguments, it doesn't. Now, I argue that this is bad practice because you're making the code more complicated than it needs to be. If the definition of the function is to give name and emoji, you should follow that practice and not confuse other developers, then just stick to that name and emoji. So you can still use keyword arguments, but make sure that they are in order, because why wouldn't you just follow what the function tells you? It's the same result, but at least this way you are following, well, the standard flow. And by the way, these keyword arguments can sometimes be confused with what we call default parameters. I know it can get really confusing, but this is something that will come naturally to you after you practice a little bit. So I'm going to just comment this out and show you how default parameters work. Default parameters allow us to give right in here, as we're defining the function, what we want as default. In our case, let's say Darth Vader is the default name, and the emoji will be this little angry Darth Vader. Well, it doesn't really look like Darth Vader, but this is the emoji that we're going to use. So what does this do? Well, if I run my program, everything works the same. If I do keyword arguments and run my program, nothing changes. Let's make this a little bit bigger. However, default parameters allow us to do something interesting. For example, if I run another function, say hello, but I forget to give it parameters or arguments in our case, well, if I run this, I get hello Darth Vader. Because with default parameters, it says if you're not able to get name and emoji because you were called without any arguments, well, in that case, make default Darth Vader and make default emoji this little emoji. If I use, let's say, just one argument and I click run, then, well, it will fill that name variable, but anything that we don't give it, like emoji, will be predefined. So this is a great way to make sure that your function runs even if it's called the wrong way. So keyword arguments increases the readability of your code because you know exactly how we're calling say hello. And default parameters allow us to keep our functions a little bit more safe because we make sure that when we use a variable, we're going to have it no matter what, regardless of how it is being called. But positional arguments are also useful because it's nice and clean, right? We're just following what the function tells us to do, and it's easy to read. So there's pros and cons of using each, but I hope this demonstrates to you some of the ways that you can define functions and also call functions. I'll see you in the next one. Bye-bye. Welcome back. In this video, I want to talk about an important concept, which is return. It's a keyword in Python that we are going to see a lot when working with functions. So let's have a look. If I, let's say, want to create a function called sum, which, by the way, already exists in Python, but we're going to create our own. And I'm going to say num1 for number one and num2. Well, our sum function is going to add num1 plus num2. Nice and simple function. Now, if I run sum with number 4 and 5, guess what's about to happen? I'm going to hit run, and nothing happens, which, I mean, might not be surprising to you because we're not printing anything, right? But what if I run print here? Will this change? Let's see. I get none. Is that what you expected? And we've seen none before, right? I mean, remember when we had a list, let's say 1, 2, 3, and then we did something like clear on it? In our editor, it gave us this little arrow and said none. And we talked about this idea of on lists, something like clear changes the actual list and clears everything and empties the list, but it doesn't return a new list. It just modifies the existing list, but instead just returns none to us. Well, functions are just like that. They always have to return something. And when they don't return anything, like there's no return keyword here, it automatically returns none. So if we don't have something like return here, it's always going to return nothing. But if we add return, it's going to say, as soon as we get to line 2, hey, I want you to exit this function. And when you exit this function, I want you to return whatever this expression gives us. If I click run, I get 9. If we change this to 10 plus 5, we get 15. And this is a good general rule with functions, because functions can do two things, right? One, it can return something. So at the end of the function, whatever after the function gets run, we return something, either none or some sort of a value, some sort of a data type. Or we can have a function that doesn't return anything, but perhaps modifies something. So for example, I could print hi, and if I hit run here, I return none because I don't have that return statement. However, my function does something. It modifies, well, the look of this text, right? It prints hi for us. So a function either modifies something in our program or returns something. And this is a topic that is quite advanced that we'll get into later on when we talk about functional programming. But a good rule of thumb with functions is this. A function should do one thing really well, and usually a function should return something. Now, this doesn't mean that any function that maybe does multiple things or any function that doesn't return something is bad, but it's generally good practice to make your code simple and readable to have these two rules. For example, here, if I have print and addition, well, this function is doing multiple things. It's worrying about printing and it's also worrying about summing. And the definition, this function, is called sum. I mean, if I didn't know or I didn't see this and all I did was run sum, I think having printing hi would be surprising because the name doesn't really describe what it does. I mean, I'm expecting this to be summed. Why is my program saying hi? So we want to make sure that our function does one thing and one thing only really well. Because as we'll see later on, we can combine and run different functions together. And then also, we want to make sure that we return something. Because this way, what we can do is we can actually assign this return value to a variable. For example, I can say total equals to sum 10, 5. And because this function returns something and when it's done running is going to have 15 as a value, that's the same thing as what we're doing here. And here's the cool part. Now I can run maybe sum 10 plus total. Now let's go through this one by one. I define my function. The Python interpreter is going to say, all right, I know what sum is now. You've defined it. I'm going to keep it in memory. It's going to keep going until line 7. And it's going to say, hey, I want a variable total. And I want that total variable to equal sum 10, 5. And before we even assign anything to total, Python interpreter is going to say, sum. What's sum again? Oh, I remember. Here, it's in memory. Okay, at sum, I'm going to give it arguments 10 and 5. So it's going to go run that function as soon as we end this closing bracket. it's going to go into the sum. It's going to say, hey, num1 is going to equal 10. Hey, num2 is going to equal 5. Now we go to line 2, and it's going to say, hey, I want you to add 10 plus 5 because I know what these variables are. And then once you're done with that, and this turns into 15, I want you to return. So the Python interpreter, finally, when it's done calling sum, is going to say, hey, assign the value of 15 to the variable total. And then it's going to go to the next line. Hey, I want to print something. What do you want to print? Well, I want to print this. It's going to say, hey, what's sum? I know what sum is. I have it in memory. And then again, it's going to say 10. And then the next argument is going to be total. Hey, what's total? Let me go in memory and find out. Oh, it's 15. So it's like saying 15. And this is the power of functions, right? I'm able to return things and assign them to variables and call them like this. And I can keep running them if I wanted to. If I want to make this even simpler, I can go sum instead of total will be right here. And look at that. Now I have it all in one line. And if I click run, again, it still works. Okay, but what if we do something like this? What if I say define sum, and then I'll say define inside of here another function. And this function takes num1 and num2. And in here, we finally return num1 and num2. Let's test this out. What do you think will happen? Well, first, let's say total equals sum 10 plus 20. And then I'm going to print total. If I click run, I get none. Now, why is that? And this should be obvious to you because here I'm saying, hey, I want you to define sum. And what are we going to do with the function sum? Well, inside of here, I'm going to define another function. But this return statement is actually not run, right? Because all we're doing inside of this block, this code block, is this part. We're defining the function, but we're never calling another function. So this returns none. And we've lost the ability to call this function. So how can we solve this? One way is to return, right? So at the end here, we have to make sure that the indentation is right. And we're going to return another func. So let's add return and see what happens here. If I click run, all right, I get this function now. So total is going to equal this function that we returned. And it's in memory. Okay, but I'm not getting the result that I want, right? And why is that? Because, well, we're not calling this function. So there's a few ways that we can do this. We can either give it the parameters or the arguments in here. So let's say 10, 20, and if I click run, I get 30. Or if we want to keep whatever we give it here, I can just simply say another func. So if we give it num1 and num2, and I click run, hey, look at that, I get 30. Now, this video you might have to watch over and over because it does stretch your mind a little bit. And to be honest, this function is not very good because it's very confusing. Your function should be easy to understand. So we might want to change this up a bit. Maybe instead over here of having the same parameter names, just to clarify it, maybe we can say n1 and n2. And then here we do n1 plus n2 to clarify that when we return this other function, I'm using the parameters num1 and num2 that we called here. Because this definition of a function doesn't really care what these things are. It only cares when another function gets called. Now, If you need to pause the video and look at this and maybe practice this a little bit, that's completely understandable. But I wanted to show you the power of return. You can have nested functions, just like you could with conditionals. But you have to be careful that your function either returns something, otherwise it's going to return none. And most of the time, you're going to want to return something from a function. So we can do something like this where we assign it to a variable so we can use it later on in our programs. I'll see you in the next one. Bye-bye. One last thing. A return keyword automatically exits the function. So that in here, if I added another piece of code like print hello, or maybe even have return 5 in here, you see that it's still valid. But if I run this, I still get 30 because the interpreter never gets to line 5 and 6. Because as soon as we return something from a function, it exits that function. And the reason that this part doesn't exit the function is because, remember, inside of this function, we're defining. So we're not actually running this part. We're just saying, hey, when we see another function coming up in our code, we know what it is, but we're not going to run it. So it's going to look like this. And as soon as it sees the return statement, when it gets called, it's going to say, all right, I'm exiting out of this function with this value. Just a little heads up. Hey, long time no see. It's been a while, but I'm glad you're back, and I'm glad you're still hanging in there. Trust me, things are going to get a lot more fun once we actually start building applications, but we do have to go through the basics, so hang in there. Now, you may have heard me mention methods and functions before, and I briefly touched on the subject, right? We have functions like list, print, we have things like max, min, what else do we have? We have input. These are all built-in functions in Python. Python just comes with this and we're able to use them. And we also learned about functions that we can create ourselves. Custom functions like, well, some random stuff. And I just created a function that does absolutely nothing. I can just pass through. And these are all functions because the way we call them is, well, we say some random stuff, and then we call it with the brackets and give it some sort of data or leave it empty. But we also learned about methods. And methods were different because the way we used them was using the dot notation. We said dot something. For example, if we had a string hello, and I do dot, I get a list of all these methods that the string data type can use. These aren't things that we can use like this, because if I do capitalize like this, well, it's going to give me an error. It's going to say, well, I'm going to get an error with max because it's expecting an argument here, but let's comment this out and click run again. I get name capitalize is not defined because it's not a function. It's a method. And a method has to be owned by something. And who owns a method? Well, whatever is to the left of the dot. In our case, the string owns the method capitalize. And that's what methods are. They're built-in objects that have methods such as strings, dictionaries, sets, tuples, all the things we've talked about, where as soon as we do dot, we have access to all these methods. They're owned by an object or a data type. And the fun thing is that there's ways to build your own methods. And I'll show you how to do that later on when we start talking about classes. But you can see here that our editors help us determine what type of methods that we can use. And again, these are built into Python. And you can also learn about these methods that we can use by going to the Python documentation, right? Python 3 documentation. is going to have a ton of things for us. If we go to library reference, for example, we can see here that we can learn about built-in types. So let's go to the set types. And here you can see that we have set type, and it shows us how we can use it. Now, Python doesn't have the easiest documentation to read for beginners, unfortunately. So sometimes it's better to actually just Google instead of going through the actual documentation. But you see here that the set type has clear, has pop, has remove if we want to use it. We have update, and these are the methods that we can use. But at the end of the day, both methods and functions allow us to take actions, right? To take actions on our data types, to have our programs do something. And although they have these different names and one has a dot in front of it and another one, well, we can just call it like this, the difference is very minimal. But keep that in mind when you hear people talking about methods and functions. There is that difference. And like I said before, we will get to methods when we talk about classes to show you how we can create our own. I'll see you in the next one. Bye-bye. There is a unique thing that we can do with functions that we haven't seen before, and they're called doc strings. Let me show you what I mean. If I had a function here, and we'll just call it test, and test, let's say, receives a parameter that is a, and in here, it's going to print a. What a useless, completely useless function. Now, if I run this, well, nothing's going to happen because I have to call test and then say, well, exclamation marks. And you see that our function works. But we can actually, with functions in Python, use something called doc strings. And it looks something like this. You do single quote, single quote, single quote, so 3 of them. And then at the bottom, once again, single quote, single quote, single quote. So at the beginning of the function, like this. And in here, I can add some info about the function. For example, this function tests and prints param a. Now here's the interesting part. If I run test here and I do brackets, look at that. My editor tells me info. This function tests and prints param a. This is called a doc string. And what it allows us to do is to actually comment inside of our functions in a way that if another person, let's say, is using the test function, they can actually, let's say in the future, when we write large applications where it's not just 10 lines of code, or maybe we have different files, instead of just finding what test does, as I'm typing it, it's going to tell me, hey, test is going to return or print param a. So I find out information about this. And if we ever use something like length, for example, and run this, you see that this gives us information about the function by using doc strings, but it comes built in with Python. Another way to view this, mind you, when we talk about developer environments, our editors are going to do this automatically. But there's a few other ways that we can actually read this. For example, I can do the help function, which we haven't seen before, which comes pre-built with Python. And we don't want to call the function, I just want to call help on test. If I run this, look at that. I get test a info. This function tests and prints param a. So we can use help to find out what a function does, which is really, really useful. One other way to do this is to use what we call a magic method or a dunder method, which again, we'll get into later on in the course. I do double underscore, then I do doc, and then double underscore, like this. If I click run, well, we have to print something here. So let's print, click run, and look at that, I get the same thing. So these doc strings are really, really useful to add comments and definitions to your functions so that when other people on your, let's say, team or coworkers come across your function that you created, they're able to understand what it does right away without searching through your Python files or multiple files. Very useful feature. I want to talk quickly about the idea of clean code, something that we've talked about before. And this is a good example to do with something like a function. For example, let's say we had a function that perhaps checks if a number is even or odd. So let's say is odd or even as a function that takes in a number. And we're going to here say, well, how are we going to check? Well, we can use the modulo operator. I can say if number modulo 2, which remember gives us the remainder. And if it's an even number, the remainder is always going to be 0. So this is going to tell us if it's an even number. So if it's an even number, then I want you to return true. And if it's not an even number, so let's say num2 doesn't equal 0. So if this is an odd number, there's always a remainder. In that case, we return false. So maybe let's change this function to be more descriptive, is even. So it's going to return true if it's even, false if it's not even. So in here, if I do is even and give it 50, and I run, I get an error because I have to make sure that I do an if statement here. We have to print here, so let's do print and click run. I get true. If I do 51 and click run, I get false. All right, it seems to be working, but how can we clean up this code? Well, here's the thing. We have some ways that we can actually make this a little bit tighter. For example, if we're only checking for is even, we don't really need to check this again, because if number modulo 2 doesn't equal 0, that is, if a number divided by 2 doesn't always have a remainder of 0, we always know that it's not going to be even. So we don't even need this statement. We can just say else, right? So that if I run this still works. So, all right, so we cleaned up our code a little bit. But here's the thing. Another thing we could do is we know that return exits the function automatically. So we don't even need the else statement. I can just say return here, because it's only going to get to line 5 if this statement is not correct. So if it's not even, well, I'm going to skip line 4 and go to line 5. So that if I run this still works. All right, but we can make this even cleaner, right? Because right now we're just returning true or false. And usually if you have something like this where we're returning true, false directly, there's usually a better way. And that's using an expression that evaluates to a Boolean. What we can actually do is simply say, hey, remove all of this. And I want you to just return like this. And if we run this still works. And if I do 50, this still works. Because what we're saying here is I want you to return whatever this value is. And this is an expression, right? That's going to evaluate true, false directly. So we get the exact same result as we had before, but look how much cleaner that is. That is just nice, simple code. And as a developer, I can come in here and right away see that, all right, is even is just performing this operation and returning true or false. So this is a good way to think about clean code. How can you clean up your code? And mind you, there's no perfect solution. You can always clean up code. But thinking like this really allows you to develop the way that advanced programmers think. I'll see you in the next one. Bye-bye. Let's talk about something called arguments and keyword arguments. I mean, we've already seen that before, right? With a function, we actually have the special characters that we can use called args and star star keyword args. How can we use these? Well, let's have a look. Let's try and have a function, let's say define, and we'll call this a superfunc for super function that receives some sort of arguments. And these arguments that we're going to receive, and remember, although I'm calling these args, this itself is a parameter, remember? But let's say that we want to just return some of the arguments. And you might be wondering, wait, sum, don't we have to define that function? Well, sum actually exists in Python, as you can see over here. So we can just return the sum of the arguments. So let's try this. Let's say superfunc and give it arguments 1, 2, 3, 4, 5. If I click run, I get an error. Superfunc takes 1 positional argument, but 5 were given. And that makes sense, right? Like, I only have 1 parameter here, which is a positional argument that it accepts, and I'm trying to sum this. So it only receives 1, but I'm giving it all these things that it doesn't know about. And this is where we can use something like this. By adding a star to here, we're saying, hey, this can accept any number of positional arguments like this, as many as I want. As a matter of fact, let's print this out. If I do print star args, and we run this function, we see that the print star args gives us 1, 2, 3, 4, 5. These are all the parameters or the arguments that we get. And if I actually remove the star here and click run, look at that. I actually get this as a tuple. So args inside of this function is a tuple of arguments that I give it. 1, 2, 3, 4, 5. So sum of the tuple 1, 2, 3, 4, 5 is going to give us the right answer. It's going to print for us the answer 15. Very, very cool. So this way we can extend and use our star args to have a function that can accept any number of arguments. So what is this one now? Well, this one allows us to use keyword arguments. For example, let's say I have the star star keyword args like this. And by the way, this can technically be anything. So this is a variable that we're creating. So I can name it whoo if I wanted to. But the standard is to name it args and keyword args because other developers are using it this way, and it's just the way it's done in the Python community. Now with the keyword args, as you might have guessed, I can add keywords like num1 equals 5, and then num2 equals 10. So that if I print the keyword args and I click run, I get a dictionary of num1 equals to 5 and num2 equals to 10. So I can actually do something like sum plus sum of items in the keyword args and grab the values, right? We've seen that before. And let's actually grab this and do a for loop and say items in keyword args dot values. Remember to grab the values over here. And in here, just add up the totals. So let's say that in here, total equals or plus equals items. And we'll add a total in here that is initially 0. So that sum will be sum args plus total. If I run this, I get 30, which looks about right. Now, this does look a little confusing, so let's go over it. We have the star args, which allow us to grab these positional arguments and just sum everything. And we also have keyword args, which allow us to grab any number of keyword arguments and get a dictionary, which comes as keyword args, and then use them however we want. In our case, we're looping over all the values, so items in keyword arg values, and then I'm just going to total all those items, have a total, and just return the sum. Now, this is, again, extremely useful because our superfunc can now take as many arguments, as many positional and keyword arguments as we want. Now, one final thing. There is a rule of the ordering that we can do of our parameters here, right? So the order, the rule is this. First, in our parameters, we have, well, our actual params. Then we can do star args, then default parameters, then star star keyword args. Let me show you what I mean. If we want to define this function, we want to make sure that if we give it a parameter of, let's say, name, that should come before star args. And if we have default parameters, that should usually come after args, but before keyword args. So if I do, let's say, I equals hi, and make sure we add a comma here, we now have, following the rule, and by the way, you would never actually write a function like this because, well, frankly, it looks super confusing. Usually you're only using 2 of these, or maybe just 1 of these. But this way, I can call this function with name, Andy, then my args, then my default parameter, which will be I equals to hi, which let's say we don't even pass in. And then we have this. So if we run here, this still works. We are just not using name and I, but you see that I'm following the rule of params, args, default parameters, and then keyword args. All right, hopefully your head doesn't hurt too much after this one. Take a break, and I'll see you in the next one. Bye-bye. All right, it's exercise time. Let's combine everything that we've learned into this challenge. What I want you to do is to create a function called highest even, and this function is going to take a list data type. And this function, for now, will just pass, but I want you to fill in this part with whatever you think is going to allow us to achieve this. If I do print highest even, and I give it a list of, let's say, 1, 2, 3, 4, 8, I want the highest even to be printed in this list. And actually, let's do 10 here. So the highest even number in this list is 10. Just for fun, let's add 11 as well. So the answer should be printed here as 10. So based on everything you've learned so far, try to fill this part so that you create your own function, highest even. Pause the video here, give it a try. Otherwise, I'm going to go with the answer. So what I want to do here, let's think about this, is I want to make sure that, first of all, we only consider the numbers that are even in here. So maybe what I'll do is create a new list called evens. And evens is going to be an empty list for now, but I'm going to populate this with all of the even numbers. So I'm going to remove 3 and 11 from this. So let's do that. I'm going to say for item in li, if item modulo 2 equals 0, which means it's going to be even, then I'm going to even append the item. So I'm going to add it to this new list. And then finally, in here, once we have the evens list, I want to find the highest number. Now, You can do this manually and go through it one by one, or Python comes with a nice function called max. And as you can see, we give it an iterable, and it'll tell us what the max number is. In our case, we can just give it evens. And remember, we want to return something from this function. That is, what is the highest number? Well, we want to return whatever the max of the evens is. If I run this, I get 10. Awesome. Looks like it's working. Now, some of you may have gotten tricked and tried to return inside of the for loop. But if we do this, remember that this still works, but we actually return from the function when we hit our first item. If we had another item, let's say 2 in here, and I click run, we get 2. And why is that? Because I'm returning when we loop the first time through our item, which will be 2. Is 2 an even number? Yes, it is. So we're going to append. And then we're finally returning max evens, which only contains the item 2. So you want to make sure here that the indentation really matters. And if you're returning something from inside a loop, you want to make sure that that's your intended behavior. You usually want to loop through something and then return. So make sure you don't prematurely exit the loop. Nice and simple. Remember, your answer may be different than mine. There are many ways to go about this. But hopefully, by practicing this, you have a better idea of functions. We now have a great utility function, highest even, that we can use all over our program. Good job getting this far, and I'll see you in the next one. Bye-bye. In order to finalize our understanding of functions, we have to talk about scope, another one of our key terms. What is scope? Let's have a look. Scope is something present in a lot of programming languages. And scope simply means what variables do I have access to? That's it. So what do I mean by that? Well, we've seen this before, right? Where I do print and then let's say name. If I click run, I'll get an error, a name error. Name is not defined because, well, it doesn't exist, right? And up to this point, we haven't really discussed this, but this is because of scope. What variables do I have access to? The Python interpreter says, hey, what do I have access to? And when we use something that it doesn't understand or it doesn't have access to, it's going to throw a name error. Or variable is not defined error. And scope in Python has what we call functional scope or function scope. What does that mean? Well, up until now, when we create a variable like total equals to 100, this is part of what we call global scope. That means anybody on this file has access to this total variable. I can use this inside of a conditional block. I can use it inside of a function. It has global scope. But when I say Python has function scope, what I mean is that when we create a function, and let's say we create total as sum, or let's say sum func, and we create total inside of the function, if I print total here and I click run, I get the same thing. Name total is not defined. This is because of Python's function scope. Anytime we create a variable, if it's not inside of a function, then it is part of the global scope. We have access to it. But you see over here, we get that red underline, undefined name total. If, let's say, for example, I had a condition, if true, then x equals to 10. If I do this and I say x and I click run, I have 10. Because, well, although I have indentation, the only time I create a new scope, you can think of this as a new universe. that we spawn? Well, we can only do that when we define a function like this. So think of scope as a new world that we create. In our case, when we create a function, we create a new world, that anything that's indented inside of the function is its own world that we don't really have access to. We can only use total if we indent print and it's part of this world. That's what scope is. Who has access to who? So let's take a break here, and I want to play a little game in the next video where we try and figure out who has access to who. I'll see you in that one. Bye-bye. All right, let's play a little game. Can you guess what the output of this program is going to be? I have over here a equals 1. Then we create a function called confusion where we have a equals to 5 and we return a. My question is, when we print a and when we print confusion, what do you expect to happen here? Take a second to figure out, pause if you need to, and let's find out. 1 and 5. Is that what you expected? Let's go line by line. First, we assign value of 1 to variable a. We then create a function called confusion, and Python interpreter is going to say, all right, confusion function, I know what it is. I'm going to put it in memory. When you need to use me, just let me know. And then it's going to go to line 8. And line 8 is going to say, hey, print a. What's a? Well, the only time that I've seen a is right here, a equals 1. So go into memory, what's a? A equals 1. But then when I run confusion like this, I'm going to say, hey, a is going to equal to 5. And now we return a, which is 5. Okay, what if I change the order of this? What if I go like this? What will happen? If I click run, is that what you expected? Once again, we have a equals 1, then we define the function, and then we print confusion. Now, confusion here is going to assign a equal to 5, and then return a. But why didn't this change? Why is a still equal to 1 by the time we get here? And this is because of scope, right? What the Python interpreter does is when it runs the confusion function, it's going to say, hey, a is going to equal to 5, but I'm creating a variable here called a in my own universe. I don't know anything about a equals 1 here. I have my own universe. And after we run this function, then, well, we're done. We've returned the function and it's completely gone. But we never left the universe into the global scope. So there's a set of rules that the Python interpreter goes through to check a variable. And the rules are this. First, it's going to check with the local. So start with local. And what we call is a local scope. A local scope is a scope that's part of this local function. So a is a local scope. It's going to check there. Hey, do I know the variable a? Well, yeah. When I return a, I have a variable defined here. So it starts there. But let's say a wasn't there. Let's say I remove a and I click run here. I get both ones because the second rule is if there's nothing in the local variable or local scope, then number 2, is there a parent local scope? In our case, what's the parent of this function? Well, it's the global scope. But we can also do another function. Let's say parent. And parent is a parent of the confusion function. And in here, let's say a equals to 10. Now in here, we'll return confusion just so we can use it again and actually run it. So let's call parent and click run. All right, let's go through this so it's not too confusing. We have the parent function that gets called. So when we call that, we assign a equals to 10, and then we also create a new function, confusion. And then finally, we return confusion and actually run it. So we're going to return a, and then in here, print whatever the value of a is, which is 10. And why is that? Well, because we first start with the local scope. Hey, does confusion know what a is? Nope, I don't have it in my local scope. Okay, does my parent local scope have it? So it's going to go up a level and say, hey, does parent function know what a is? Yep, I have a equals to 10. So it's going to print that. The third rule, or the third order, is global. And global is what we call the indentation of nothing. It's this file, right? Whatever the file has, that is global. In our case, if a equals to 10 doesn't exist here, there's no local, there's no parent local, and I click run, it checks the global scope. And then finally, there's one other rule, and this is number 4, and it's a tricky one. And this is what we call built-in Python, or built-in Python functions. So Python comes with predefined functions, such as, well, the sum that we've talked about before. This sum, let's say just give it 5, is going to check, or actually, let's not give it anything. Let's just do sum here. When I run this, I get built-in function sum. Now, how did it know what this was? What this variable at the end of the day was? Well, because it said, hey, do I have sum inside of this universe? Nope, I don't. Okay, do I have sum in my parent scope? Nope, I don't. Okay, do I have sum in global? Nope, there's nothing sum in here. And then the final thing it's going to check is, hey, is sum some sort of a built-in Python function? Yep, Python actually gives us sum, so you can use it, so it doesn't error out. And this is the scope rules that the Python interpreter follows. Very, very cool. There's still a few more things that we need to learn, so I'll see you in the next video. Welcome back. Let's try and answer some questions that you may have. For example, what about parameters? If I do parameter, let's say b here, what is this parameter when I use b like this? So let's say print b, and in here I'll run confusion with, let's say, the number 300. If I run this, this works. And that is because b, the parameter, is part of the local scope. That is, it's part of this. So parameters are considered local variables. We're able to use it inside of the function, but we can't use it outside of those functions. Technically, when we define the function, we let the interpreter know, hey, b is going to be a local variable. Okay, what about this? What if we have this, a, but I want to make sure inside of my function that I'm actually referring to the global a. Is there a way for us to just use this value without creating a new variable? Well, let's use a better example for this. Let's say I wanted to create a counter. So we'll have total equals to 0. And then in here, I'm going to say define count. And this function is going to say total plus equals 1. So we're going to add every single time. When we add count, it's going to increment 0 by 1, and then 1 by 1, so on and so forth. So we're going to return total at the end of this. Okay, so if I run here print count, let's see what happens. I'm going to hit run, and I get an error. Local variable total referenced before assignment. And that is because, well, count doesn't know about total. You're trying to use total, but we haven't assigned anything yet. But we want the total from the outside world to run. Because if I just do total equals 0 here, and I run count, that's great, I get 1. But what if I wanted to run count multiple times? What if I wanted to run count, let's say 3 times, so that the count total will be 3? So let's do print on the last one here. And I click run. I still get 1. Because every time we run the function, we reset the total to 0. That's not very useful, is it? So one way that we can fix this is using what we call the global keyword in Python. And global says use the global total, if it exists, in here. So that instead of having to create a new variable, I can use the global variable total. Check this out. Well, I get an invalid syntax, and that is because we first have to say global total is going to be used in here, and then we can say total plus equals 1. If I run this, hey, look at that. We have a proper counter. So global is a way for us to access this global variable. However, I argue that this is actually not a good way of doing things, because it can get really confusing when you start adding globals and all these different universes are accessing each other's variables. A better way of doing this is something called dependency injection. And this is a simplified version of it. But the idea is that instead of accessing variables outside of the function like this, which can get really, really complicated as files get bigger and bigger, is to do instead this. Total. Like this. We create a parameter, and then we pass in that parameter or argument in here. But as you can see, it's still 1 because by the time we print the third total, well, this never changes. This is a global 0. So instead, we can do something like this. We can say count total, of which we're going to count again, and then count again. If I run this, I get 3. And I know what you're thinking. This is completely insane. It looks confusing. Look at all these brackets. But let me show you what we've actually done. We're able to detach the dependency or the effect that this count function had on the outside global scope, and instead just focus on its health. All we needed to do was say, hey, I want you to give a count with total of 0, and then after that, this is going to evaluate to 1, and then we do count total of 1 plus 1 is going to equal to 2, and then count 2 plus 1 is going to equal to 3. And this way, we're able to still do our count without having to use that global keyword, which I would argue is nicer. Mind you, if this is your first time seeing this, it can get a little bit tricky. But at least this way, you know that there's different ways of doing things. One other word I want to show you is something called non-local. But for that one, let's take a break and I'll see you in the next video. Oh boy, there's some code on the screen and it looks terribly confusing. This is an example of a really convoluted, complicated function that you would never write, but it'll be good for exercise purposes. And we're talking specifically about this right here, called non-local. It's actually a new keyword in Python 3. And as you can see, my REPL doesn't even notice it, so it doesn't even highlight it in blue because it is a new feature. But I do want to talk to you about it and let you know what it does. The non-local keyword is used to refer to this part, this parent local. It's a way for us to say, hey, I want to use a variable that is not a global variable, but is outside of the scope of my function. So based on that definition, try and pause the video and see what this function might do. I'll run it right now and then go through the code. If I click run, this is what we get. So let's talk about this. We have an outer function, and then we call the outer function. So the Python interpreter is going to go and say, all right, we have an x variable that is local to the outer function. And then inside of here, we're going to define an inner function, another function. And in here, before we even call that, we jump to line 9 and say, all right, call inner function. We come back and we say, hey, line 5, I want to use non-local x. What does that mean? Well, I want to use this x variable because it's non-local. That is, I don't want to create a new x variable. I want to jump up the scope to my parent scope, my parent local, and grab whatever you find in there. As long as it's not global variable, any parent will do. I want to grab that non-local. So now this x is referring to the outer function here. So when we say x equals non-local, we're assigning this new string and replacing this local so that when we print inner x, we get non-local. But also when we print the outer x, we've modified this outer scope with the non-local keyword, so that becomes non-local as well. If I remove this line and let's comment it out, and I click run, you see the difference now. We have the inner non-local, but then the outer local hasn't been modified because this is a new variable. Again, I argue that this actually makes your code more complicated than it needs to be. So there are special cases where you might want to use this, but if you can, try to make your code predictable where you can avoid using things like non-local and global. Mind you, they are there for a reason because they are useful in some situation. With that said, keep in mind, make your code predictable, make your code clean, and I'll see you in the next video. I want to address a question that you may or may not have, but it's something that's taken me years to understand. And that is, why not just have everything as global variables? I mean, all this confusion of who has access to who. How easy would it be if everything was just on the main page, all our information, all the data on our global scope so that everything has access to everything? Wouldn't that be easier? And you'd be kind of right. I mean, that would make all this headache go away, right? But you have to remember that machines don't have infinite power, don't have infinite CPU, don't have infinite memory. They all have limited resources. And as programmers, we have to be conscious of what resources we use because sometimes that can cost us money, sometimes that can crash our computers. And scope is a great demonstration of this. For example, this code right here, when this function is run, we're creating technically just one location in memory for the x variable. So we have that bookshelf in our computer that is x, that's pointing to local when we actually call this function. And then when we say non-local here, well, we're saying just don't create another bookshelf for us, just use the one that we already have and assign it non-local. If we didn't have this line, by the time we get to line 7, we've placed in memory x equals to local and x equals to non-local. So we have 2 locations now in memory. Now, this isn't a big deal because, well, in this day and age, we do have a lot of memory. But as programs get larger and larger, this does become a bit of a problem. Okay, but what about a function? I mean, we learned that functions allow us to not repeat ourselves and being able to call outer multiple times. But another good use of functions is that once we call this function and all of this is done, the computer and the Python interpreter specifically destroys all this memory. That is, once we finish with the outer function, I can't really call print x here. It's going to give me an error. It's going to say, I have no idea what x is. And why is that? It's because after we call this function, the Python what we call the garbage collector, is going to say, hey, it looks like we're done with this function, and I see that this x variable, and this x variable, we're not going to use because we're done with this function. So I'm going to collect that garbage and then just throw it out. So I'm going to empty that memory cupboard so that other resources or other programs can use that. And that is a really nice feature where Python just automatically removes these for you so that you don't clog up the computer's memory. And that's why scope is useful. We don't have to think about it in such detail like I've mentioned it, but it's nice to know that it's there so that your programs don't hog up a lot of memory and they can run efficiently. This is a bit of an advanced topic, but I did want to include it in here so that you can think about why programs are designed the way they are. All right, I'm going to stop talking now. I'll see you in the next video. Bye-bye. Up to this point, we've learned about a few ways to organize our Python code. The first thing we did, we just wrote Python in a file, and that organizes it, right? Our entire code has been so far on one single file. So that was one way that we organized our code. Next, we learned about functions. And functions were used as a way for us to not write code that we repeat over and over. We could write functions that we can use anywhere we want in our file, so that we can call these functions over and over. And we can name the functions appropriately so that our code makes sense. And then we learned about classes, right? These blueprints that we can create objects from. We can instantiate new Python data types beyond the ones that they just gave us, right? Instead of just having dictionaries and lists, we can create our own custom ones, our own lists maybe that have extra features. And we're able to use classes to organize our code, to box them up, and give each class a certain method and attribute that packages it nicely for us to use. We also learned about functional programming and how, unlike, let's say, object-oriented programming, where we see a lot of classes, with functional programming, we just use a lot of functions, a lot of pure functions. And we have data that we just pass into those functions. And we organize things into small little pieces. All of these things were meant for us to keep our code clean, make our code more maintainable, thus keeping our code organized. Because as we write more lines of code, it gets harder and harder to keep everything in your head. If other people join your team to work on your project, they need an easy way to figure out how things are working. But we still have a problem. And that problem is that everything is contained in this one file. All the functions, all the classes we've been writing has been on just one .py file. But in real life, this isn't the case. We have a lot more code. And we can't just have one file with millions of lines of code. So how do we stay organized? Well, if we had multiple files of Python, like this, because our project is getting bigger and bigger, would this work? Is there a way for us to link all of these files together? As a matter of fact, there is. And this is very common practice all across industry. And we call this way of organizing code modules. And modules are simply, these files. Each one of these files, each .py file is a module. And by building these modules, kind of like we built different functions, kind of like we built different classes, because inside of these files, we can have classes, we can have functions. But we can also have different files, so a layer higher to divide up our code. And in this section, we're going to learn all about modules and try to master it and see how we can write organized code. Let's have a look. You can see over here, if I click on files in our REPL, we have a main.py. And every time I click run, this file got run. But what if we have more files? What if I add another file here? And we'll call it utility.py. So based on what I just taught you, these two things are what? They're modules, right? Main.py is a module, utility.py is a module. And when writing modules, we use the same principles as variables in Python, which is snake case. That is, if there's spaces, we use underscore, everything is lowercase letter. So how do we divide up these modules? And this comes with practice. When you're just beginning, it's hard to say, hey, what goes into what goes into what file? But it's similar to classes, right? Similar to functions. We want to divide up our code into chunks that make sense. Again, let's say we're working at Netflix. We might have a file dedicated to videos. We might have another file or module dedicated to the login of a user. Maybe another file dedicated to analytics and figuring out recommendations for users. We want to group these classes and functions together inside of a file that makes sense. Now, one of the most common ways to use a module is something like a utility. Let's say we want to create a utility module. That is a module that has a lot of, well, kind of like a tool belt. Very simple functions that we can use all across our project because we can imagine here having multiple files. So let's create a very simple example. I'm going to say a multiply function exists here. And this takes a num1 and num2. And in here, we're simply going to return num1 times num2, a very simple function. And once again, we'll also have a divide function. And yes, this is kind of useless because we can just use the plus or the divide operand in Python, but stick with me here. I'm trying to show you an example. All right, so num2. I'm going to return num1 divided by num2. Nice and simple. So this is our utility module that has all these functions for us. Now, notice here that we're actually not doing anything in this file. I'm simply defining functions, but I'm not running any of the functions. But let's say we have this utility module and I want to use it in my main.py file. How would we go about doing this? Well, the way we communicate between these two files is quite simple. All we need to do is use the import command. We import and then give it the file name that we want to import. What do we want to import? We want to import utility. Just like that. And notice that I'm not adding the .py because we assume that whatever we're going to import is going to be a Python file. So we don't need to do that, just the name, just like that. Now let's print utility here. If I run this, whoa, do you see that? We have module utility from, and then this is a file path that this website generates for us. So it doesn't really matter. Now, there's a few things that happened here. One is that we generated this py cache folder, __ py cache. And oh boy, what is this gibberish? This is pretty confusing, right? Well, this py cache is created every time we run a file with, let's say, import statements. So when we're using modules. You see, what PyCache does is when we click run, the interpreter is going to create this PyCache folder, and it's going to say, hey, I'm running this file, this one main.py file. Anything that main.py file imports, let's say utility in our case, I'm going to cache it. So see how here it says .pyc? This is because it's using the C Python interpreter. Remember? This is the C Python, which is the interpreter written in C. So this is actually a compiled file. So that next time I click run here on my main.py, nothing changes. Because what's going to happen is instead of loading up utility.py, it's going to load up this compiled version of utility because nothing has changed in utility.py. And this makes things faster when I try to run main.py again. That's what caching is. Caching is, hey, I'm going to remember this, and this is the compiled version, so I don't have to go through the compilation step again. But notice that the main.py file does not get compiled because, well, we run it every time. Now, if we change the utility function to not have the divide in there, I click run, and you don't notice it here, but this has now been rerun because we have a different file. You see that we have multiply here, but not divide. So let's bring back divide again. Go back to here, click run. And there you go. We have divide here too now. But this is something that we don't touch. This just comes underneath the hood with any editor that we use. And in a few videos, we're going to show you how this also happens when we use something like PyCharm. This is just something that editors allow us to do just so our programs can run faster. So I now have access, let's make this a little bit smaller. I now have access to utility. And here's the interesting part. If I do dot here, look at that. I have access to divide and multiply so that I can multiply numbers, let's say 2 and 3, click run. And I'm able to use the utility module in my main file. Very, very cool. If I do divide and I click run, I can use this as well. Very, very cool. And I can import as many times as I want. If I had a different file in here and I want to import another thing, let's say there's a utility2 file. Well, I can import that and import as many things as I want and use them across my files. How cool is that? So now we have a way to organize our code and have all these files communicate together. Because in real life, we have big projects. And these big projects are going to be worked on by different teams, different programmers. And we need a way to work with all these files. And by using the import statements between modules, we're able to use functionality, just like we were able to use the functionality that functions provided us between different files. And most of the time, if you're working at a company, the first couple of lines on a .py file are usually import statements because usually you're communicating with other files. Let's learn some more in the next video. Welcome back. Up until now, we've talked about Sublime Text and Visual Studio Code. Code editors that we had to install a bunch of plugins and extensions in order to customize it to what we want. And they work really well with a ton of different programming languages. The next one, though, is an IDE, and it's called PyCharm. And it's probably the most popular tool for Python developers. So I really, really like it. But it's an IDE. That is, unlike a code editor, it already comes pre-built with a lot of things. This company, JetBrains, makes it, and they focus purely on Python developers. So that is, if you're a Python developer, they really focus and make sure that all the tools you need to succeed are in here. Now, when you click on download now, you have two versions. The professional one, which you have to pay for, and the community one. So just download the community one. The professional one just comes with a few extra features that we don't really need. So download the community one. Just a heads up, it's a lot bigger. It's 315 megabytes. So again, it comes with a lot more tools for us to use. So it is a little bit heavier than Visual Studio Code or Sublime Text. But if you're a Python developer and you just want an environment where you can do everything in one place, PyCharm is the way to go. Now let's fast forward through this so that we're not waiting around for the download. Whew. All right. That was a long pause for me, but for you, with some editing, this should have been quick. All right. If I open this up now, again, if you're on Windows or if you're on Mac, installation process will be different. In our case, because we are on a Mac, I just drag this to application. With Windows, you'll probably go through an installer. All right, it's all installed. Now, if I double click, PyCharm is going to open up for me. And we'll just make sure we allow it. Now, in my case, I had already a previous version of PyCharm that I've been using. And you might want to import your previous setting. But in our case, we've never used PyCharm before. And also, most likely you want a fresh install. So even if you get this type of pop-up, you can just click on Do Not Import Settings so you get a fresh slate. We're going to click OK. And there we have it. And right away, you can see that, well, it gives us a lot of options. Let's just say I've never used PyCharm before. And next, we get to choose our UI. Do we want Dracula, which is dark, or do we want light? Let's go with dark for now. So I'm going to skip the remaining and set defaults. So in PyCharm now, we can create a new project. Now in here, it asks us where we want to create our project. In my case, we can just leave it over here. We'll call it my project. And before we click create, make sure that you click on this project interpreter and double check that our base interpreter is using Python 3. Remember, if you're on a Mac or Linux, you might have Python 2 already installed. In our case, we installed our Python version 3.7 right here. So we make sure that this latest version of Python is what's being used as the interpreter. Now we can just click create, and our project is going to start for us. We can close these tips. Every once in a while you get tip of the day. Because this is an IDE, you get a lot of features that you can read about online. So it might take you a while to get used to PyCharm, but it is a very powerful tool. Let's make this a little bit bigger. Now, with my project here, I can right-click, say New, and then select File. Our file, we'll just call it hi.py. Click OK. And there we go. We have our first file opened up, and we can just, once again, say print. Now, this is definitely way too small. So I'm going to go to PyCharm, Preferences, and here it gives you a ton of options to customize PyCharm to your liking. In my case, I want to make sure that I use, let's say, a custom font, but definitely increase the size to, let's go with 18. How's that? Let's apply. That's better. You know what? I want even bigger. Let's do 20. I'm going to hit OK. All right, this side is now bigger. That's great. We can see it, but this is still tiny. I want this a little bit bigger, so let's fix that as well. We can fix this easily by pressing Command and then using the mouse wheel if you have a mouse, or using 2 fingers and zooming in. Like so. If you're on a Windows machine, it'll be Control instead of Command, and just zooming in and out as you like. Now, the interesting thing here with PyCharm, I know we have a ton of things that we might not be familiar with right now, but the key thing is that Python 3.7 is running our project. And if we type something like print, hey, we get a ton of interesting things. First, we get a typo saying, hey, this whole hey is not an English word. If I add spaces, look at that. It even gives me typos of English words. But then I also have this yellow curly bracket or squiggly line. And it tells me pip8, no new line at the end of the file. This is something that we're going to talk about shortly when we talk about formatting our code. But if I add a new line, look at that. Everything is working smoothly. I get a nice little check mark. Now I can run this code by going to Run and then clicking Run. And you can see the shortcut command here as well. If I run this, ask me, hey, what do you want to run? Well, I want to run the new hi Python file. I click on this and look at that. Let's make this a little bit bigger. That's better. we see that our file is being run. The process finished with exit code 0. 0 is a good sign. It means there were no errors and everything is great. Now, if we make an error here, and let's say I miss my brackets and I hit run, or I can just click on run here. Look at that. It gives me an error saying, hey, syntax error. Unexpected EOF while parsing, and tells you something went wrong. So once again, I can fix it, run my code, and everything is good. There are a lot of features here that you can explore on your own, get comfortable with it. PyCharm is definitely a great IDE. And the beauty is that unlike Sublime Text or Visual Studio Code, where we had to install all these packages, PyCharm comes, well, with everything built in. It's an IDE. We don't have to install any of these packages. This environment is already set up for us to work professionally with Python because it is made for Python developers. I'll see you in the next one. Bye-bye. Welcome back. We just learned about modules, but let's say our project is getting even bigger. We have this main file, we have some utility, but let's say that we're now working for Microsoft and we have a new, let's say, shopping functionality, an entire, let's say, shopping area where you can buy Microsoft t-shirts. Well, we can now create a folder, so we can add folders to our project. And inside of this folder, let's say we have a new file, and we'll call this the shopping cart.py. So now this shopping cart.py is a folder in our project. You see that our project is getting bigger and bigger. And let's say that here we just have a function called buy, and we give it an item. And let's say here we have a cart variable that, let's say, adds. It's not a very sophisticated buying system, but for our example, it should be fine. And then we just return the cart. Now in here, we have this buy function. And let's say in our main file, so up here, we want to also import our shopping cart buy function. How can we do that? Well, if we try to do shopping cart like this, remember that's the name of our file. You see that I get an underline. It says imported but unused. Okay, so does that mean I can use it? Let's see. I'm going to say shopping cart, and if I click run, module not found error. No module named shopping cart. You see, what we've created here is what we call a package. A package is simply a folder. And we learned about module, which is these files, these Python files. A package is a level up. A package is a folder containing modules. So you can have a package with multiple modules inside of them. So this shopping cart is a module, but this shopping is a package. So the way it works when we import from a package is we say the package name. So what's the package name? It's shopping. And then we do a dot. So dot shopping cart. So package name and then the module name. Now if we do this, let's see if this works. Let's say I do shopping dot shopping cart now. If I print this, let's make this a little bit smaller. All right. Now I have access to the shopping cart module by importing the package shopping, which is the folder, and then the shopping cart. And you notice once again, we have a PyCache that was created for the shopping cart. So let's see if we can use the buy function. So I'm going to say buy, and then item, I'll say I'm buying just an apple. If I click run, there you go. I get my apple list, and I was able to import it from a package. Now, here's the thing. I want to try and copy what we've just done into a real life scenario. Instead of using this website, repl.it, let's actually create our own project. I'm going to use PyCharm, and I recommend you use PyCharm as well, just for these next couple of videos. Let's open up PyCharm, and let's just create a new project here. Now we can call it whatever we want. So let's just call it modules for now for our project. You can see where it's being saved. And remember here, we get to pick what interpreter we want. We're going to talk about this virtual env later on in the videos, but the key thing is to make sure that our base interpreter is using Python 3. In my case, the Python 3 that we've downloaded in user local bin. If you're on a Mac or Linux, if you're on Windows, this path will probably be different. Now we can just create a project. And we see here we have our modules project. Now we're going to ignore all of these folders for now. We're going to talk about them later on. The key here is that we want to create a new file. I'm going to just right click here and say new Python file. And we can just call it, let's say, main.py. And notice here that I created in a folder called venv. We'll get back to that shortly. Now let's make this a little bit bigger so we can see. And we're going to copy whatever we've just done here. So I'm going to copy the main file like this. Oh, that did not copy. Let's try that again. Like that. And then we're also going to create a few more files. So we'll create a folder. So in here, I'm just going to say right click, say new. And right away, you see that it says Python package. I'm going to click on Python package, or I can create a directory if I want as well. And when I click here, let's name the package like we've done here as shopping. All right, we get our shopping folder. And in here, let's right click, say new file, and we'll call this the shopping cart.py. So shopping cart.py. And then finally, we'll add our utility file. I know we're doing a lot, but hey, I'm trying to prove a point here. Trust me, this is going to be important. So utility.py. There we go. So we have the same setup that we have here. Let me copy this over as well. All right. And we copy. Let's make this bigger like that. All right. So we have our files just like we have in our REPL, except this time we're actually using an IDE. Now, the reason I wanted to transfer over to the IDE is that there's an extra file here that we didn't see in the REPL. And the REPL actually hides this away from us. You see this underscore init.py file, and it's completely empty. There's nothing in here. One of the rules of a package, of a Python package, is that on the root of this package, you have to have an underscore init __.py. Now, why is that? Well, because the interpreter is going to read this and say, oh, this is a Python package. Remember how when I right-clicked here, I said new, and then I had an option of a directory or a Python package? By clicking Python package, it automatically added this init for us. So although here everything worked without a init, this is just something that REPL hides underneath the hood. Anytime you want to create a package, you'll see that we need to have an init file. And it can just be completely empty. Now, the beauty here with PyCharm is that it does it for you, which is really, really nice. Okay, so let's run this code and make sure that it still works. So this is our main.py. I can simply run the code here by going to run and then selecting run. Let's run our main file. Oop, and we get an error. Let's zoom in here. And we see that module shopping.shoppingcart has no attribute by. And that is because we did not import the buy function here. So let's do that. Let's go to shopping cart, buy. Make sure I copy that, paste it in. Let's zoom that in. And by the way, I'm zooming here on my touchpad. I can just use 2 fingers to zoom in here. If I click run again, and this time once you ran it once, you can just click on run again. And there we have it. We have Apple right here as the output. And it says process finished with exit code 0. In programming, when something exits with code 0, it means there were no errors. If you get 1, well, that's usually an error. All right, so we have everything working, and this is now our setup. We have our main file. We have our other modules like utility. And then we also have our packages, and they're packages because they have this init file, and we have different modules in them. And as projects get bigger and bigger, and we use IDEs like PyCharm, we organize our functionality, our grouping, into these packages and modules. And really, really good developers are able to organize code in really nice packages that make sense, really nice modules that make sense. This is a skill that is really hard to teach. It just comes with practice, by looking at other people's projects, by working on projects. But the key thing is that you want to do what makes sense. And when we start working on some of our final projects, we have over 10 projects coming up that we're going to work on. Now, with those ones, you're going to start to learn different ways to organize code as you follow along. So don't worry. Let's take a break and explore modules a little bit more in the next video. Let's learn about different ways that we can actually import these modules. Up until now, we've only learned about import. But sometimes things can get pretty hectic. For example, we can actually have another package inside of another package. If, for example, I create a new folder here and say new Python package, we'll call this more shopping. Click OK. You see that I've initiated another package inside of a package that has its own init file. And let's move this now to, let's do refactor, move, and we'll move it inside of the more shopping folder. So I'll say more shopping. If I click OK, you'll see that I've moved this module over here. So I have a package inside of a package. And the way we would access this is to say simply shopping dot more shopping dot shopping cart. And let's copy that over and do the same here. And now when I click run, you'll see that it still works. But this is getting a little bit too crazy. You can imagine as we have more and more packages that we constantly have to do this dot, and this is getting a little too long and ugly. So how can we better this? Well, one way of doing this in a cleaner fashion is to do something like this. Instead of saying import, we say from this part, I want to import the function. So here I'm saying, hey, from package name module, import whatever function I want. In our case, we want to import the buy function. So you see here, I can just do that. And in my code, I can just run buy as if it was part of this main file. If I run this, you'll see that it still works. Awesome. So that's definitely cleaner. And we can do this with utility as well. I can say from utility, import, and actually import the 2 files or the 2 functions. So that is multiply. And if we want another function, we can just add a comma and say divide. So now we can print apple or buy apple as well as divide. Let's say 5 by 2. And we can also multiply. Oh, and make sure it's a comma here because it is a function like this. So that if I run this, you'll see that there we go. This works as well. So this is a really nice way to clean up your code. You can also do something like this, where you say from package name, and then import the entire module. So let's say I want to import the shopping cart module. I can say import, so package.package, or you could have just have done one package, and import the actual module shopping cart. So now I would access it like this, shopping cart.buy. And this is going to work as well. Perfect. Now, the reason you might want to do this instead of what we had before is that sometimes you can get name collisions. Let me show you. Let's say I had a print, and then in here we use the max function, which gives us, it's a built-in function, we give it an iterator, and it finds the max for us. So that if I run this, you'll see that the max in this list is 3. Well, imagine in our utility function, we have a, let's say instead of divide, or we add a max that simply says, returns an oops. Well, if I go back to my main.py and get max as my function, and I click run, well, you see I get an error. I get max takes 0 positional arguments, but 1 was given. Because now max doesn't mean what we thought we meant, at least in this file. We've imported max, and well, max is a whole different function now. So we can actually override existing functions. So by using something like this, shopping cart, we make sure that we have only one case that we might have name collision, but all the properties or all the methods that shopping cart has are connected to shopping cart. So instead of having multiple functions that could be overridden, I only have one namespace. And by the way, this is also one of the reasons that I don't recommend doing something like this. You can actually do import star. And what this says is, hey, from the utility module, import everything. And when you do that, you'll see that once again, we get an error because it imports the max as well. And because we don't even know what's being imported right now, we can't see it. We have to go to the file to see it. When we get an error like this, we're going to be like, what's going on? I thought max is working. And it's because of this line. So it's always good to be explicit and say exactly what you want to import. But let's remove max for now. But as you can see, modules can be imported in different ways. My recommendation is to always be explicit and say exactly what you want to import. And the format usually follows either using the import statement followed by the package.module or import the module. Or you can do the from statement to give it package, subpackage, and module if you want. Or you can do module and then saying import and the specific function or the actual module itself. Many ways of doing it depending on your need. The key takeaway here is that modules and packages help us have good engineering practices and build big projects in an organized fashion, yet still have all these files talk to each other. All right, that was a lot. Let's learn more in the next video.